Master the essential tools for modern C++ development with this comprehensive course that covers environment setup across Windows, Linux, macOS, and Docker. Learn how to configure CMake and vcpkg to streamline your build process and dependency management while exploring online compilation tools like Compiler Explorer. Discover how to effectively use Git for version control in your C++ projects and leverage GitHub Copilot's AI capabilities to boost your productivity. Daniel from LearnQT Guide developed this course.
Hello there and welcome. If you are serious about modern C++ development and want to leverage latest features like C++20, C++23, coroutines, concepts, modules, ranges, and beyond, you are in the right place. This course is all about having a solid professional-grade development environment. It's actually part of our latest course on C++23 fundamentals with projects and algorithms, but don't worry, you don't need to take that course to benefit from this one. Whether you're following another course or working on your own projects, this setup is going to serve you well. Setting up a proper C++ environment is one of the biggest hurdles for new and even experienced developers. But in this course, I'm going to take all the guesswork out of it. You'll get a step-by-step guide to setting up a powerful cross-platform C++ dev environment on Windows, Linux, and macOS, even with Docker and Compiler Explorer for cloud-based development. We'll cover all the essential tools: CMake, vcpkg, VS Code, Ninja, Git, everything you need to build and run modern C++ projects smoothly. And on top of that, I'll show you how to supercharge your workflow with GitHub Copilot, bringing AI-powered coding assistance right into your projects. With over 5 hours of hands-on guidance, this course ensures that you're not just setting up an environment. You're building a foundation for professional, high-performance C++ development. The source code and setup files are available in the description, so you can follow along easily. Timestamps are also provided, so if you are looking for a specific setup like Windows, Linux, or Docker, you can jump straight to it. But I highly recommend watching the entire course to get the full picture of how top-notch modern C++ is used in a true cross-platform setting. And if you ever need help, join our Discord server to connect with fellow developers, ask questions, and collaborate. Okay, so let's get started. I would like to welcome you in this chapter where we are going to see how to set up a C++ development environment on different operating systems. One thing I have to say is that this course is designed to give you the ability to develop C++ code for any major desktop operating system. So it doesn't matter if you are on Windows, Mac, or Linux, you should be able to run the code in this course. But depending on which operating system you are on, the steps to set up that environment are going to be a bit different. So if you are on Windows, you should watch the videos for Windows. If you are on Linux, you should watch the videos for Linux. And the same goes for the Mac. So that's the first thing I am going to do here. I will show you different ways to set up a development environment on these operating systems here. But I will do something more. I will show you a way you can set up a containerized environment from which you can develop C++ code without worrying too much about the operating system where you are on. This is going to be using a technology named Docker. You may have heard about it. And this is going to give us an environment in which we have a Linux system. And this Linux system can be interfaced to or talked to from any operating system where you have Docker installed. So you may have Docker installed on Windows, you may have it installed on Linux, you may have it installed on a Mac. And if you have Docker installed, I will show you a Docker container or a Docker image you can download and use on your system and talk to this C++ development environment. One good thing about this is that if you have a Visual Studio Code installed on the host system, you can tell Visual Studio Code to compile and run code in this Docker container. And another thing is that this Docker container is going to have everything installed, so you don't have to worry about setting up the compilers and all other things we need to do C++ development here. I am getting ahead of myself here, but I know that this is something cool, and it is going to be good, especially for people on the Mac, because the default compiler on Mac, which is Appleclang, doesn't really go well when it comes to using the latest C++ standards. So Docker is going to be a good addition if you are following this course on a Mac. Another thing I am going to show you is how to use an online compiler. An online compiler is something you open up in a browser and type some C++ code and hit some button. You are going to run C++ code. Another good benefit of these kinds of environments is that you have an easy way to switch between different compilers to compile C++ code. You may not know what a compiler is, but it is something you pass your code to so that it can be compiled in a way that it is going to be running on your computer here. We are going to learn about all these things here. Another thing I am going to do in this chapter is help you understand the basic project and the things that make up your C++ project. There are a couple of files that you will be dealing with, and you will understand what each of these files does. Now, one thing that makes this course special is that you will start using the tools that the professionals use. And these tools may seem intimidating at first, but if you go through this chapter and have a good environment, you will have done something that 70% of C++ developers who are learning don't do, and that's going to set you up for success if you really want to become a serious C++ developer. So if you are on Windows, watch the videos for Windows. That's what I want you to do here. And if you have the time, if you have some effort to spare, make sure you set up Docker on your system, because that's going to give you another environment. The Docker container I provide is going to be containing a bunch of tools that really help you in writing C++ code. And another benefit is that I will be updating this container as new compilers get released. It is going to be ready to help you use modern C++. So that's what we are up against in this video. I am going to head over in the next one and show you how to set up an environment on Windows, and you will be able to use C++ in no time. I am going to stop here and I will see you there. In this video, we are going to see how to set up a C++ development on a Windows operating system, and you should watch this video if you plan to follow the course using Windows. Windows is actually one of the best operating systems to do C++ on, especially if you want to do modern C++, because the default compiler on Windows is really working well and hard to try and keep up with development when it comes to C++. On Windows, we will do a couple of things to have a good and ready environment. I have to warn you, this is going to seem like a lot because we will be installing the tools that the professionals use for C++ development. The first thing you install is a compiler. And a compiler is something that is going to take the code you write. Suppose you are writing the code in an editor, in a text file that you are typing something. The compiler is something that is going to take this code and turn that into a form. So it is going to do something, and it is going to turn this code into a form that you can run on a computer. So this is going to be loaded in the CPU of a computer, and you can run the program and see it do things. So for example, I am using the PDF application to show you the slide here. That's an application on my system. I have a binary file. If I double click on it, PDF is going to open up and I am going to be able to do things. So a compiler is something that is going to give you that file that you can double click on to run it and have things done in your C++ program. What I am trying to say is that a compiler is an important part of C++ development, and we will install one in this video here. That's going to be the Visual C++ compiler. The name is cl.exe. This is what you call to compile your C++ code, and it is going to come as part of the Visual Studio IDE. I have to say that the Visual Studio, the IDE, is different from Visual Studio Code. The names are a bit similar, but these are different things. Visual Studio, the IDE, is a powerful IDE that Microsoft provides. You can use it to do C++, but the drawback it has is that it is so tied to Windows. It is only useful if you plan to do your C++ development on Windows, and this course is designed in a way that you can run your code anywhere. So we won't be using this IDE. but we will use the compiler that comes with it to compile our C++ code. What we will use to type our code is Visual Studio Code, which is another powerful editor that they provide. It supports multiple languages and you can use it on any system. That's why this is a good choice. You can use it on Windows, Linux, and Mac, and it is going to look and feel the same. The first thing we need is the compiler, and we will install it. After that, we will install CMake, which is a tool that helps us take a bunch of files that we have in our project and put them together to compile them in a unified way and get the binary executable that we can execute on your computer. This is a powerful tool. Now you don't have to know too much about it. What we need is just to know that it should be there, and we will have files specific to it in our C++ project. We will also install vcpkg. This is something that is going to make it easy for us to bring third-party dependencies in our application. You can think that this is our application, but there are thousands of libraries out there that you may need to download and use in your application. vcpkg is going to be the thing that makes that easy. So I can tell vcpkg I want to use the fmt library, which is a powerful library for logging and printing stuff in modern C++. I can say I want fmt, and I will say that through vcpkg, and vcpkg is going to download those and make sure that they are available on the system. Then I will be using CMake to grab them and pack them into my binary, which is going to be much more powerful. This is going to give me the ability to use thousands of libraries that have been written by other smart people, and I can take advantage of them in my C++ project. This is one of the big benefits you will get from going through this course. You will be able to use third-party libraries from the go, and you can write much more powerful programs in this course here. We will also install Ninja, which is a tool that is going to be building our program. Don't worry too much about this. We will also install Visual Studio Code, which is the editor we will be typing things on. Now that you know this, I think we can go on and start installing these things here. I have another article I have written, which is going to give you specific steps you can follow to follow up with what I am doing in the course here. I think you can get a link to that if you go into the course. So let's go there. Let's make sure. If you open the course and go in environment setup, I think I have a resource. Let's increase the size here so that you can see what is happening. If you go to environment setup and go in the first video there, you will have a resources link, and this is going to point you to a GitHub repository for the code in this course here. I want you to come into environment setup. That's where we are here. If you go in here, you will have a bunch of articles written that are going to help you do things. If you are on Windows, you should follow this. If you are on Linux, you should follow this. If you are on a Mac, you should follow this. You should follow whatever is specific to what you want to install here. So we want to follow up with Windows. That's what I am going to open here. And this is going to give us steps to follow to set up a modern C++ development environment on Windows. The first thing you need to install is the Visual Studio, which is the IDE. So download and install Visual Studio. Let's increase the size so that this is really visible. If you click on this link, I think I shouldn't open that immediately, but I can right click and open it in another tab so that I keep that tab around. So what I want you to do is to download the Visual Studio, and you can download the community version. You can get the professional version. I think most of you guys are going to be using the community version because this is free. So download this and install the file you have. And another thing you need to be careful about is that as you start installing, you should look for desktop development with C++. I think we can even try to do that together. So I am going to download this file and wait for it to come. It is going to start downloading on my system. You see it is downloading here. If I show in folder, I will open my download folder. I am going to double click on this and give this a chance to start installing on my system here. And I am going to allow it to execute. So let's click continue on this screen, and it is going to do whatever it needs to do. Give it a second. This is going to take some time depending on the speed of your internet connection. Because I already have it installed, it is going to say that it wants to update what I have here. So let's give this a second. At this point, it has downloaded and installed the update for me, But for you, it is probably going to say that it is going to be installing some things. I want you to see something that you should choose. So for me, I am going to click modify here. But what you should choose is desktop development for C++ if given that option here. You see that it is checked and it is already installed for me. So I'm not going to install, but you should select this and choose whatever the button here says. It should say install or whatever, or download. Download and install this and wait for everything to be set up. After it is set up, you will have Visual Studio installed on your system, and you should be able to go to the start menu and say Visual Studio, and it is going to show you whatever version of Visual Studio you have installed. In this case, I have a Visual Studio 2022, and if you click on that, it is going to start a Visual Studio on your system. So let's say Visual Studio again, and if we run it, I am going to give this a second. It is going to show up. It is going to open a Visual Studio window. So if you see something like this, it means that you have a Visual Studio installed. Let's go back to the article and see something we can do next. So we have downloaded and installed Visual Studio, and we have chosen desktop development with C++. We can open Visual Studio and see it opening up. Now we have to confirm that we have the compiler installed on our system. What we need to do is to follow these steps here. So go to the start menu and type Visual Studio. If you do that, no, not Visual Studio, type developer. That's what the instructions say. And if you do that, you will have two options. One is going to be developer shell for Visual Studio, whatever version you have installed. The other one is going to be developer prompt. These are different ways to do the same thing. But if you want to do things in a modern way, you should use PowerShell. It is much more powerful. So that's what I am going to choose here. Again, I am going to say developer and choose developer PowerShell for Visual Studio 2022. If I do that, you see that this is going to be opening PowerShell for me. It is the window you see here. Inside of it, I want you to type cl.exe. If you do that, it is going to show whatever version of Visual Studio that you have installed. In my case, it is reporting this version. If you see anything like this printed, it means that you have Visual Studio and the compiler that comes with it installed in your system. This is the first step you need to do if you want to install a C++ development on Windows. The second thing we are going to be installed is CMake. You can see CMake is essential for building C++ projects. We can download and install it through the official site. So go there. And I think I should turn this bright so that it is much more visible. So let's make this bright again. And if you go to download, you can click the download button. It is going to show you whatever versions are available for downloading CMake. You see they have a release candidate, which is CMake 4.0.0, but we wanted to use the latest release, the stable version that we can get our hands on here. So we are going to be using CMake 3.31.6 at this point. Choose whatever latest release you have at the time when you are watching this video here. We can go down and choose binary distributions, and now I am on a Windows machine, so I am going to choose Windows x64 because that's the system I am on. I am going to click on this link. This is going to download the installer, and I am going to wait for it to download. It is going to take a few seconds on my system here. And I should turn this back to dark because this is hurting my eyes. The download is done. I can go in my download folder. If I go there, you should have a file like this downloaded on your system. If you double click on it, it is going to start the install process, and it is going to be installing CMake on your system here. I am not going to do that because I already have a CMake installed, so I am going to cancel out of this. But I am going to show you where CMake is installed on my system. So I think it is in C program files. And if we go in CMake, we have a CMake folder. If I go inside, I have a bunch of folders as you see here, bin, doc, man, and share. If you go in bin, you will see the binaries that make up CMake here. This is my CMake binary that I can call to do things. And we have a bunch of other CMake binaries that we don't care about at this point in the course here. The first thing I want you to do after you have CMake installed is to add it in your environment variables. I think they even say that in the article here. So once you have a CMake installed, you need to add it to your path during installation. We are going to do this manually. Let's go to the location where we have a CMake installed again. So that's what we have here. I can go to the top here and copy this path. You can see that for me, I need to make sure you see all these things here. For me, it is saying C program files CMake bin. This is the location where CMake is installed on my system. I am going to grab this path and copy it. Then I am going to go to the start menu and say environment variables. There are many ways to set up environment variables, but this is how I like to do it. You can go to the start menu and say environment variables, and if you start to do that, you will see the option to edit the system environment variables as you see here. I am going to choose that option, so I am going to go there again and say environment variables. If I click on that, it is going to give me this window here. I am going to go down and select environment variables. So click on that and choose the path variable in system variables. This is what I like to do. So this is the path here. I am going to double click on that and we will see a bunch of paths that are displayed in this window here. I want you to add the path where you installed the CMake in this list here. You can see that I have it now. And if you don't have it, what you can do is just say new and then paste that path that you have in your clipboard here. This is going to be adding CMake to the environment variables. And I want to move this a bit up so that this becomes your best CMake version installed that you use here. I am going to take this out because I already have it here. If you want to move it up, you can just say move up and you see that it is going to go up. But again, I am going to delete it because I already had it. I don't need a duplicate of this in my environment variables here. Once you have it in, you should click OK and click OK again and click OK. And how do you confirm that you have a CMake properly installed? You can go to any terminal or any PowerShell window. In my case, you can go to the start menu and say CMD. This is going to be opening a terminal window on your system. If you say CMake version, I think I can increase the size of this so that everybody can see. If you type CMake -- version, it should report whatever version of CMake you have installed. You can see that the version I'm using on Windows is slightly older than what we found on the website for CMake, but that's okay. You can use any version as long as it's better than 3.32 as we have here. You are going to be fine with whatever we are going to do with the course here. But regardless, I recommend you install the latest version you get from the CMake website here. Now we have completed the step to install CMake. We are going to move on to the next piece of software we need. This is going to be Ninja. And Ninja is a fast build system used with CMake. There are many ways to install this, but I really like to use the WinLibs version. This is a guy who is kind enough to maintain a bunch of compilers that you can use on Windows. He has GCC and Clang. And I am going to show you how to use Ninja from this location here. But I have to say that there are 1,000 ways you can get access to the Ninja binary. So what we want to do is to go to the download section. Again, I think I should turn this bright a little bit so that you can see a bit better. So we are going to go to the release versions here, and you see that they offer a bunch of versions. So let's see, there is something I want you to see here. You see we have UCRT runtime, and if you go down, they have MSVCRT runtime. So you may be wondering, which one do I choose here? I think he has an explanation. So MSVCRT or UCRT, they say unless you are targeting older versions of Windows, UCRT is a better choice. So I want you to download UCRT. You see that it is even the first one they provide here. Another choice you need to make is whether you get one without Clang LLVM or one with it. I would recommend to get the one with it, which is the first one here. And I am developing for 64-bit Windows, so I am going to be downloading one of these here. So let's go down and grab whatever version we need. And what is the difference between the one we have on top here and what we have down here? The differences are in the versions of Clang that they have. You see that the second one here is using 19.11. The other one is using 19.17. We want to get the latest version, so I would recommend you download the zip archive for 64-bit if you are on a 64-bit Windows system and get the zip archive here, you are going to click download and it is going to be downloaded on your system. So let's give this a second. Okay, the download is good. I can open this in the folder and my downloads folder is going to pop up, and you see that I have a zipped file which contains the things that I just downloaded here. If I click on it, if I double click, of course, to be able to do this, you need to have some kind of zip archive application. I am using WinRAR. If you don't have it, you should install it. But I am going to extract this somewhere on my system. And by extracting, I mean you take this, you copy and paste it somewhere on your system. In my case, I like to install this in my C drive. So I am going to open another file explorer window and go to my C drive. You see where I put this. So you go to C and then you put it somewhere where the name is Minji W64. So what I basically did, I extracted this and then copied this and pasted this in my C drive. That's also what I want you to do. And this means that you have these things installed here. So I am going to assume that you copied what is inside this folder and put that in your C drive, and you will have an environment exactly like I have on my system. Once you have this done, you can go inside this folder and you will have a bin folder in which you have a bunch of tools that you can do to do C++ development. This is going to be very useful if you are on Windows because it will give you access to the GCC compiler and the Clang compiler. How do we get the GCC compiler? The GCC compiler is installed because we have access to its binaries. If you go down, you see that we have G++ here and the GCC. These are C compilers, C and C++ compilers that you have on Windows. You can use them to do things. But we also have access to the Clang compiler. You can see that we have Clang and Clang++, and we can use them to do things. But the main reason I downloaded this in this course is that we also have access to a bunch of tools that help us do C++ development. One of those tools is Ninja, and I can just, let's browse through this, and we should have a Ninja somewhere. We have Ninja here. This is the tool I want you to have access to. It is going to help you build C++ programs. Now that we have this, we also need to add this to our environment variables so that we have access to this. Again, you will follow the same steps. You are going to copy the path where we have these tools installed. In this case, it is CMake W64 bin. So copy this path, put it on your clipboard, and go back to your environment variables. You already know how to do this. So we go there and choose environment variables again. And we want to go to the path in our system environment variables. I am going to double click on this, or you can even hit edit. It is going to do the same thing. And make sure that you have that in place. I think I already have that in place. Let's look. You see the path is here. But again, if you don't have it, you can click on new and paste that in here. And hit OK. It is going to be available, ready to use. But I am going to go back and take it out because it is a duplicate. So I have it here and I have it on top. Let's expand this and make sure I can see the other one that I have, which is the same. You can see I have it here. And here it is the same. So I am going to delete the second one that I just added by hitting the delete button while I have it selected. And then I am going to click OK. Once you make sure that you have this in place, and click OK again and click OK. So what we need to do after we do this is to open another terminal window and make sure that we have access to the Ninja binary. So this is basically what the guide here is saying. So let's go and open a new terminal window. I can go to the start menu and say CMD. And if a terminal window opens, I can increase the size of it and say Ninja -- version. If I see a version printed, this means that I have Ninja installed on my system and I can use it to do things. Now we have this Ninja tool installed. The other thing I want you to install to have a professional environment in which you can do C++ is Git. Git is a popular version control system used by many developers. It is going to allow you to control changes in your application. If you have a file and make changes and then you come tomorrow, you do other changes, Git is going to help you keep track of the changes that you do through your application here. I'm not going to say a lot about it, so I am going to take you to the official Git website, and you can download it for whatever system you are on. In this case, you are going to download and install for Windows. Choose the defaults that you see. It is not going to matter too much. After you have it installed, you should also be able to go to any terminal on your system and type git and get the git version printed out here. So this is a standard installation on Windows. Again, you can go to the terminal. In this case, I am going to use PowerShell. I have a shortcut on my system here that I can click on to have a PowerShell window. So I am going to use that starting from now. So if I do ++ to increase the size, I can say git. And if I print the version, it is going to show up. It doesn't matter which version you have, it is going to do for the course. Now you have Git installed. We can go down and do some configuration as shown here. If it is the first time you use Git, this is going to allow you to configure your name and your email. So if you make any change, Git is going to store information about who made the change to that file, because it is possible that you may be working on a project as a team. So person 1 is going to be changing the file, person 2 is going to be changing the file, and person 3 is going to be changing the file. And Git is going to be using this information to say who has made any change to the file here. That's why you need to do this. So just copy these commands and use them in your terminal. I think I can even minimize this and open another terminal window. So what I can do on Windows, I want these things to show up side by side here. So I am going to put this one on the left and bring my PowerShell window to the right. Then we can go down and run these commands here. I have already done that. So I can just confirm my name. I am not going to show you my email because that's confidential. So I am going to show you my name because you already know it. So if I run this command, it is going to say the name of the person who's running Git on this system here. This is going to confirm that you have Git installed. So we also need to install vcpkg, and this is going to be installed through Git. vcpkg is a package manager for C++. I have told you that before. You can use it to download third-party dependencies. And to install it, I am going to be installing this in the C drive again. So what you want to do is to go to the C drive of your computer. I can get there in the terminal just by going to the top here. So let's cd, and if I do dir, this is going to put me in the C drive. You can see that here. I think I can even do pwd to show me the location where I am in this terminal here. Once you have this, again, confirm that you have access to the Git because we are about to use that. And just download vcpkg using the command here. So you are going to copy it and put it on your system. So we can copy it. In the guide, you can even use the copy command here and put this on your system. This is going to download. For you, it is going to be downloading this if you don't have vcpkg installed. But for me, it is saying vcpkg is already installed, so I don't need to install it here. But after you have it installed, you need to cd into the vcpkg folder, which is going to be created by the previous command that we just run. If you go in there, you can do ls to see the files that make up your vcpkg installation. And one of the files that you are going to see is a bootstrap file. For Windows, you can use the bat file here. For Linux or Mac, you should use the shell file that we have here. I want you to run that file. Again, you can run that using this command that you have here. So you can copy it and paste it here. If you do that, this is going to make sure that vcpkg is installed and configured on your system. Now it should confirm that you have vcpkg installed. You can confirm that you have it in this folder by doing ls. If you run the ls command, it is going to show you that you have a vcpkg binary that you can run. And we can run it by saying vcpkg, let's say dot and backslash, and then say vcpkg. If I start typing and hit tab, this is going to be auto-completing. And if I run this, it is going to give me options. But another thing I can do, I can hit the app button to bring up the history and then say -- version. This is going to be printing the version of vcpkg I have installed. You can see that my version is a bit older. I installed this last year. We are in 2025, but this is going to do for what we want to do here. So this is okay. Just make sure that you can see any version. This means that you have vcpkg installed in your system. Another thing I want you to do is to add a vcpkg to your environment variables. So what I can do is to go to the C drive of my computer where I have a vcpkg, And I am going to go to the VC package folder, which is right here. Let's make sure everybody can see it. And then I am going to go inside and confirm that that's where I have the VC package binary. You can see it here. We just looked at it on the terminal. Now I am going to copy this path and add it to our path variable in our environment variables. So I am going to copy this again. I want you to come to environment variables. So this is a bit involved if you are doing this for the first time, but you are going to get used to this. So let's go to environment variables and go to system variables and then go to path. We want to make sure that we have a VC package. I think I already have it. Let's see, do I have VC package in my environment variables? I don't think I do, but we can try that. We can go in any location on our system and let's close this. We can close this and open another terminal. So we are going to open another terminal by clicking on this and increase the size a bit and then say vcpkg -- version and see if this is going to report the version. You can see that it is being found. So I must have it in my environment variables. It's just that I can't seem to find it here. But add it if you want a VC package to be widely available from any terminal here. Once you have it added, you click OK and you click OK. And now this is going to confirm that we have a VC package installed. Another thing I want you to do after you have a VC package installed is to add the VC package root environment variable. This is very important for what we are about to do in the course here. So we will set up an environment variable. It is not going to be the path variable. It is going to be a separate environment variable named VC package root. And it is going to be pointing to the location where we have a VC package installed on our system here. I am going to show you the steps you need to follow to get this done. So open your environment variables window. So let's say environment variables and go to edit system environment variables. We are going to go to environment variables and we are going to go to system variables and we are going to add an environment variable named VC package root. You can see that I already have it and it is pointing to the location where I have a VC package installed. So if you don't have it, you can just click new. In the variable name, you should type VC package root. So you can go here and say that vcpkg _ root. And then in the value, you are going to say C:\VC package. So we can say that here. And you are going to click OK. And your environment variable is going to be added. And you can use it going forward in the course here. This is something I want you to confirm. So once you have it, click OK. I am not going to do that because I already have it. But make sure that this environment variable is available on your system. Okay, once you have it installed, there is a way to confirm that in PowerShell. I am going to say OK. And if you open a PowerShell window and go in any location, you can run this command here. So in PowerShell, you say $env and you pass the environment variable. If you hit enter, it is going to be printing that environment variable. This is something I should have put in this article, but now you know it. So grab this command, hit enter, it should print the location where you have a VC package installed, and this confirms that you have VC package properly installed and configured on your system here. Now we have a bunch of tools installed that we can use to do C++ development. The next thing we need to install is Visual Studio Code. Visual Studio Code is a good editor. It is popular, it is cross-platform, and you can use it for a lot of languages. And we will be using it in this course here. You can download for Windows. They have detected that I am on a Windows machine. But if you go down, I think they will give you options to download for different operating systems here. So I don't know where they put it. This website changes a lot, but you can choose other platforms here, and they will give you different operating systems that you can download for. You can download for any system, but I would recommend using the download button here, which is going to be downloading for your specific operating system. So you are going to download it, install it, and it is going to be available in your system. It is a standard installation. I don't need to do this because I already have it installed on my system here. Let's go back to the article. Okay, once you have a Visual Studio Code installed, you can open it, and I can open it because I have it as in my start menu. If you start it, it is probably going to look like this, and it is going to show the welcome page. So let me try and see if I can show the welcome thing that you are going to see, but it doesn't matter that much. Once you have it installed, it is going to look like this. And now we need to be giving it the ability to do C++. Visual Studio Code doesn't have C++ built in. To give it the ability to process C++, we need to install a bunch of extensions here, and these are going to give it the ability to do C++. To install extensions, you go to the Extensions tab here. So if you click on it, it is going to show a bunch of extensions. For me, it is going to show those I already have installed. But if we go back to our good article, we should see that we have a bunch of extensions that we can install. Now, here you have a choice to make. You can either use the C++ extension from Microsoft, or you can use the Clang tools, which are going to give you a modern way to do things. Either of these options is going to work, but in this course, I am going to be using the Clang tools. I'm not saying that the C++ extension from Microsoft is bad, but you should choose one of these tools. You can't have them both enabled in Visual Studio Code. You can install them, but at any point in time, if you want to do C++, make sure that you have one of these, either the C++ extension from Microsoft, which is going to teach C++ to Visual Studio Code, or the Clang tools. So at any point, we will be using ClangD and CodeLLDB, or using the C++ extension. And in this course, I would recommend you go with Clang tools because that's what I am going to be using here. So let's go to Visual Studio Code and get this done. You can, if you want to use the C++ extension from Microsoft, just search for C++ and hit enter. It should give you C++, and you can see that I even have it installed. It is an extension from Microsoft, and you can install it and use it if you want to go this way here. This is one way to do C++ in Visual Studio Code, but again, I'm not going to be using this in the course. I am going to be using CodeLLDB and the ClangD extension. If you don't plan on using this extension, you can disable it. You see that I already have it disabled. That's why it is telling me enable here, but we will be using CodeLLDB. So let's say CodeLLDB. This is the extension I want you to use. This is the extension here. I already have it installed and activated. It is by Vadim Chugonov. This is the guy who wrote it probably, and you need it enabled. You see that it is very popular. It has been downloaded 8 million times. It has 89 reviews. It is a good extension for C++. And another one that is going to go with this is ClangD. So if you say ClangD, it is going to come up and it is going to give you these things they say here. So C++ compilation, navigation, and insights. It does code compilation and a bunch of things that you need for C++ development. So make sure you have ClangD installed and enabled, and make sure that you have CodeLLDB installed and configured. And I am going to show you a few other extensions that we need. We need the CMake tools extensions, and we need the CMake extension to teach Visual Studio Code to use CMake. So we can say CMake in our extensions tab here. If we do that, we should have a CMake extension by this guy. The name is TWXS. It is a good extension. And again, they tell you what this extension is going to do if you look through here. So install this extension and make sure that it is enabled. And I want you to also install the CMake tools extension from Microsoft. This is going to give you extended CMake support in Visual Studio Code. It is going to make things easy if you want to use CMake within Visual Studio Code. Let's go back to the article and see some other things. There are a bunch of other extensions you may need. One of the extensions that I would recommend is the remote extension, which is going to allow you to use things like Docker. So let's go down and look at the remote extension. If you do, you should have a bunch of options. So we have dev containers. This is a good extension to have. Remote development is going to teach Visual Studio Code to do remote. This is going to allow you to do things like using Docker containers in Visual Studio Code. These are optional, so make sure you put them in if you think you need the things that they will provide. But at this point, we should have a good and ready C++ development environment. At this point, I want you to try and confirm that you have everything that you need to do C++. I am going to try and minimize this and bring up a terminal window. So to confirm that you have things, we need the CL compiler, but to get access to this, we need to use a developer shell. So what I am going to do is to close any terminal that I have, and then go to developer, and I am going to use a PowerShell here, and I am going to put this on the side and make sure that we can see it. So let's expand this a little bit and increase the size. I like to see things in big. So you can say cl.exe to make sure that this compiler is available. If you have output like this, it means that you have the compiler downloaded. You can confirm that you have a CMake. And if you do CMake version, it is going to spit out a CMake version. You should have Ninja. If you do Ninja version, it is going to say the version that you have. You should also have a vcpkg and say version. It is going to spit out a date. This is how vcpkg works. It probably means the time that they built this and pushed this on GitHub, but it doesn't matter. It should spit out a version. Now it means that you have a C++ environment ready for use on Windows. Now that we have the environment ready, I want you to see how you can use it. This video is going to be a bit long, but it is something you need to do if you need to be serious about C++. So if the setup was successful, you can now use one of the template projects as a starting point. We will be using C++ 20 modules. Now, where do you get the template project? The template project is going to be coming from the starter files that you downloaded in the first chapter in the course here. I am going to go where I have them on my system. For me, it is going to be this folder here, course files, and I will have a code live folder, which is going to be containing things that I can use as a starting point in my application here. I am going to make sure that I have a Visual Studio Code opened so I can close anything and go to the top here. You see that it is inviting me to open a folder to start doing things. I am going to be opening a folder that is coming from our starter files. So I am going to go in code live. That's what I want you to do, and go to environment setup. Then I am going to choose a project that I want to use here. I am going to be using the project template for modules. So I am going to drag and drop this on top of Visual Studio Code. If I do that, Visual Studio Code should use the tools that are already available and give me the option to choose a tool to use to build my project here. It is going to detect that I am using CMake because I have a bunch of CMake specific files in my project. Again, don't worry too much. We just want to make sure that we can use our environment here. Just follow what I am doing here. We will take a moment to explain the things that we are doing as we go forward in the course. If that menu goes away, just go to view and do command palette, and then you want to choose CMake select configure preset. If you don't see it, you can just say CMake and then say select, and it is going to come up and you should select it here. Click this and it is going to bring back that menu. And I want you to use Windows CL here because this is going to be using the Visual Studio compiler that we downloaded earlier. If we choose it, we should see a bunch of things happening. You can see that we will have some output in a terminal window here. And if everything went well, you should see a message saying that the build files have been written to a folder on your system. And this folder should be to the path where you have this project opened here. You can see the name of the project at the top in Visual Studio Code. This name should match the name that you see down here in Visual Studio Code. Let's make sure you see it. So you see the name in the top, and this name should match the name that you see here. And it should be saying that the build files have been generated. This is a good message saying that this project is working the way it is supposed to work. Now, once you do this, I want you to build this project and see if we can generate a binary out of it. And to do that again, I want you to go to view and say command palette, and then select CMake build. So you can say CMake if you don't see that, and then say build as you see here. This option is going to show up. You can see it at the top. Click on it, and this is going to start building your project. And if you see a message like this, let's make sure everybody can see it. If you see a message like this saying that exit code is 0, it means that your project has been built, a binary has been generated, and you can run this binary here. I want you to take a moment to watch what happens when you configure and build this project. We configured the project when we selected a configure preset, and we built the project when we did the CMake build. So you should notice these two steps here. When we configured the project, a build folder was generated in our project here. And you can even go to the location where we have the project. So this is our template project. If we go in there, a build folder has been generated. I want you to notice that. And if you go inside, we should have a CL folder. If we go inside, we should have a bunch of files. One of the folders you will see is debug. So go inside this folder and you should see a binary named Rocket. This is a binary that we just generated as a result of building this application here. Now, if everything is good, you should have a binary generated as we have seen. Again, you can confirm that the build was good by hitting build again. This is going to bring the terminal here and say that the build was successful. If you don't see this button, it is down here that I can click on to also build. We have two options to build. We can use this button or go to view command palette and say CMake build as we have done before. Now that we have the binary, we can run it. So we can either hit the run button here and it is going to run our program. At this point, our program is not doing anything, but let's just show you how you can get it to do something. You can go to the main file here and go inside the main function. And I just want you to type what I type here. So we are going to say include and say FMT format. Okay, this is something you can do. And then say FMT print and say hello world here. I should disable these auto completions because they are giving us away. So let's configure code completions and disable completions. This is what we need to do. We can say FMT print and then say hello world here. This is going to print something, and then I am going to say \n. Make sure you type these things I type, and then we can build the project again. We just wanted to say something when we run this application here. This is something you can do if you need to do this in your C++ program. Now that we have this, we can just hit the build button again, or go through view command palette and then say CMake build. All these are going to do the same things. You can see that it should say exit code 0. This means that the build was good. Now a binary containing this code has been generated. It is in our system. It is in our debug folder. Again, you can go in the build folder. Let's go there and make sure you really are familiar with these things. This is our project folder. We go in build. We go in the CL compiler. These are the files that have been generated because we are using the CL compiler to build on Windows here. And the binary has been generated in the debug folder. You see that it is even saying that in our output here. I want you to notice this. This is our folder containing the project, and the name of the folder should show up here. In the output of Visual Studio Code, you see that it is the name that we see starting around here. Make sure you see all these things. Now you can run the application by hitting the run button at the bottom of Visual Studio Code. You can see that right here. So click the run button and it should say hello world in the output. This confirms that you have a working environment. You can compile and run modern C++ code, and this is really cool. Another thing I want you to see is to make things much easier in Visual Studio Code by being able to run things through the run menu. So I want you to be able to go to the run menu and say start debugging or start without debugging. And to get this to work, you need to configure a few things in Visual Studio Code. I promise that this is the last thing we need to do to have a fully working environment on Windows. And if you do this, you will be setting yourself up for success as a C++ developer. So what I want you to do is to come to the debug menu that you see here. So this is the thing we want to go to. If you hover over it, it is going to say run and debug. You can get here by hitting Ctrl-Shift-D. So Visual Studio Code is going to give you a bunch of shortcuts you can use to get to this location here. You see that if I click on this location, it is going to give me this menu. But we can do Ctrl-Shift-D on Windows. So I am going to go back to the Explorer tab that I have on top. Again, the Explorer tab is what you see here. You should know these things. Visual Studio Code is our tool now, and we should know as much as we can about it. So if we go from Explorer tab, I am going to hit Control-Shift-D on my keyboard. You see that it is going to take me there. So you should learn these shortcuts to help you do things faster. I try to remember the shortcuts that makes things go easy for me, but you can use your mouse and go to this location and click on this tab. This is going to show up here. Another thing you see in Visual Studio Code is that if you click on a tab twice, the thing that we have on the left here is going to disappear. This is where you do a lot of things. But if I click again, you see that it is going to go away. So if you want it to go away, you can just click twice and it is going to go away. Click again, it is going to come back. Now, what I want you to do is to look at what is said here. It is going to say to customize, run, and debug, create a launch.json file. This is a file we need to create in our project. I have to say that this file is specific to you, so don't expect to send this file to someone and expect it to work unless they have the same tools and configuration as you. This is your file and you should configure it to work in a way that things are configured on your system. I am going to click on this link that says create a launch.json file. So click on it and a file should be created in your configuration. And I want you to go in these choices that you are given here and choose code LLDB launch. This is what we want to do here. And if we do that, a configuration is going to be created. It created double. So what I need to do is to just take out, we need just one of these. So I am going to go to the first one and remove it. Or let's remove the second one. So I am going to remove the second one. You see that I am going to go to this closing brace and go all the way to the comma. So also take away the comma. So let's take it out. This is our configuration. It is using LLDB. You see that this is the tool we installed in Visual Studio Code. It should say launch here. The name is going to be launch. And what we need to configure here, we need to change one thing. We need to teach this thing to go to the location where our binary was generated. And if we go from the workspace folder, and the workspace folder is the location where you have your project, I think if we go to the terminal down below here, we can even see it. Or we can close all these terminals by hitting the dustbin buttons that we have here. And I am going to view and come to terminal. This is going to open a terminal window. And this terminal window is going to be at the location where I have my project on my system here. I think I can even do pwd in this PowerShell window, and it is going to give me a full path of where my project is located. And this entire path is our workspace folder. This is just a thing that we have in Visual Studio Code that is going to resolve to the location where you have your project in Visual Studio Code. I hope this makes sense. Now, coming from this workspace folder, we need to go to the location where we have our binary. And to go there, we can cd into the build folder. If we do build and do ls, you will see that we will see cl. Make sure you can see these things I do here. If from cl we do ls, we can cd into ls. And if we go in there, we can cd into CL, that's what it is. So if we go in there and do ls, we will see the things that are in there. We can navigate our files using the terminal or the PowerShell window that we have here. One of the things we have in here is the debug folder. So we can go cd and say debug. And if I start typing and hit tab, this is going to autocomplete and make things easier. If I do ls from debug, it is going to say that we have our binary generated. Again, this binary is going to be generated if you hit the build button here. If you don't have it, try to hit the build button and see that you see this binary here. Now, what we really need to do from this debug folder, we can do pwd and see that the location where we have our binary is build cl debug, and inside here we have our binary. We are going to tell Visual Studio Code where to go to look for our binary starting from the workspace folder. And now that we have this information, we can pass this in Visual Studio Code. So from the workspace folder, I want you to go into the build folder. I want you to go into the CL folder. I want you to go into the debug folder, let's say that. And in there, I want you to look for a binary which is named rocket.exe. This is basically what we need to tell Visual Studio Code. It is going to be using this information to run our application every time we come to the run menu and say start debugging or start without debugging. Okay, another thing I should mention is that this file is generated in a .vs code folder in your project. Again, we can even open our Explorer window, go to the location where we have our project. You see that we have a .vs code folder. It is the same folder that you see here. Inside of this folder, we have a launch.json file that we are manipulating here. I want you to connect all these things and really understand what is going on. This is going to pay dividends once you start doing things with C++, as we are about to do in the course here. Now that we have this, we can use it to run our application. So what I want to do is to close this terminal. It has done what it needed to do, and we can go to the main CPP file in the project by clicking on it. And now we can go to run and say start debugging. If we do that, it should run our application, and we should see the output in our terminal tab in Visual Studio Code here, and you see that it has said hello world. If you go to run and say start without debugging, it should also run and say hello world. To confirm that things are working, let's say hello world. We are using modern C++. Okay, we have this. Now that we have changed our application, we can compile and run it again. But if we run it, so let's go to run and say start without debugging, because this is going to run the application right away. And another thing I want you to see and how this is going to be easy to work with is that now that we have a shortcut that we can use to run this application here. If we do Control F5 on the keyboard, this is going to run our application without debugging, but this is working again because we have a launch.json file configured to work exactly as we have things configured in our C++ application here. Now, if I do Control F5, the thing is going to be built again. So we need to build again. We need to build first. We can build by coming to View Command Palette and do CMake build. This is going to rebuild the application. Once we have the binary generated, we can go to run and start without debugging, and it is going to run the application. And you see now that it is saying hello world. This is something really cool that you can do right from the start because we have a good C++ environment set up. This is really cool. The last thing I want you to see is that you can even debug this application here. So I want you to do something. Let's say int value1. Type what I type here. It doesn't matter if you understand or you don't. I just want you to show you a way you can run things slowly in your application. So let's say value2 and give it a value of 20. And I want you to change the application in the way that I am going to show you here. We can say hello. The values are, and just do what I am saying here. Okay, so these are placeholders. We basically want to take the first value and plug it in here, and take the second value and plug that in here. That's something you can do with the FMT library that you are using here. Once you do this, you are going to say a comma and say value1, and say another comma and say value2. And we need to change this to use 1L later. I think this is what we need to do. Once you make sure you type this, I really encourage you to type this to make sure that you can build things on your own. We need to rebuild the project, and to build, we have seen that we can do View, Command Palette, and CMake build. And another thing you can see is that we have a shortcut that we can even use to do this faster. So I can hit F7 on my keyboard, and this is going to build my project here. I am going to do just that here. So I am going to hit F7. If I do that, that's going to kick off the build of my project. And you see that exit code is 0. And I get the same result as if I did CMake build by going through that menu here. So that's going to make sure that the changes I have here have been built into the Rocket binary that we are running through the launch.json file that we have here. Again, make sure you really make these connections. Otherwise, you are going to have a lot of problems. But I'm sure that now you are really careful about this because we took a moment to understand how important this is. Now that we have this done, we can run this application. Again, I can run it by saying run without debugging. So if I do that, this is going to run the binary and make sure that we see things right away. Again, I want to use this shortcut that I have here. I encourage you to use it because it is going to make things easier. So if I do Control F5, this is going to run the application, and you see that the changes that we did here are now showing up. We have 10 and 20 printed out, and these are values that we are storing in our program. But what I want you to see now is that we can freeze this program and make it run one step at a time. This is something we call debugging in C++, and I want you to make sure that you can use this right from the start because we want to do things like professionals do. If you want to freeze your program, you need to set up what is named a breakpoint. So I am going to put 1 on line 10 in my application here. Your line doesn't have to be line 10. Just choose the line where you want things to stop. I just want it to start at the point where we have value 1 set up in our program here. And after I make sure that I have a breakpoint, I will have a ready point showing up here. If we don't have the breakpoint, it is going to be a bit grayed out. But if I click to add a breakpoint, it is going to be a bit red here. You can really add breakpoints anywhere you want in your C++ program. And we add these breakpoints by using the getter that we have here. This is the location. Now we have a breakpoint at line 10 in the application. If we want to run the application and make it freeze at this point, we can go to the run menu and say start debugging, or you can use the F5 shortcut that we have here. In this case, I am going to hit F5 to start debugging. So let's hit F5 on my keyboard. If I do that, you will see that something magical is going to happen. Our application is going to attempt to run, but it is going to freeze on line 10, and we will see information in our variables. On the left here, you see we have a local section, we have a static section, we have a global section, we have a registers section. Most of these things may not make sense now, but make sure that you can see these things at this point here. Now that our application has frozen on line 10, we can run it line by line and see things happening as we execute things. Now you see that we have a value 1 and a value 2, and they contain values that we didn't seem to put in there. But I want you to focus on the section that we have at the top here. It contains a bunch of buttons. One is step over, the other is step into, the other is step out, the other is restart, the other is stop. And you can see that each of these options is going to give us a shortcut that we can click to make things happen here. Now, what we want to do is to execute things line by line. So we want to execute line 10. After that, we want to execute line 11 and see what happens. After that, we want to execute the fmt print statement, which is going to be printing things to be visible on the terminal here. To do that, you will be using the step over button. This is what is going to execute a line, and this is going to be executing the current line. In this case, if we click, it is going to be executing the current line, which is 10 in this case here. So I am going to click on this button. So wait, 1, 2, 3. I am going to click on it. If I do that, this is going to be executing this line. And after we do this, you will see that a value of 10 has been stored in this value 1 location here. And we can see that on the left. You see now that value 1 is 10. This is the value we have in here. If we execute to line 11, we should have a value of 20 stored in the value 2 location. So let's do that. The value is going to be in there, and you see that the value has been in here. Now we are on line 13. That's the line we are about to execute. And if we execute that, it should print things on the terminal, and we should see them printed out here. You see that right now our terminal is empty at the bottom. Visual Studio Code is nice in that it has a terminal that we can use to see things happening. Now, if we click on step over, in this case, I'm not going to click on the button. I am going to use the shortcut, which is F10 in this case. You see, Visual Studio Code is nice enough to show us these shortcuts here. So I am going to hit F10 on my keyboard, and this should execute line 13 in my application here. So let's hit F10. If I do that, it is going to execute the line, and you see that we are able to execute things line by line, and the line that we just executed has printed the data on our terminal. And this is something I really want you to practice. Don't be afraid. This may seem like overwhelming, but it is things that professional C++ developers do on a daily basis, and I want you to be familiar with this. At this point, we have a configured, well-working environment for C++ development. Make sure you go through this article here to understand the things. Many things I explained in the video, but I didn't follow the article line by line, but you should be able to do these things because we just did them. But it is exactly what we talked about in the video here. Congratulations if you made it at this point in the course. Now you have a ready working environment for C++, and we are going to start to use it in the next video. We'll learn about the files that make up the project here. But I would at least encourage you to work other videos for other operating systems so that you know how things work. But if you are on Windows, this is the setup that you need. But at least watch the videos on Docker and how to use the online compiler because they may come in handy. And again, one of the things I would also encourage you is to at least run the code on 2 operating systems to make sure that you are getting the experience to be a cross-platform C++ developer. Congratulations again. I am excited that we made it at this point here in the course. We are ready to tackle even more important and fun things. I am going to stop here and I will see you in the next one. In this video, we are going to see how to set up a development environment on Linux. I will be using Ubuntu 24.04. That's the system I have access to now. But the steps we do here should be reproducible on any Linux distribution that you may be using. If you face any problem, just ask around and we will do the best we can to help you out. So we need a few tools to do modern C++. And in this course, we want to be using cutting-edge modern C++, things coming from standards like C++20 and C++23. For that, we need a modern, recent version of a C++ compiler. There are many compilers that you can use for C++, and before I even talk about that, I am going to back up a little bit and ask myself, what is a compiler? A compiler is a tool that is going to take the C++ code that you write. So you can assume that this is a C++ file and I am typing some C++ code in it. And after I have this code typed, I am going to pass that through something named a compiler. And this is going to take this code and turn that into a form that the compiler understands and that we can double click on to start running the application. If, for example, you want to start a browser on your system, you go somewhere, you click or double click and you start, we will get a binary on which we can double click and run and get it to do things. So the compiler is something that is sitting between your code and the final goal that you have, applications that people run, and it is the compiler that is going to take the project and turn that into binary form that a computer can run. That's what a compiler is. So we have many compilers in the C++ community. We have the Visual C++ compiler. This one is going to only be working on Windows, so it's not going to be very useful on Linux. But on Linux, we have access to 2 mainstream compilers, GCC and Clang. GCC is also good, but the tool that we use to build our project, which is named CMake, doesn't support it well yet. So the best option we have at this point when I am recording this video is the Clang compiler, and we will be grabbing the latest stable release of this compiler and use it to compile our code. We will also be using CMake. CMake is a build system generator. You can think of it as something that is going to take your project and make it easy to build. Your project is probably going to be made of dozens of files, and it is really tedious to manage how these things are put together. You can call the compiler manually and get it to do that, but CMake is a tool that is going to make it really easy to bundle all these things together and pass them to the compiler and get the compiler to generate the binary that we can run. We will also install a tool named vcpkg. vcpkg is a tool which is going to make it easy to pull thousands of third-party libraries and dependencies and use them in our application. You can think that what we have down here is our application, but for example, if we need to do encryption, if we need to do networking, for example, we need to download a file from the internet in our application, chances are somebody somewhere has written code that does that, and all you need to do is use that code in your own application. So vcpkg is going to make it easy to pull those things and use them in our project here. It is a really cool tool, and I want you to have access to it from the get-go, because this is a tool that professionals use. We will use Ninja. Ninja is just a build system which is going to make it easy, again, to put things together. And the most important thing, I think, is going to be Visual Studio Code, the editor in which you type your code. This is where you are going to be spending most of your time. We will install it and add a bunch of extensions to give it the ability to do C++. These are the tools we need. And at this point, I just want you to have a simple idea about each of these tools. So Clang 19 is going to be our compiler. CMake is a build system generator, which is going to put everything together and then pass those things to the Clang compiler to compile the code and give us a binary. vcpkg is going to be useful in pulling the dependencies, so it is a dependency manager. Ninja is a build system which is going to take the code and pass that through the compiler. And now you may be asking, if we have CMake and Ninja, why do we need two things? Well, CMake is going to be making it easy to use different build systems. So CMake is going to sit on top here. You will give it your project, but CMake has the ability to build the project using different build systems. For example, on Linux, we have the ability to use Ninja. Ninja is one of the build systems that was built by Google, if I remember correctly. But we have tons of other build systems. For example, on Windows, we have MS Build. On Linux, we have Makefiles. So CMake is going to make it really easy to set up our project in a unified way and tell CMake to use different build systems to generate the binaries. So the way this is going to work, I think this is going to be much more clear. We have CMake sitting on top. CMake can call any build system, and this build system is going to call the compiler, and this is where the binary is going to be generated. So for us here, we will write our project, and the project is going to have a bunch of CMake files. Those CMake files are going to be passed to CMake. CMake is going to call the build system. In this case, it is going to be Ninja, and Ninja is going to generate the binary by calling the compiler. This is how things are going to work, and I want you to understand. We have many other options. So for example, we can tell CMake to use Unix Makefiles. So in that case, we will go down this road here. If we are on Windows, we may use MS Build and get things done. CMake is going to make it easy to write a project that can be used in many scenarios. And I am going to show you how to use the Ninja build system because it plays well with CMake when we are using modern C++. Features like C++ 20 modules that are very revolutionary in modern C++. Again, I am getting ahead of myself here. So let's go ahead and install an environment on Linux, but you really need to know what is going on in C++. I have an article written that we are going to be following throughout this course here. So if you go in your course where you are watching this and go to the first video in environment setup, I provided a resource link. You can click on this. And if you click on this, it is going to take you to the Git repository for this course here. I want you to go in environment setup. And if you look, we have number 4, and this is going to be containing a set of steps you can follow to set up a development environment on Linux. So we are going to be reading through this. I am going to open this up, or I can put this on the side. I really want you to have a good experience with this. On the left, I have my guide, which is going to be giving us steps to follow. On the right, I have a Linux terminal. This is my Ubuntu 2404 system. I can confirm that by doing cat etc. I think OS release. I believe this command is going to give us the information. So you can see this is Ubuntu 2404, and you can use any system. So we need a bunch of tools. You can read through this. It is going to tell you the basics about the tools that we need. The first step is to install a compiler, and we will be using the Clang compiler. Clang is a popular C++ compiler that is known for keeping up with the latest C++ standards and blah, blah, blah. I want you to read through this. But to install Clang, we will be using a shell script that is provided by Clang. I think if we do Clang, let's see, Clang, LLVM shell. So if you type in the browser Clang LLVM.sh, we should have a link that takes to the location where they provide this shell here. So you come to this site, and then if you go down, I think they provide a way to install this through this shell here. So automatic installation script, this is what they give you, and you can get it, give it execution permissions, and then run it and specify the Clang version that you want to install here. This is basically the steps that I repeated here. So you are going to get this thing and put it on your system. So I can copy this command, and I want you to copy it. And to do that, I am going to do everything in my home directory here. So if I do cpwd, that's what I need to do. You see that I am in my home directory. If you look here, you see that I don't have much. Let's do lsalh to show everything as a list. You can see that I don't have anything special here. I just have a vcpkg folder that contains my vcpkg installation, and we will get to install this. So download this and put it in your home directory. If I do wget, it is going to be downloaded. And if I do ls, now you see that I have this. You will give it executable permissions. So the command to do that is chmod +x and specify the name of the file. You will do that, and you will run it using sudo to do things in elevated mode. And at this point, I want you to specify the version of Clang you want to install as 19. So run this command. I'm not going to run it because I already did this. I have this installed on this system. But if you run this, it is going to do a bunch of things. Give it a few seconds or minutes, depending on the speed of your internet. And things are going to be downloaded and installed in your system. And it is going to do a bunch of things. It is going to add the apt repository for LLVM. It will install Clang 19 for you, and it is going to do everything you need. After the script is done, you should have Clang 19 installed in your system, and you should be able to do Clang 19, as you see in the guide here, and say -- version. And it should report the version of Clang that you have installed here. If you are in the future, for example, Clang 20 has been released, you can use it. You can use the latest version you can get access to. But the base on which I am going to base this course is Clang 19, and it is going to do wonders for us. Now that we have confirmed that we have Clang installed, we need to make it the default Clang installation. And before I even say anything, I should show you where the install was done. So this is going to install Clang in your user bin directory. So if we cd there and you say user bin, let's do that correctly, user bin, it is not bin, and do ls, we should have a bunch of things. You see that we have a lot of LLVMs. Let's increase the size so that everybody can see this. You see we have a bunch of LLVM files. These were installed by the script that we just did. And if we go on top in the C section, we should see a bunch of Clangs. Clang, you see we have a bunch of Clangs here. These are a bunch of Clang tools that you can use. You can see that we have a Clang 19 and Clang ++ 19, and we have a bunch of other files that we can use to do things here. You see we have Clang D19. This is a language server for C++ that you can use in some cases. But the most important files here are Clang 19 and Clang ++ 19. Now, usually when people call Clang, they don't specify the version. They just say Clang version or Clang ++ version. And we want to do that kind of thing here. So we want that if somebody calls Clang, for example, if they do Clang version, we get the version of Clang 19. So what we need to do is to link this command to the Clang 19 binary that we just installed. And you do that using the update alternative tools. So if you look in our guide here, you will see that we have the command. Let's bring this down again so that we see everything. It is going to take the first link, so user bin Clang, and map it to the Clang 19 that we just installed. So if somebody calls Clang, we will call Clang 19. This is basically what we are telling this system here. This is going to make it easy to do the things that we want to do in this course. So we need a bunch of tools. We need Clang, Clang++, Clang D, LLDB, LLD, and Clang Tidy. These are the tools that you are likely to need. And if you need any other link, you can do it yourself now that you know this. So just take a moment to run each of these commands. I am going to take out what we just had now and reduce the size a bit so that we see the command, and I am going to run it. I am going to put in my password this time, and I want you to copy each of these lines and run it on your system. And the priority just means that it is going to be the first one. So because the priority is high, if you want, you can learn more about update alternatives here. It is a command that is available on your Linux system. So let's run for LLDB. LLDB is a debugger that is used by Clang. And you don't have to worry too much about this. We just want to make sure that these things are available for use on our Linux system. So I am going to run each of these commands, and I want you to run it. This is the last one. I am going to put it in and run it. And at this point, we can run each of these commands, and they should report Clang 19 that we just installed here. So we should be able to say Clang version, and if we do that, it is going to report Clang 19, Clang++, this is our C++ compiler. If we do version, it should report Clang 19, and we can do for all these here. I am going to confirm that they are pointing to Clang 19. This is Clang 19. Let's copy the command for LLDB, and it is going to report the version. We do LLD. LLD is a linker, if I remember correctly. And what is this? Let's leave this around so we can check Clang tidy. And if we do that, it is going to report that this is using the Clang 19 version that we just installed. At this point, congratulations. If all these commands, don't worry about LLD. We are going to just be fine with what we have. But if all the others have reported Clang 19, you are fine. You have a working installation of Clang on your system. The second thing we need to install is CMake. You saw that CMake is a build system generator. Again, CMake is going to sit on top. And below CMake, we have a bunch of build systems. One of these is Ninja. And below Ninja is going to be sitting a compiler that Ninja is going to call. On Linux, we usually have two options when it comes to compilers. We can use GCC or Clang, if I can use my ugly handwriting. So the build system is going to choose a compiler to use. We will choose Clang, and Clang is going to take our files and turn them into a binary. Now we are going to be installing CMake, which is going to be processing CMake files that we have in our project here. This is what CMake is going to do. We need to install it. Again, you can read through this, but just go to the CMake download page and download a script that is going to help you install it on your system. Just open that link. You see that we have release candidates. I think I should turn this to white and make it visible a bit later. This is a release candidate, something that isn't released yet. We want to use stable stuff. So let's go down and say latest release. And there are a bunch of scripts that you can download. You see we have for Windows, Linux, and Mac. In this case, we are on Linux, so I am going to choose this version here. And I am going to download a shell script that we can run. So I want you to download this. In this case, the version is 3.31.6. And in the future, you may get another version. Just download whatever is latest for your operating system that you are on. Once you download this, you will put this somewhere. So what you are going to do is to copy the link to that shell script. So you can just right click and copy link and then download this using the wget command. So we are going to go into our home directory by doing cd and make sure that we are in our home directory. We just have the LLVM script that we had earlier. Now we want to download the script for installing CMake here, and it is just going to download. Give it a minute. After it is downloaded, we will give it executable permissions, and we will run the script, and it is going to be installing CMake in a location that we specify. The script has been downloaded. Now you see that we see it in our system, CMake 331. So you will get whatever version is available at the time where you are doing this. You want to give it executable permissions. So I am going to put this command in and give it executable permissions. If we do a lsalh to visualize everything, you will see that now our script is executable. As you see here, it is executable because we have a bunch of X's in this section here. This is something you should see if you know a bit about Linux. Now you are going to be running this script, but the most important thing I want you to notice is this prefix option that we are passing. It is specifying where we want CMake installed on this system here. In this case, I want it to go into the OPT folder and create a folder named the CMake-3.31.6. This is going to be hinting to the version that I have installed, and CMake is going to be installed in that section here. And we are going to be skipping license information. So copy this command and run it on your system. You can just copy it and paste it, but make sure that it is going to be installing in the location where you want to be installing CMake. In this case, it is going to go into OPT and CMake, whatever we have here. I am not going to run this because I already have a CMake installed, but run it and give it a minute to execute. And after you do that, CMake should be available in that location. If I go into the OPT folder and do ls, you see that I have a CMake. Let's do ls ALH so that everything is visible. It's not even visible, but I have a folder named CMake-3.31.6. And if I go inside, I should find my CMake installation, and let's do ALH. I have a bin folder, I have a doc folder, I have a man folder, I have a share folder. The files that we need are in the bin folder. So if we cd in bin, we are going to be seeing a bunch of files. So let's do LSALH to show everything. You see we have a CMake, which is the binary that we want to use. We have a bunch of other binaries, but the most important one is CMake that we will be using here. Now that we have this, we want the CMake installation in our system to point to this CMake that we just installed. And again, we will be using the update alternatives utility on Linux. We want that if somebody calls user bin CMake, we will be pointing to the CMake that is living in the OPT folder that we just installed. Again, we are giving it the priority of 100 here. This is going to make sure that we have CMake installed, and it is going to be findable or locatable by anybody who needs CMake on this system. So I am going to run these commands here. So take a moment to run them. I am going to copy the second one. I like to run them one by one so that I see what happens. If there is a problem, I can notice and try to fix it. I am going to run the last one. So let's copy it and put it in our terminal and run it. And after you do this, now you should be able to go anywhere. I am going to go back into my home folder. And if I say CMake -- version, it is going to report the version that we just installed. This means that you have a CMake installed, and you are ready to go on and install other things that we need. The next one is going to be the Ninja build system. Again, you should notice the chain of command that we have. We have CMake sitting on top, and below CMake, we will have a build system. The build system is going to be Ninja that we are about to install. Below the build system, we will have a compiler that we already installed. So we have a Clang sitting here, and we have a CMake sitting on top. We are going to be installing this thing sitting in between here, which is Ninja as a build system. If you want, you can go to a browser and learn about Ninja. You can just go there and say Ninja build system. And yeah, they are going to tell you what it is. We can go to the website that is coming up for it. It is a small build system with a focus on speed and blah, blah, blah. If you want, you can read it. But now we just want to install it. So we are going to go to the Git repository for it. And they have a bunch of release files that we can use. So where do we go? Let's expand this and make it a bit big. And we can go to releases. And if we go there, we will see the latest version. You see, we have a bunch of files that we can download. In this case, we are on Linux, and we will be downloading this file here and put it on our system. That's what we want to do. So let's go back to our guide, and yeah, let's put this where it belongs. We go back to our guide. So you are going to open the terminal and update and get the tools that we need. Let's just run these commands here. So sudo apt get update. This is going to update our sources, And after this, we will attempt to install the unzip command. I think I already have it installed, but if you don't have it installed, you can install it. And wget is already installed. You see that I already have them installed, but run these commands to make sure that you have the tools that we need here. So you are going to be downloading the zip file that I just mentioned. All you need to do is to go to this location, Ninja Linux zip, and copy this link, and you should get the latest version at the time where you are watching this. So copy this link and just use the wget command to download the thing you need here. So let's get wget and put in the link that we just got from the site. Hit enter. This is going to be downloading this and putting this on your home folder. If we are in our home folder, you see we have downloaded it. We are going to unzip the file, and it is going to be unzipped in this location here. And the command to do that is to do unzip. So let's copy it and put it here. And this should give us the Ninja binary. So let's do lsalh, and we have a Ninja binary that we just extracted. We are going to move it into the user directory and give it executable permissions. So move it there, run this command, and put it on your terminal. And you are going to run it. I'm not going to run it because I already have this in the location where it is supposed to be. After that, you will give it executable permissions. And now you should be able to execute that thing. And after you run this command, you will be able to run Ninja and get the version that is installed by doing ninja -- version. This is going to report the version that you have installed. You see that in our case, we have 1.12.1 installed. After this, we will need to install Git. Git is a tool which is going to help you manage versions in your files. So for example, if you have a file today and you come tomorrow and you add stuff to it. So you had one thing inside, the next day you add things, maybe the next day you come and remove half of the things that you have added. Git is going to help you keep track of these changes in a very smart way. It is a good tool, and every developer I know is using it. So you should use it too. We are about to use it to install vcpkg, that's why we need it here. But to install it is really easy on any Linux system. Just use your package manager and say sudo apt install git. I think this is going to be installing it if it is not installed. And after this, you will just say git version -- version, and it is going to report the version of Git that you have installed here. Now that we have this, we need to install vcpkg. Vcpkg again is something that is going to be pulling dependencies into our binary. We have a binary that we are building, and we have thousands of repositories that we can pull things from. And if, for example, we need to do encryption in our program that we are writing, we can pull that dependency and put it in our binary and use that without having to invest the effort to do these things ourselves. This is how you get real things done. So we need a vcpkg, and it is going to help us do those things in our program. I am going to be installing the vcpkg in my home directory. This is how I like to do it, but you are free to put it wherever you want. And yeah, let's do this. Make sure you go into your home directory by running this command. So this is going to put you in your home directory, and you can confirm that using the pw command, which is going to report where you are. And after this, you will download a vcpkg. I have to say that I already have a vcpkg downloaded and installed in this directory. So for me, it is not going to download it, but you can use it if you don't have a vcpkg installed in this location here. So run this command, git clone https, and put in the link there. If you run it, it is going to be downloading vcpkg and putting that in your home folder. And now it is saying that it's not going to do it because I already have it installed. But after you do this, this is going to download and put the folder in your home directory. Now what we want to do is to change into this vcpkg folder. So I want you to do that. And if you do ls, you will see a bunch of files in there. The most important one in this case being the bootstrap shell file that you see here. This is what I want you to run next. So I am going to run it in my case. This is not going to hurt. I am going to copy it and run the command. And if I do that, let's do vcpkg boot bt. No, it is bootstrap. Let's run it as a shell command. And if we run it, it is just going to do whatever it needs to make a VC package usable on this system here. And it should report something like this when it is done. Now that's going to mean that you have a VC package installed. So you can do vcpkg version. To run things on Linux, I think you have to specify the folder here. So vcpkg version should report the version that you have installed. And you see that we have a version that was built in February of 2025. That's what we have here. And it is just going to do for you. Okay, now we can confirm that we have a VC package installed. If you see an installed version of VC package, you have successfully installed it. And now we need to set up a VC package root environment variable that our projects in C++ are going to use. To do this, you need to open a file that is in your home directory. So I am going to change to the home directory and do ls.l I think this is what we need to do. And if you do this, you should see a bash RC file, which is a hidden file because of the dot that we have in front here. This is just how Linux works. I want you to open that file and add this command at the end of that. That's what the instructions here say. You can open it with any editor. I am going to be using Vim because that's what I am familiar with. But you can use any editor that you have on Linux. You can even use some visual editors. I am going to use Vim in this case. So what I am going to do is say Vim bash rc. I think that's the file rc. And if I open it, you will see a bunch of things that you probably aren't familiar with. And I want you to just go to the end of your file and put in these commands that you see here. You see that I have put in the path for CMake, I have put in the path for VC package root, and I just did this command here. I just want you to adapt these last 3 lines to point to the location where you have these things installed. In this case, I want this one to say the location where you have a CMake. So my CMake is installed in this location. And I am going to set up a VC package root, which is going to be going into my home directory. And I am going to export this so that it is available. Anybody can call this from anywhere in this application here. Make sure that the end of your file points to the location where you have these tools installed in your system. This is what I need you to do. Once you have this, you are going to close out of this file. So I am going to get out of this. And after you do this, you need to reconfigure the paths in the terminal that we are in here. So run this command and it is just going to make sure that everything is working correctly. Now we should confirm that we have a bunch of tools that we can use to do C++ on this system here. So we have a Clang installed. Let's say Clang version. So you should see a version of Clang. You can confirm that you have a CMake. If you see output like this, it means that CMake is installed. You should confirm that you have Ninja and you should see a version, and you should be able to use vcpkg and version because we added it to our bash rc file as we just saw in a minute. These are things you need to do to get a good environment in which you can do C++ development. Okay, now that we have all these tools installed and we just confirmed that they are available for use on this system, we want to install Visual Studio Code, which is going to be the editor that we use to put things together. Visual Studio Code is one of the best editors when it comes to C++ development. Well, it is really useful for many languages. I like to use it for C++, especially because it is very lightweight. It doesn't eat up a lot of resources on your system. But another great selling point is that it works well on all operating systems. For example, you can use it on Windows, Linux, and Mac, and it is going to look and feel the same. And it is very powerful. It is extensible. It is customizable. You can make it to do a lot of things. And in this case, we will teach it to do C++ using all these tools that we just installed here. So head over to the Visual Studio Code website. Let's increase the size here so that you see everything. And it is a good editor. You want to download it for whatever system that you are on. I am browsing this site from Windows. That's why they are saying for Windows. But if you are browsing this from a Linux system, they will tell you to download for whatever system you are on. Another thing you can do is to click on other platforms here and get whatever you need for your system. Once you download it, you will follow the usual steps you use to install things on your system. and Visual Studio Code is going to be available. Now I am going to assume that you have it downloaded and installed on your system, and we are just going to open it and configure it to do things. I am going to be opening this on my system, and this is not a real Linux system. It is just Windows subsystem for Linux. It is going to give us a good environment to do Linux on. This is just easy for me because I am on a Windows system, but regardless, if you have a Visual Studio Code open on your system, the steps I show you here are going to apply. So make sure you do everything I tell you to do on your system here. Now let's go back to our guide and see some other things that we need to do. Download and install Visual Studio Code, open it and install a bunch of extensions that you need to use for C++. Now, the first extensions we need are those that teach Visual Studio Code to do C++. And there are two options here. You can use the C++ extension from Microsoft. It is going to work really well. But in this course, I will be using the Clang tools here. So we will be using an extension named ClangD and another one named code LLDB. That's what I am going to use, but in many cases you may see the C++ extension from Microsoft used. It is going to work, but we have to choose one of these here. I have to warn you that if you try to enable both of these, you will have problems. So you have to really make sure that at one point you are either using the extension from Microsoft or the Clang tools, and by the Clang tools I mean ClangD and LLDB. So you can't have both of them installed and enabled. If you do that, you will have a problem here. Let's go to our editor and install the extensions that we need. So you open the extensions tab, which is right here, and I think if you hover over it, it is going to say something. So let's decrease the size here and hover over it. It is going to say extensions and Control-Shift-X. This is another way to get here through a shortcut. So open it and type code LLDB, and I want you to hit enter. After you do that, it is going to give you this option, code LLDB by Chuganov. This is the name of the guy. It is a popular extension. You see it was downloaded 8 million times. And it is enabled. I want you to enable it if you want to be using these extensions here. So make sure it is installed and enabled on your system. And if it is installed and enabled, this button is going to say disable. So this is what you want here. Another one we need is ClangD. So let's search for ClangD. If you hit enter, it is going to come up. And this is what I want you to install. It is coming from LLVM, and this is going to help you write, understand, and improve C++ code by using the features that you have here. This is what we get by using this extension in Visual Studio Code. So make sure you have installed. So make sure you have it installed and enabled. And this is going to be teaching Visual Studio Code to do C++ as we are about to do. After we have these, we will be using a bunch of other extensions, and I want you to install the CMake tools extension and the CMake extension here. Let's just copy CMake tools and just put it in our extensions tab and say CMake tools. If I hit enter, it is going to come up. It is an extension from Microsoft. Make sure you have it installed, and it is going to give you all these features that they talk about here. But now we just don't care too much about this. We just want it installed. The other one we need is a CMake. So let's type a CMake there. Let's not be lazy. So we can even delete the tools here and just say CMake. We want the one by this guy named TWXS. It is a good extension. Again, it is going to teach Visual Studio Code to do CMake here. It is going to give us a CMake syntax if I remember correctly, and it is going to be just good. Now we have everything we need to do C++, but if you want, you can install all these other extensions I talked about here. They can give you a good experience if you want to do C++, but they are not required. I am just going to be using them to improve how I do things in my environment here. And at this point, you have everything you need to do C++ development on our Linux system here. Now what we want to do is to see how to use this to compile and debug a C++ project using the Clang compiler that we just installed here. What I want you to do is to go back into the course, so you can go to, let's make sure we see this, and turn this dark because this is hurting my eyes. What I want you to do is to make sure that you have downloaded the starter files that I talked about in the first chapter here. Make sure you download this file here and extract it somewhere on your system. And if you do that, you will get a folder containing the files for this course here. I am going to go to that location. In my case, it is going to be Code Live. This is where I will be doing my work in the course. And if you go inside, you should have a folder named Environment Setup. And inside of that folder, you should have two template folders. One is going to be using modules. Another is going to be using headers. I want you to notice this here. Make sure you have access to these files. Now we are going to be using them from our Linux system. And before I even use them, I am going to clean them up a little bit because they contain things that we don't need at this point. You want to have these files in your case, but make sure that they look like this when you are starting here. We are going to be using the modules one. And if you want to use the headers one, you will follow the same steps. So what I want you to do is to open this folder in Visual Studio Code. So I am going to go to Visual Studio Code in my case and click Open Folder. And I am going to browse to the location where that project is living. You should follow the steps that are available on your system. In my case, I am just going to go into the location where I have those things. So let's go there and go to course files and do Code Live and do environment setup and then do template modules and then open this folder. This is going to be opening up in my system. It is going to give me a prompt saying, if I trust the folder because it is mine, so you should trust it. And after we open the project, it is going to give us the option to choose the compiler that we want to use. In this case, I want you to choose Linux Clang because Clang is one of the best when it comes to modern C++ and the features that we need in this course here. And if this menu happens to go away, I know it is possible if you click somewhere, it is going to go away. You can go to the View menu and choose Command Palette and then type CMake, select. And if you do that, you should have the option to say CMake configure, select configure preset. Again, this is going to work if you have the CMake extensions installed as I have shown you a few minutes ago. So choose select configure preset and you should be given the option to choose a compiler. I am going to choose the Clang compiler. So let's give this a minute and decrease the size. This is going to trigger the process to configure our project. And because our project is configured to use a vcpkg to download stuff, vcpkg is going to download the things that we need to build this project here. I just want you to see that you get output like this. And the best outcome out of this is that you see build files have been written to a location in your project. Now, after we configure the project, notice that a build folder has been generated. And this is going to be containing files that CMake can use to build our project. Because we are using Ninja as the build system, you can even see that here. I think we can find some information in the output we get after we configure. You can see run detecting compiler for whatever architecture we are building for. It found the compiler in user bin. And let's see what else we can pick up. This project is using the FMT library. So we can look at that. And it is going to be using the Clang compiler that we just installed to build this project here. You can see that we have a bunch of things that we can use right away. This is going to be doing what we want in this project here. Now let's go to the vcpkg file and tell this project, I think this file doesn't look exactly like we want it. So give me a minute. I am going to adapt it. Okay, I am back. This project, when you download the files, they will look like this. And I want you to go through this because there are many errors that may come up that I want you to be aware of. Now, your vcpkg file should be attempting to get the FMT library and the SFML library. That's what I want you to see here. It is going to do the configuration that is needed. Again, we are telling this project to download a third-party dependency named FMT and another one named SFML. And we are going to give it a minute to do what it needs to do for things to work in our project here. Now, let's go to our guide and show you something I want you to be aware of. So you may get a bunch of errors, and let's look at this warning here. At this point, if you are using SFML, from the vcpkg JSON file, and that's the file we are using here. You see vcpkg.json. You may get errors stating that some files are missing or not found, and that you can install them using this command here. So I want you to grab that command and run it and install those things. In my case, it was apt-get install and those tools here. So just copy this and put that in your terminal. In Visual Studio Code, you can even open a terminal by coming to View and selecting Terminal. And this is going to be opening a terminal on your Linux system, and you can run these commands here. This is going to download and install them. We need to say sudo in front of this. Let's do that. And they are going to be installed if they are not already installed. What I want you to see, and the point I'm trying to make here, is that you should look at this output and try to see any indication of how you can solve problems you come across. Again, if it is a problem you can't solve on your own, give me a message in the course platform and I will try to help the best I can. But now we are trying to do things the way professionals do, and professionals come into these problems, and you really need to be aware of this. That's what I wanted you to see here. Now, the project is going to be configured, and it is going to report that the build files have been written to a location, and this is going to generate a build folder in your project directory. I want you to take a look at it, so you can even open this in Visual Studio Code. Inside this build folder, we have a bunch of files, and you see that we have a folder named debug, which is going to be containing the things that this project builds here. Now, this confirms that your configuration was good. To build this project, you can just hit the build button here. We have a build button down below. Let's increase the size, and hopefully this is going to be visible on video. The button is here. You can click on it to start building your project, and it is going to be built. Now we have generated the build files for Ninja, and you can see that if you go in the build folder, these files are going to be specific to Ninja. And the most important one, I think, is the build Ninja file here, which is going to tell Ninja to build this project using the Clang compiler. This project is configured to use the Clang compiler, and I will show you that in a minute when we have everything working here. So we can hit the build button to build. I am going to click on that. And if the build is good, it is going to report that exit code is 0. This is something that means that your build was successful. Now, you can run the application using the run button. Again, I can increase the size and make sure that you see a play button down below here. You can click on it to run your application. And if we click on it, we should see something coming out of this application. Let's click on that. And it is going to do its thing. Let's give it a minute. Before we run, we need to build. So I think Visual Studio Code lost track of things here. But we can just hit the build button and click the run button. If we do that, it is going to print something in the output. And this means that we built and run the project here. And congratulations, if you can see this output, you have a working environment that you can use to do C++ development on your system here. I am going to go to the main file and look at the files that I have here. If you want, you can even take them out. I think this is something we had leftover from the install we did on Windows, but because we are using the FMT library, you can say FMT print hello world. You see that autocomplete is coming in here. And if you want, you can build this project again. Let's undo what we just did. And just make sure that we have a main function which says FMT print. And again, you don't have to worry about this. If you want, you can type this line by line to practice. Just type what I type here. And after you type, you will hit the build button to make sure the changes that you put in your code are baked into the binary that is generated. And then you can run. This is the flow we follow to do things in C++. If you want to change this, maybe to print your name, you can go down and say, I think we should disable these completions here. So let's go here and configure code completions and disable completions. We don't want these getting in the way. And we can say hello print and then put hello and put in your name here. In my case, I am going to put in hello Daniel. And the \n is going to instruct the compiler to move to the next line. So once you do this, you hit the build button to make sure the changes are in the binary. Then you can run. If I run it, you see that it is going to say, hello, Daniel. And everything seems to work at this point here. Now, if you do things the way professionals do in Visual Studio Code, you want to run your applications from the run menu here. And for this to work, we need to configure Visual Studio Code to do something. But before we even do that, I want you to notice where our build files have been generated. For that, I am going to open the location of our project. Again, I can go into where the course files are. You should go to your location in your case. In my case, I am in environment setup here, and I have a project template modules. And when I configured and built the project, a build folder was generated. I want you to notice this here. Now, I go inside the build folder. I will have another folder named Linux Clang because that's the compiler we are using on Linux. Then if we go inside, we should find a debug folder. If we go inside this debug folder, this is where a binary was generated. I am showing you this from my file browser, but you can see this on your own file browser. In the terminal in Linux, we can even open this from Visual Studio Code. If we do ls, you will see that this is going to show us our project directory. I think let's do lsalh so that we can see this better. Now it's not very visible. Let's do lsalh. And this is going to show the information as a list. You see, we have a bunch of files in the project. These are the files that you had originally in the folder. These are the template files that you downloaded in the zip file. Now, after we configured the project, it generated a build folder. We can cd and go into this build folder. So let's cd build and go there. If we do that and do lsalh, we will see that the build folder contains a Linux Clang folder. We cd into Linux Clang and we will see that we have a bunch of folders, but one of these is the debug folder, which is going to be used by default to store our binaries. So if I cd into debug, I will see that it contains my binary whose name is Rocket here. Make sure you know the location where this binary was generated. After you have this location, then you can go into the debug tab, which says run and debug. And you see that Visual Studio Code is going to give us a shortcut that we can use to get to this location. So if I am anywhere, I can hit Control plus Shift plus D and get to this location here. Make sure you practice these things because Visual Studio Code is going to be a tool in which you spend a lot of time going forward in the course here. So if I am on my Explorer tab, for example, and if everything is even closed, I can hold down Control Shift D, and that's going to take me to this location and I can do things. If I want to go back to the Explorer tab, you see that I can use Control Shift E. So if I am anywhere, even in my editor, I can do Control Shift E, and that's going to take me to the location where my files are. Make sure you see these shortcuts and use them to your advantage because that's going to make things go faster for you. I am going to go to run and debug. And what I want you to see again is that you can even click multiple times to make it go away. If you want it to come back, you click again. This is something you can do in Visual Studio Code if you didn't know that. But what we want to do here is to make this run things when we go through the run menu. And to do that, we need to customize run and debug. And to do that, we need to create a launch.json file here. So click on this link, and this is going to create a file in the .vs code folder of your project. And you can go down and choose a configuration you want to use. In this case, we want to run things. And this is the launch configuration. You can click on launch here, and this is going to put things in this launch.json file that was generated here. Make sure you notice all these little details. This gave me double the information. So what I want to do is to delete the second one. I can take it out. So I am going to go to the brace that is on line 22 in my case and go all the way up to the comma here and take it out. And I am going to customize this to launch my application. But for this to work, I need to tell Visual Studio Code where to go to run my binary. The program option here is really telling Visual Studio Code the binary that we want to run if we go through the run menu here. We need to customize the program section that we have here, and this is going to go to the location where we have our binary. Now, the workspace folder here resolves to the location where your project is located. In this case, it is going to be resolving to this location where our project files are located, and the project files are the VC package file you see here, the CMake list file here, the main CPP file you see here. This is your workspace folder. From this location, we can go into the build folder. That's what we want to say. So we are going to go here and say we want to go into the build folder. From the build folder, we want to go into the Linux Clang folder. You can even see that in our terminal here. So we are going to say Linux Clang _Clang. You should say whatever is available in your system. In my case, it is underscore, but I think in the course files, that's going to be Linux-Clang. That's not going to matter. You need to just adapt this to your case. And from there, we have a debug folder. And inside that debug folder, we have a binary which is named Rocket. This is what we want to configure to run when we hit the run button here. Now, make sure you have this configured exactly like this, and make sure that the Linux Clang thing you have here matches the Linux Clang you have in your terminal here. If it has a dash, you should put a dash here. This should match what you have here. Just make sure that they look the same. This is named this because of the settings I have in my CMake presets file, but let's not worry about that now. What you need to make sure here is that this section of your path needs to be the same as what you see here. So if it says Linux-Clang, you should say Linux-Clang in here. If this says Linux_Clang, you should say Linux_Clang, as we are saying here. We are basically telling Visual Studio Code where to find the binary that was built and generated by our project here. Now that you have this, you can even close this file, but to make sure that everything is working, you can hit the build button again. This is going to build everything, and you should see exit code 0. And now you can go to run and say start without debugging, or you can even do start debugging. Let's do without debugging to make sure that everything is working. And if everything works, let's give this a minute. It is going to run the application, and your output should show up in the terminal window here. So let's do that again. Run, start without debugging. It is going to show the output. I can confirm that this is working by adding another fmt print statement here. So I can say print the sky is blue and I put \n. This is going to instruct the thing to go to the next line. And after I do that, I can build by hitting the build button down below. But it is even possible to build through the command palette here. So I am going to go to view and say command palette and say CMake. These are things you need to be familiar with. And build, we have the option to do that here. And why do I show you this? Because this is going to show us a shortcut we can go through to build our project here. In this case, I am going to use that menu. So let's do view command palette and say CMake build. We have the option here. If I do that, this is going to rebuild my project, and I can run it by doing run and start without debugging. And this is going to show our new line here. You can see that this is how you run the application. So the flow to work with Visual Studio Code to do modern C++, you change your code. After you change your code, you need to build the project. So let's add another line, or we can even delete the line that we just added here. So to build again, I can hit F7. You saw that we had that as a shortcut for the build command. So I can hit F7. If I do that, this is going to rebuild the project, and I can run the project by using the shortcut that I see here, which is Control F5. So if I hit Control F5, this is going to run the project. So the flow is really to change the project, and I use the shortcuts to do things really fast. I want you to practice that now. You can add another line. Let's say print the sky is not blue, and you add a \n as we always do, and put the needed semicolon. To build, I can hit F7. This is going to be building, and if I want to run this, I run Control F5, and this is going to make things go faster. I really encourage you to try and use these shortcuts here. Another thing I want you to see is that you can debug this project, And what I mean by that is to freeze the application and make it run in slow motion. So we can make it freeze at this location, for example, and make it execute things line by line. To do that, I am going to change this project a little bit. So let's take out everything here. You can delete everything. Then I want you to type this program that I am just putting in here. So let's say value 1, and I am going to give it a value of 10. And I am going to add another one, value 2, and give it a value of 20. This is going to do. And I want you to say fmt print ln, or we can even say fmt print. This is going to do, and say the values are, and put a bunch of parentheses. Okay, I want you to type this. We will get a moment to understand all these things here. And after the comma, you say value 1. And I put another comma and say value 2. You see that Visual Studio Code is even giving us good completions here. Now, you want to put a \n at the end of the second pair of parentheses. Now we have the project. We can build it before we run it. That's something you need to do. Again, to build, you can go to View Command Palette and do CMake build. But we should practice using these shortcuts here. If you run this, this is going to build. But while you go there, if you can just hit F7 and see the thing building right in front of your eyes. Now to run the project, we can go to run and do start without debugging. But again, you see that we have a shortcut saying we can do this using Control F5. I think on a Mac, it's going to be Command F5, but we are on Linux here. So let's do Control F5 and run. And you see that it is saying the values are 10 and 20. This is what I want you to do here. Now, what we can do is go to a location in our project and say that we want our application to freeze at line 10 when this application is run here. Again, I have to stress that this is going to work if you have a .vs code folder in which you have a launch.json file, in which you properly configured the program option to go to the location where your binaries are being generated. This is really important. I don't want you to have these problems here. Once that's configured, go to the location where you want the program to freeze. In this case, it is line 10 here, and click in the gutter that you have in between here. So go to a line. If you hover over a line, you will see that we have a dot, and it is going to prompt us to click to add a breakpoint. I am going to do that on line 10, and this dot is going to turn bright red as you see here. This is what I want to do. Now we have a breakpoint, and if we run our application in a certain way, it is going to freeze at this location, and we will have the ability to tell it to run line by line. That's what we want to do here. And this is a special thing to do in C++ development. It is going to allow you to inspect problems, see things in slow motion, and fix problems that may arise in your programs. And I want you to be able to do that right from the start. So to start debugging, all we need to do is to go to the run menu and say start debugging. Again, you can see that we have a shortcut to do this, but because we are doing this for the first time, I am going to do it from here. So I am going to click start debugging. And what this is going to do is going to run our binary. And again, to make sure this works well, you need to build the binary with your changes, and then you are going to go to run and say start debugging here. When you do that, your application is going to run, and when execution hits your breakpoint, everything is going to freeze in place. You see that we have a frozen on line 10. We can see that because of the diamond shape in yellow here around our point. And now that the application has frozen, we have a view of everything happening on the left here. This is what I want you to see. We have things we call the local variables. We have a watch window. We have a call stack window. I don't want you to worry too much about this, but the important thing is that we can freeze this application and run it line by line and see things happening here. And another thing you can notice now is that we have our local variables, value 1 and value 2. They seem to contain values that we didn't put in there, but that's not a big problem. All we want to do is to run this program line by line. To do that, you need to come to the top. This is where I want to draw your attention. We have a bunch of buttons here, and one of them is saying continue. The other one is saying step over. The other one is saying step into. The other one is saying step out. The other one is saying restart. And the last one is saying stop. I want you to use the step over button. And again, you should notice that we have a shortcut that we can use to trigger this action without even using our mouse here. We can just hit F10 and this is going to happen right in front of our eyes. So if we want to execute this line, and I have to say that at this point, line 10 has not executed. So if we want to execute that, we can hit step over here. If we do that, you see that execution is going to move to line 11. So we have executed line 10, and notice that the value of 10 was just stored in the value location that we have in memory. This is something I want you to notice. You can do that, and things are going to be happening line by line here. We can also execute the next line, which is line 11. So if we do step over, I am going to click on that. That's going to execute. You see that a value of 20 was stored in this value here. And now the line that we are about to execute is the FMT print line, which is going to be printing things on the terminal. You see that even Visual Studio Code gives us a terminal that we can see things from right away. Here, I want you to practice the shortcut. So it is F10. I'm not going to go to that menu on top. I am just going to be somewhere in my editor, and I am going to hit F10. This is going to be executing line 13 here. And if I do that, output should show up in our terminal. So let's do that. 3, 2, 1. I am going to hit F10. If I do that, you see that line 13 has executed, and we have our output here. These are things you can do in Visual Studio Code and make things execute line by line. I really want you to practice this and be familiar with this. It is going to make you a better C++ developer. If you want to get out of this debugging session, you can just hit the stop button here, and you can take out the breakpoint, and everything is going to come back to how it was before. Now, we have a well-working C++ development environment. I realize that this took some time, but you really need to go through this to have an environment that you can use. If you get stuck, look at the article here. I tried to detail everything. And after that, if you still have a question, you can ask me and I will do the best I can to help you out. This is really all I had to share in this video, giving you a well-working environment in which you can do modern C++. We have a bunch of top-notch tools that we can use to do C++ development. And I gave you a template project from which you can start understanding how things are done by the professionals. And we have the tools installed. Again, you have a CMake. You can confirm that you have that. We should have Ninja installed. So let's do Ninja version. I think we have a VC package. So let's do vcpkg. And the last one was what? We can confirm that from our article. That's why it is good to write things down. Sometimes we need to jog our memory. And the last one I forgot is CMake. So we can confirm that we have CMake here. So let's say CMake and a version. It is going to give us the version of CMake that we have installed on this system here. Now you have everything and you are ready to start doing things the way professionals do. And now that you have an environment set up, in the next video, we are going to see all the files that make up this project and try to understand what each of these do. But if you want, you can even watch other install videos. For example, now you are on Linux. You can see how things are done on Windows. You can see how things are done on a Mac. And in another video, I am going to show you how to install Docker, which is going to give you a ready-made environment in which you can do C++. But if you are on Linux, now you have everything you need to do. Just watch the video on how to understand the files that make up this project here. And then we can keep going and learn even more interesting and advanced stuff. I am going to stop here and I will see you in the next one. In this video, we are going to see how to set up a development environment on a Mac. And here are a bunch of tools that we need to install to get a good environment for C++ on a Mac device. The first thing I have to say is a warning, and this is that the default compiler on Mac devices tends to lag behind in terms of catching up with the latest C++ standards. So for that reason, I will show you how to set up a development environment using the default Apple Clang compiler. But keep in mind that there are some things that you can't do with that compiler. And I have had a lot of trouble trying to get the GCC and Clang compilers to get to work on that system. I'm not saying that it is impossible, but it is troublesome, especially for a course like this, where somebody is trying to learn. So the approach I took was to get you to use what is available on a Mac through the Apple Clang, and then get you to install a Docker image that I provided with all the tools that allow you to do things in a modern way in C++. So on a Mac, we will be setting up a local environment using the available Apple Clang compiler, and you can use that. I think it is going to work 80% of the time for things that we are about to do in the course here. But if it happens to let you down, you can just use the Docker container, just like I am going to show in a future video, which covers how to use Docker on any operating system. So that's the idea here. In this article, we are going to set up the default compiler, which is Apple Clang, and I want you to keep that in mind here. So to do C++ development, you need a couple of tools, and one of those tools is a compiler. A compiler is something that is going to take your code. So suppose you have your code typed out in an editor, and it is a C++ code. And at the moment you decide to compile it and generate an application that people can run, you need to pass that through some kind of compiler. In this case, it is going to be Apple Clang, as I just said here, on a local environment. So your code is going to pass through the compiler. The compiler is going to turn that into a form that your computer understands, and it is going to be loaded into memory and executed when you click or double click on that binary executable. That's what a compiler is. It is going to take raw C++ code and turn that into a form that is directly understandable by your CPU, and your binary can run if you double click on it. That's what a compiler does. We also need CMake. CMake is a tool that is going to make it easy to take your code and turn that into a binary executable. I just said that you can use a compiler to do that, but once you start having thousands of files in your project, it becomes really difficult to keep track of how you pass these files to the compiler. CMake is a tool that is going to make this easy in a cross-platform way, and CMake works in a way that it sits on top, and it is going to be supporting a couple of build systems that can then interface to the compiler. For example, if I give you some names, we have a CMake here, and on Linux, it is possible to use the Unix makefiles build system. So let's use U to denote that. We can use the Ninja build system. We can use the MS build on Windows. This is a tool that you can use to build, and you may have other tools that CMake may support. So what is going to happen when you call CMake? For example, I have a project that uses CMake here, and I try to build it. CMake is going to process those files and decide which build system to call. In this course, we will be using the Ninja build system, so it is going to select Ninja. The Ninja build system is going to call a compiler. The compiler is going to process the code and generate a binary. You can see that we have a chain of tools that we use to make things work easy. You may think that this is a bit complicated, and it may seem like so if you are a beginner, but I am going to show you how to use all these tools and really get comfortable using the tools that the professionals use in this course here. So we need the CMake. Again, a CMake is a tool that is going to take thousands of files and make it easy to pass them to the compiler to generate the final executable. Make sure you understand that. We also need vcpkg. vcpkg is a dependency manager. So what it is going to do, suppose that you have a binary down here and you need to use a bunch of libraries that have been written by others. You may have a library to do networking. You may have a library to do encryption. You may have thousands of libraries to do different things. If you need those things in your application, you don't have to write the code yourself. It is possible that people have solved this problem before, and you can just grab what they did and embed that in your application and get to do what you want to do faster. This is what vcpkg does. It is going to make it easy for us to download third-party libraries and use them in our project. And this is going to make your life easy as a developer. And I am proud to say that you will also have access to this tool from the get-go if you go through this course to learn C++. We need Ninja. Ninja is a build system. I just talked about it. And we also need Visual Studio Code, which is going to be our editor. On Mac, I think you have a bunch of other tools you can use by default, but we will be using Visual Studio Code to make our life easy. Visual Studio Code is lightweight, it is cross-platform, and it supports a lot of tools that are going to make our life easy as developers. So these are the things that we are going to install in this video here. But again, keep in mind that the Apple Clang compiler may leave a lot to be desired in terms of latest stuff from C++. And again, if you find something that this compiler doesn't support, you can use the Docker container and get access to things from other compilers like GCC and LLVM Clang. Okay, now that you have an idea about this, we are going to go on and set up our environment on a Mac. Another thing I have to say is that I don't have access to a Mac device, so I am going to give you instructions. Try to follow them, and if you face a problem, please let me know and I will try to solve it as much as I can here. I have an article written that is going to make it easy for us to follow what we want to do here. If you go into the place where you are watching the course, you should go to the chapters that we have. I think right now it is chapter 2, environment setup. In the first lecture, in that chapter, I have a resource that I provided, which is going to be pointing us to the repository of the source code for this course here. I want you to click that link. If you do that, it is going to take you to the repository on GitHub. Go into environment setup, which is number 2 here, and we have an article, number 5 here. This is going to be giving us instructions we can follow to set up a development environment on a Mac. And you can see that this is about setting up a modern C++ development environment on Mac. It is going to give me a bunch of instructions. The first thing we need is to install Xcode command line tools. And to do that, you will follow the instructions here. So open the terminal and run this command. If you do that, this is going to install an environment you need to do C++ development. I think this is going to be installing the Apple Clang compiler, which I said that doesn't behave well with the latest C++ standards, but it is going to do most stuff that we do in the course here. So follow the instructions and complete the installation. After the installation is completed, you can run this command and it is going to give you a version of the Clang compiler. After that, I want you to install CMake. Again, I said that CMake is a tool which is going to make it easy to put together different files in your project and pass them to the compiler at the end to generate a binary executable. So this is what CMake is going to do. You just need to click on this link and download the package for Mac. I think if we go there, I should turn this to white so that it is visible. So if we go down, we should have binary distributions, but the first thing they will show you is a release candidate, which we are not interested in. We just want the latest stable release. At this point, it happens to be 3.31.6. So this is what I am going to download here. And down here, they provide binary distributions you can use, and we have one for Mac. So you can get the DMG file here and download it. Once you download it, you are going to be opening that and follow the installation instructions. This is going to be following the regular steps to install stuff on a Mac. And after you have that installed, you should run CMake version to make sure that this is available on your system. It should report a version of CMake. Again, I don't have access to a Mac, but I think I can show you how to run these commands using my installed Linux version here. So let's just do that so that we have something to show you. And this is going to bring up my Linux box, but you should be doing this on a Mac. It is going to be similar. It is not going to be completely the same, but it should be similar. What I'm going to do is just drag and make sure that things are side by side here. So let's put this on the side and put the other one on the other side. I am going to clear. And after you have Clang installed, this is going to be Apple Clang for you. You run this command and it is going to be reporting the Clang version that you have installed. Of course, for me, it is reporting the Ubuntu version that I have installed, but for you, it should be a Clang version that comes from Apple. That's something you need to keep in mind here. So you should have a Clang installed. You should also have a CMake installed at this point here. So copy this command and paste it in your terminal. If you do that, it is going to be reporting a CMake version. Now we have two tools. We need to install Ninja. Ninja is a fast build system often used with CMake. If you want, you can search and read more about it. But again, it is a tool which is going to take your code and process it and call the compiler for you. So this is a Ninja sitting here, and the Ninja is going to be calling a compiler to compile your code and generate the final executable. This is the chain of command that we have here. So to download this, you need to go to the location where they have Ninja releases. I am going to open this link here. I can close the one for CMake. If you go here, they should give you a bunch of binaries that you can download. And we have one for Mac. Where is the one for Mac? You can see it right here. So you are going to be downloading this and follow the instructions to install it. So you will extract the binary using any tool that you have to extract the binaries, and you will move that into the user local bin directory so that you can run it from anywhere. So run this command to move it into the user local bin directory, then give it executable permissions. After you do that, you should have access to Ninja, and if you run the command to show its version, it is going to be reporting whatever version you just installed here. At this point, I think the latest version is 1.12.1, is it? Let's go to this location. Yes, the latest version is 1.12.1, but if you are watching the video in the future, you may see a different version here. So now we have installed Ninja. The next thing we need to install is vcpkg, but to install vcpkg, we need to install Git first. Git is a tool that is used to manage versions across your files. So for example, if you have a file and you have written something into it, then the second day you come and you add to what you had yesterday, maybe the next day you come and remove some of the stuff that you added, Git is going to be helping you manage these changes. It is a tool that the pros use, and I want you to start using it from the get-go here. We are going to install it. I think Git is going to be installed if you run the select install command here. If it is not installed, you can search how to install it. I think you can even use the brew command, but that's going to require that you have homebrew installed. If you have a brew installed, you should use this command here. This is going to be installing Git for you, but make sure that you have Git installed. After you have it installed, you should do git -- version, and it is going to give you the version that you have installed here. So at this point, we should have a bunch of tools installed. We have the development tools on the Mac. We have CMake installed, we have Ninja installed, we have Git installed. Now we are about to install vcpkg, which is going to make it easy for us to download third-party dependencies. Now, I want you to change into your home directory and run this command to download vcpkg and put it there. If you run it, it is going to download the vcpkg and put that in your home folder. So run it and it is going to download for you. But for me, it is not going to do that because I already have this downloaded here. If I do ls, you see that I already have the vcpkg folder. But for you, if you don't have it, it is going to download it. After that, you should change into this directory. So you can just do cd vcpkg. It is going to take you there. And after that, I want you to run the script, which is going to install vcpkg here. For you, it is going to be bootstrap vcpkg.sh. I think that's what it is going to be on a Mac as well. So run this script, and you can run it by just saying bootstrap and something like this. Hit enter. It is going to do what it needs to do, and it is going to make sure that vcpkg is available on your system. After you do that, you need to add vcpkg to your path. And all you need to do is to add this command at the end of your zshrc file here. The command to do that is what you see here. And after that, you will run the source command to bring everything up to date. So this is something you need to do on a Mac. And after that, you can confirm the version of vcpkg you have installed by going anywhere. I am going to go into my home directory and then say vcpkg and then say version. This is going to be reporting the version of vcpkg that we have installed here. After that, we need to add the vcpkg root environment variable to point to the vcpkg directory. This is something that is very important for the projects that we will be using in this course here. So make sure you add this. And to do that, you need to open this file, which should be in your home directory. And you can use Nano or any editor. And you need to add the following line at the end of the file. This is going to be putting this path into this vcpkg environment variable. After that, you need to also run the source command. And I think on a Mac, you can also confirm that you have this by running the echo command and printing the vcpkg environment variable. So let's do that. And it is going to be pointing to your home directory where you have vcpackage installed. This is going to make sure that you have everything you need to run C++ code on your system here. At this point, you should have the basic tools installed. So let's just check that we have everything. The first thing you should have is Clang. And for you, that's going to be the Clang compiler that comes with Apple devices, desktop devices, I should say. So if you do Clang version, you should see a version printed out. If you do CMake version, you should see a version printed out. If you do Ninja version, you should see a version printed out. And if you do vcpkg version, you should also see a version printed out. This means that you have all the basic tools to do C++ development on your Mac device. And I think you should also check that you have Git, but you should have it now because you already installed the VC package here. Now that we have this, we need to start using this environment, and we will be using the Visual Studio Code editor. So what you need to do is to go to the website for Visual Studio Code and just download it for a Mac. For me, it is saying download for Windows because I am on Windows, but if you go to other platforms, they will give you an option to download for the Mac, and you should download for whatever device you are running. Once you download this, you will install it like you install any other applications, and then you will need to try out Visual Studio Code. So after you have it installed, run it, and you should have a window like this. There should be some welcome message in between here if it is the first time you use Visual Studio Code, but don't worry about this. Just close that message by clicking CMake button, and then now we need to install the extensions that make Visual Studio Code do wonders in terms of C++. So we will need a bunch of extensions. You can either use the Clang tools extensions, which are going to make it easy, or you can even use the C++ extension from Microsoft. I think it also works on a Mac, but what I recommend and what I will be using throughout the course here are the Clang tools, and this means that you need to install the ClangD extension and the Code LLDB extension. They give C++ superpowers to Visual Studio Code and allow you to work with that really well. So we are going to go to our Visual Studio Code window and go to the extensions tab. If I hover over this, you see that they even give me a shortcut that I can use to run things here. Notice these shortcuts, and if you find that you do something a lot, it is going to be worthwhile to memorize this shortcut here. Now I have seen that it is Ctrl-Shift-X, and if I want to go there very fast from anywhere in my application, I can just do that, and it is going to take me there. That's something worth investing in if you want to become a good C++ developer. But anyway, I am just going to look at the extensions that we need. We need the ClangD extension. That's what I am going to look for and install in Visual Studio Code. So in the search bar here, just put ClangD, and you should see an option from LLVM. This is going to give these powers to Visual Studio Code. So you will be able to do a lot of C++ stuff from Visual Studio Code. Just install this and make sure that it is enabled. The other one we need is Code LLDB. So let's do that. Code LLDB. This is the extension from Vadim Chuganov. I think it is also going to be available on a Mac. It is popular, so it is going to allow you to debug C++ code, Rust code, and all kinds of crazy things. But what you need to do is just to install it and make sure that it is enabled on your system. The next things I want you to install are the extensions that will teach CMake to Visual Studio Code, because we will be using that to do all kinds of crazy things here. So make sure you install CMake tools and CMake from Microsoft. So let's go to Visual Studio Code and do that together. We can go here and clear whatever we had, and we are going to say CMake tools. We have this extension, look for it and install it. The name is CMake tools, and it is going to give extended CMake support to Visual Studio Code. So install it and make sure that you have it available. The other one you need is CMake. So let's make sure we have that available. And it is going to be the second one you see here. And it is from a guy named TWXS. Install this, make sure it is available. It is going to allow you to do the stuff that you even see in this little animation that they have here. At this point, you should have the tools to do C++ in Visual Studio Code. You need something that teaches Visual Studio Code to do C++, and that's done by these tools that we use here. We also need tools to teach Visual Studio Code to do CMake, and we have these two extensions here. Down here, you see a bunch of other extensions that I use personally. You may need this, especially if you want to do Docker. So make sure you install Docker and dev containers. You may leave the Vim one out because you may not need it, but if you need it, you can install it. These are the things I am using even in Visual Studio Code right now. So make sure that you decide whether you want them or not. Now that we have this, we can go to Visual Studio Code and actually try to use it. Now we have the environment we need to do what we want to do in the course here. So let's go back to the article and see something we can do next. Now we have the things, we have verified our installation. Now we can put it all together and run our first project. If all the setup was successful, you can now use one of the template projects as a starting point. What I mean by these template projects are the template projects you downloaded in the last chapter. You should have them somewhere on your system, and we will be using them. We would like to use C++ 20 modules as a first-class citizen in this course, but the default tools on Mac may not support it. For this reason, I am going to show you how to use the header-based compilation model. And if you want to see how modules work, how to run the template with modules, you will do that in Docker. And you see the note here, you can just go to this link and follow the instructions on how to set up Docker and get things done using the container that we provide. For our case, we will be using the template for headers. You can even see that here. So what I want you to do is to go to your Visual Studio Code instance and open the folder containing the code live files that I have shown you in the last chapter. I am going to go to the location where I have them on my system. So I am going to navigate to that location here. In my case, I am using Linux on Windows, so bear with me as I do this. But for you, you will navigate to that location and you will find those files here. So we should be in course files, and I want you to navigate to the code live folder inside your files and go into environment setup and then choose the project using headers. You see that we have two options here. We have one using modules and we have one using headers. Because you are on a Mac and you are using the Apple Clang compiler, now I want you to use the headers template and make sure that you can get things working. If you want to see how to use the modules one, use the Docker container as I am going to show you in the next video. But you have to complete this video first and you have to use the header one. So let's choose headers here. And then we are going to click OK to open this. It is going to prompt me whether I trust the files. And if you run this on a Mac, it should give you an option to use the Clang compiler on Mac. So choose whatever is good for you. For me, I am going to choose the one with Clang. And if that menu goes away for some reason, you can bring it back. And now you may get nervous if it goes away. Don't worry, you can bring it back. You can go to the View menu and do Command Palette and then choose CMake, select Configure Preset. I think that's the option. If you do that, that menu is going to come back and you can choose your compiler that you want to use to build this project here. I am going to be using the Clang compiler that I have on my Linux box, but for you, you will choose the Clang compiler from Apple. So give this a moment. This is going to try and configure your project. And I think when this is done, it is going to generate a build folder that is going to show up somewhere here. So you should see a build folder somewhere. And you see that for me, it has come up. This is going to generate a build folder that contains the files that you can use to build stuff on your system. And to build this, you will be using the Ninja build system behind the scenes because of how this project is configured through these files here. I will explain what each of these files does in a future video, but for now, just make sure that you can compile things like we do them. You can see that for me, it is saying that the build files have been generated. This is what you should see if everything is all right. Of course, the paths and everything may be different, but the message is the same. The build files should be generated and stored somewhere on your system. And for you, it is going to say something different from Linux Clang here. So make sure you look out for that. But you should have a folder specific to the compiler that the files have been generated for. And what do I mean by that? These files that you see generated in this folder, they are specific to Linux, in my case, using the Clang compiler. If I were using another compiler, for example, GCC, you should see a folder named something like Linux GCC. And this is something I configured for this project to make it easy to follow what tools I am using to do what I am doing here. But make sure that this is specific to your environment. I really want you to see how all this works. Now this is done, the build files have been generated. You can even navigate to the location where you have your project. In my case, it was the location for headers. So if I go there, I should see a build folder. So you can see it right here. And if I go inside the build folder, I will find Linux Clang. This is the same thing I just showed you here. So this folder is the same folder you see here. They are the same thing. It is just that here I am using the file browser and here I am navigating through the terminal, but they are the same thing. I can go inside and look at the files that have been generated. Here you can pick up that these files have been generated for the Ninja build system because we have this build.ninja file. So this is something you can see. And if we happen to build the binary out of this application, we will have it generated in this debug folder because by default we are using a debug configuration. You can even see that at the bottom here. This is what we are using. You should start to connect dots and really understand how everything comes together in the tools that we are using here. Now that we have this, we have generated the build files. What this means is that we have configured our project to use a set of tools. We configured the project to use the Clang compiler and the Ninja build systems and all kind of crazy things. But this is just the configure step. We need to do another step to build the project, and that's going to be the build step. And to build, there are many ways to do that, but for now we will go the easy way and just click on this build button down below here. If you click on it, it is going to build your project, and hit it and see what happens. Something is going to happen behind the scenes, and at the end, if everything went well, you should see a message saying that build is finished with exit code 0 and that a binary named rocket has been generated. This is what we just did here. So how do we confirm that the binary has been generated? Well, we can navigate to the location we said we would generate our binaries in. If I go to the terminal tab in Visual Studio Code, I should be at the location of my project here. So if I do ls, I am going to see my files. I can even list them in a nice way using lsalh. I think this is also going to work on a Mac. This is going to give me a list of the files that make up my project, but it is also going to give me the build folder that we just generated. I just want to go in this folder and see for myself if I have the binary generated. We should be able to do that. So cd into build, if you do that and list, you will see that we have a folder. I think we should list nicely. So if we list, you see that we have a folder named Linux Clang. We can cd into that. So let's cd into Linux Clang and list again. If we do that, you see that we see the files that we saw in our file browser. But again, this is using the Ninja build system because we have a build.ninja file, but we want to go into the debug folder and see if we have our binary generated. So let's go there, cd debug and lsalh to see what is there. And sure, we have a binary named rocket generated, and this is a binary because we have executable permissions, so we can run it. If I run it, I think it is even going to do something here. So let's run it, and you see that it is not doing anything at this point. And why is it not doing anything? Because the main file of our program is empty. But we can teach it to do some things, and I think it is going to be educational, so why not do that right now? We can go here and just type what I type here, so we can include fmt and format. This is something we can use to print stuff out, and we have access to this because it is mentioned in our VC package file. This is something I want you to see here. So make sure you type what I type, it is going to work. So we can go down and say fmt println, or we can even say print and say hello world. Now we want our program to say hello world if you run it, and we want to make sure that we see this if we run our binary. Now what we can do, after we change the code, we need to tell the compiler that the code has changed somehow, and we need to recompile again and generate a new binary with these changes that we put in. To do that, you have to build again by hitting this build button. That's what we are doing now. So I am going to hit it, and it is going to generate a new binary. If I go back to my terminal and run the binary again, I should see my message printed out, and you see that now it is saying hello world. We should fix out the typo that we have here, so let's go down and fix it. And we should say hello world, and I am doing modern C++. We can say that, why not? Okay, let's do that. And again, after we do a change, we need to build again and tell the compiler that we need a new binary generated with these changes that we did here. So let's hit the build button. If we do that, a new binary is going to be generated. If we go to the location where we have the binary, we can run the Rocket binary and we should see it do wonders here. So let's call it manually here. And you see that I am doing modern C++. This is working. Now you have a fully working development environment in C++. Now, if you had problems configuring this project, chances are it is that you are asking for C++23. If you go to the CMake list.txt file here, I should have said this before, but if you had problems, you can come here and change the C++ standard to a lesser version. So if C++23 doesn't work for you, you can come back to C++20 and give this a moment to regenerate the build files. So it is going to take a moment. And after it is done, it should say that the build files have been generated. But let's give this a second and let it do what it needs to do to give us those files. You see that they have been written. And another thing I should say is that it is possible to run the application through Visual Studio Code by just hitting the run button here. If you generate the new files, you should generate a new binary. So let's build and see what happens. And if we hit the run button, our application is going to be run from Visual Studio Code, and we should see our output here. This is another thing you can do. If C++20 fails you, you can change this to C++17, and I think this is going to work. This is a guaranteed thing. Now C++17 is supported everywhere. We can look at our output here. It seems that the build files have been generated. So we can hit the build button and run the application. If we run it, it is going to do whatever it was doing before. But we were doing these changes about the C++ standard in the CMake lists.txt file here. So make sure you see these things. But if you can use C++20 or 23, make sure you use them, because this course is about doing modern stuff using C++ here. I am going to turn this back to 23 because I have access to it. So let's give this a moment. It should reconfigure. And if everything is all right, it is going to generate the build files again. Let's just confirm that this is working by adding another print statement. And you should be typing these things with your hands. Don't rely on AI or anything. That's just a way to not get good at C++. You need to type these things and really build muscle memory to solve problems with C++. Let's say the sky is blue. And add a new line character at the end of this. And we can pass this through the compiler by hitting build. If we build, the build is going to be good because exit code is 0. If you don't see this message, exit code is 0, it means that there was a problem and you should fix it. Let me show you an example. So if we hit build and we forgot the semicolon there, the build is going to fail. So at the end, it is going to say exit code 1, meaning that something is wrong. And the compiler should give you a hint about what is wrong. In this case, it is saying we expect a semicolon after this expression here, and we don't seem to have any. So I am just going to come here and add that semicolon. I am going to build again. And now Now everything is going to be good. Exit code is going to be 0. I can run this through Visual Studio Code by using the run button down below here. So if I click on it, it is going to run my application, and you see that the sky is blue. But I can also go through the terminal and go to the location where I have my binary and run it manually. If I do that, you see that this is also going to work. Now you have a good working environment in which you can do C++. And I have to congratulate you if you made it at this point using a Mac device. Now you have a good environment, and this is really cool. Now that we have this, we can go back to our article and see if we can do something else. So we have done all these things here. We have configured, we have built the project. Now what I want you to see is how to debug your project. And to debug is the ability to freeze your application and make it run line by line. But another thing that's going to do the configuration we are about to do is going to give us is the ability to run our applications through the run menu here. So if you go to the run menu and say run without debugging, we want to run the application and be able to see the output here. The good thing about this is that this is even going to give us shortcuts we can use to run things without taking hands off the keyboard. This is going to make you an efficient programmer. If you find that you use something a lot, you should learn about the shortcuts to do those things easily. And this is going to give us that ability. But to be able to do that, we need to do some configuration in our project here. And to do that configuration, you come to the Run and Debug tab. You can see that if we come here, the tab I am talking about is the one you see here. It is saying run and debug, and it is going to give us a shortcut we can use if we want to get here faster. So make sure you remember these things if you use them a lot. To get there from anywhere, I may be here in the main window doing whatever I want to do. And if I want to get there, I just hit Ctrl-Shift-D, and it is going to take me there in Visual Studio Code. This is a sure way to increase the speed with which you do things in Visual Studio Code. But what I want you to see here is that to customize, run, and debug, we need to create a launch.json file in which we will be putting our configurations here. So what I want you to do is to click on this link to create a launch.json file, and it should give you a bunch of options. And what we want to choose is code LLDB launch, because we are using code LLDB to debug our applications here. So choose this. In my case, it is going to give me double the information. I don't know why they do it this way, but we can just take out the second one here and leave out the one we had. You can see that the one using LLDB and launch is the first. What you want to do is to make sure that this request option is saying launch, and you can give it any name, and you don't want to change the type here if you are using code LLDB and clang-D like I have been doing in this video here. This is mostly fine, and what we need to change is this program option here to make it point to the binary that we just generated. And if I open my terminal again, you see that the location to my terminal, to my binary, is going from the workspace folder. The workspace folder is the location of your project where you have your CMake list.txt file and everything. So this is basically our workspace folder. This entire thing is going to be resolving to this location on your system. So if we go on the terminal, we will see that that location is going to be around here. This is in our project, and everything coming after here is going to be a path to the location of our binary. You can see that from the workspace folder, we go into build, we go into Linux Clang, and of course this should be saying Linux Clang on the Apple device. You should find the path and put it here. It will not be exactly like I have here because I'm not doing this on a Mac, and you may have different naming conventions. So make sure you do whatever point to the binary that you just generated in the steps that we just did in this video here. So we go into build, we go into Linux Clang, and then we go into debug. And into debug, we will find our Rocket binary. What we need to do is to put this path in this program option here. So I am going to say build. I am going to say Linux Clang because that's the file, that's the folder where things are in my system. I am going to say debug. This should be a full path to your location, and we will be starting from our workspace folder, encoding the location where our project is. Once we get into debug, we want to run the Rocket binary, and you saw that we have that binary. Even if we go in the terminal here, and do ls, you will see that we have a binary named rocket, which we are referencing here. Make sure that these things are properly set up on your system. Once you have this, you will magically have the ability to go into run and then run without debugging, and this is going to run your application. Let's go to main and make sure we see what is there, and this is going to give us a hint at what we can expect if we run this program. It is going to print hello world, I am doing modern C++, and then it is going to print the sky is blue on the next line. This is what the program is doing here. So if I go to run and do run without debugging, it should run my application. Okay, it has ran, and if I go to terminal, I am going to see my output here. It took a second, but it did it. I can go there and run again. So do run and run without debugging, and it is going to run the application again. And if I happen to do any change, I need to build first before I run the application here. I am going to show you that. So I can say fmt print and say 1 and put a closing and put a new line character. I just changed my application here, but I may think that if I go to run and say run without debugging, I am going to see one printed out here. But you see that if I run the application, that's not going to happen. Another thing I should show you is that you can also use these shortcuts to run these actions here. So instead of coming to run and do run without debugging, I can just hit Control F5 on my keyboard, and this is going to do the thing. So I am going to hit Control F5 and try to run, and you see that I am not seeing the change that I requested for here. This is happening because I did not rebuild the project to burn this new change into the binary that we are running here. Remember, we are running this rocket binary. For this to work, you need to rebuild, and now we have even two options to build. You can just hit the build button here. This is going to be rebuilding the application and burning these changes into the binary, or you can come to view and say command palette and say CMake build. This is going to give you the option to build, and you see that this is going to do the same. This is going to build the project. The good thing about going through the view menu and command palette is that many of these things have shortcuts that you can use to do things faster. So if you want to build, you don't need to go there or even touch the mouse. You can just hit F7 and this is going to build your project. Now we know the shortcut to run, but you can come to run and run without debugging. But I am going to show you how to use the shortcut here. So you can do Control F5. This is going to run, and you see that the change we just did is visible. We can run our application here. Congratulations if you made it at this point in the course here. But we still need to debug this application and show you that you can freeze it and run it line by line. Now we have the ability to do that. For that, I am going to try and clear out everything I have in the main file, and I am going to put in this code. I will have two locations storing different values. The first one is going to be named value 1, and the other one is going to be named value 2. And in these things, I will have two values. In value 1, I have 10. In value 2, I have a value of 20. That's what I should say. And I am going to print these values using a syntax that we will learn about. But at this point, I want you to just type what I type here. So let's do fmt print. And we can say the values are, and put a bunch of parentheses, and put another pair of parentheses, and put a \n. And after this, after the quote, we will say value 1 and put a comma and say value 2. And this is going to do what we want. And in C++, you need to put a semicolon after every line that you type. This is just how C++ works. Now that we have this done, we can build the project. I am going to challenge you to build it without leaving the keyboard. Just remember the shortcut to build. But we can just go to View, Command Palette, and see CMake build. And the shortcut for that is F7. In this case, I am going to do it from here. So click CMake build. This is going to build the project. If you want to run it, you come to run and do run without debugging. This is going to run the project. And you see that it is saying that the values are 10 and 20. This is running our application. Now we have everything we need to look at how we can freeze the application and run it line by line. And what I mean by that is that we can tell the application to stop at line 12 here, and then execute line 13, and then execute line 15, and see what happens at each of these steps here. This is going to work because we have the tools in place, but to be able to do that, I want you to hover over this location in your Goddard. So if you hover over here, you see a bunch of dots. Go to the line with value 1 and then click to add the breakpoint. You can see that this is even the context menu that we have. This is really cool. So let's click, and the dot is going to turn red. This is going to mean that we have a breakpoint at this location in this file here. And now that we have it, we need a special way to run this program in a way that when it runs and hits this location, it is going to freeze and let us watch things happen in real time. This is really powerful. So to do that, you come to run and then start debugging. You don't do run without debugging. If you do run without debugging, this is going to run the entire thing and show you the output right away. But if you want to run line by line, you choose start debugging here. That's what I am going to choose, and watch what happens. If I do that, the binary is going to run, and when we hit the line where we have the breakpoint, everything is going to freeze, and the program is basically going to wait us to tell it to go line by line. And this is really powerful. When this happens, you get the ability to see what happens when your program is in this state. For example, you can watch the values that you have in your program and see the values that they have. You can see that right now value 1 has something we didn't put in, value 2 has something we didn't put in. But if we execute line 12, we are going to be storing value 10 in value 1, and we will see it here. To execute line by line, I want you to watch what happens at the top here. We have a bunch of buttons, and if you hover over each of them, it is going to tell you what it does. The first one is for continuing. The second one is for stepping over. The other one is for stepping into. The other one is for stepping out. The other one is for returning. We even have one for stopping. What we need is the one to step over, which is going to help us go line by line. Now, what I want you to do is to click on step over and move execution to line 13. And when you do that, this line is going to be executing, and you will see a value of 10 stored in this location here. So I am going to do that. 3, 2, 1. I click, and execution is going to move onto line 13. We just executed line 12, and the value 10 has been put into this location here. I really want you to notice all these little things. They will make you an efficient developer, not even just for C++. Now, if we execute line 13, we are going to put a value of 20 into value 2, and we should see that on the left here. So this is where we should see it. I am going to do that step over. And before I even do that, notice that we have a shortcut that we can use to do this easily. So if you don't want to do this by using the mouse and clicking around, you can just hit F10 and it is going to do the same thing. It is going to execute the current line here, which you see highlighted even in Visual Studio Code. So this is really cool. I am going to click step over, and this is going to execute line 13. Now you see that the value of 20 has been stored in this location. This is really cool. And for the last line here, if we execute it, it is going to print the data in these variables, but I don't want to go here and click. I am going to be using this F10 shortcut that you have, because I want you to practice using these shortcuts to make things easy and fast. That's what you want to do if you want to be a good developer. So I am going to hit F10 on my keyboard, and if I do that, that's going to execute line 15, and we should see output on the terminal window that we see down here. This is what we expect. So 3, 2, 1, I am going to hit F10, hit, and you see that this is going to execute the thing, and we see our output here. This is the process you go through if you want to debug your application and see things happening line by line. I am excited if you made it at this point in the course. If you want to stop debugging, you can just hit the stop button here, and this is going to stop the entire thing. Again, if you want to run the application without debugging, you can just do that through the run menu, or you can hit Control F5 and it is going to do the thing. One thing I should warn you about is to make sure that you build the binary before you try to debug it, to make sure that the changes are in place. I would really hope that they would build automatically if you do this, because sometimes you are going to forget to do the build. But what I do is just use the shortcuts to make this easy. So every time I do a change, I try to hit F7, and this is going to be building my new changes. And if I run, my new changes are going to be into my binary. Again, this is something you should do if you want to do things faster. To build, you just come to View Command Palette and do CMake build. or you can just use the shortcut that shows up here. To run, you come to run and then choose whatever run you want to do. If you want to debug, you start debugging. If you want to run without debugging, you do that. And you can use these shortcuts that you see here. This is really all I had to share in this video, giving you a workable environment in which you can do modern C++. We are on a Mac and we have been using the Apple Clang compiler. But again, if you want to do things in a modern way, if you want to use cutting-edge modern C++ and the Apple Clang compiler lets you down, you can use the Docker container, as I am going to show you in a future video. For now, congratulations. I am really happy that we made it at this point. I am going to stop here and I will see you in the next one. In this video, we are going to see how to use Docker as a way to get a ready-made environment set up in which we can use modern C++. This environment is going to give us a bunch of tools that we can use to do modern C++ development. If you are on Windows and you watched the video on Windows, you saw that we had to set up a lot of tools. We did the same for Linux and Mac. And many of those tools were CMake, a compiler, vcpkg, CMake, and all kinds of crazy things. These are many things to set up. And sometimes you don't want to invest the time to do that on your local environment. Another thing that usually happens is that, for example, if you are on Linux, you have your Clang compiler version that you like, you have your environment the way you like it. And if you are watching this course, you don't want to mess up your local environment. So what you can do is go to your environment, keep it the way it is, but install Docker. And this Docker binary is going to allow you to set up another Linux environment with the things that we need for the course here. So if, for example, you have your GCC 11 version that you like and you don't want to change it, you have a Clang 16 version that you are using and you don't want to change it for this course here, you can just use Docker and just use the compilers in this Docker image or this Docker environment and get to not mess up your local environment. On Windows, we get a free Linux environment in which we can do things. This is a plus. And on a Mac, this is even going to be better because if you are on a Mac, you probably saw that the Apple Clang compiler, which is the default compiler on Macs, is not really good when it comes to latest C++ standards. So getting a Docker environment in which we have a Clang and GCC latest is going to give us the ability to try out all these new features. So Docker is an environment I thought I could support in this course here. So if you think you will benefit from it, then follow along and install it and get to use these containers to do the things that we do here. I will give you a second to read the things on these slides here. I'm not going to repeat them. I just talked about them. For example, Docker is going to help you avoid the "it works on my machine" problem. This is a problem that comes, for example, when you set up an application and you make it do things, but the moment you send that application to somebody else to run, the application is going to be missing a few things that were available on your local environment. To solve this problem with Docker, you set up a Docker container containing the resources that the application needs, but you also pass the binary so that somebody who runs this container is going to have access to everything right away. In our case, we are going to bundle the tools into the container. So we will put in a bunch of compilers. I will be putting in GCC and Clang latest. The latest I can get my hands on at this point here. I will be putting in CMake, vcpkg, Git, and all the tools that we need. And what we will be doing in this course here is go from Visual Studio Code that we have installed on my local system. So for example, I'm on Windows and I have a Visual Studio Code installed. I will get Visual Studio Code to connect to a running container and run the code in the container from my Visual Studio Code instance. This is pretty powerful, and we are going to do that in this video here. Now, I have an article prepared in the Git repository of the course that is going to help us go through the things that we want to do here. So let's open that up. It is here. You can go in the course Git repository, the link for which you already know. Go into environment setup. That's what we are doing here, and choose 06 Docker setup. This is what we are going to go through to have an environment ready that we can use with Docker. So take a moment to read through this. The first thing we want to do is to install Docker. So you should go to the website for Docker. I think we can even go there together. Let's say Docker install in the browser. and we should have a way to install Docker on different operating systems. So I want to follow you the steps that pertain to whatever operating system you are on, and I'm not going to help you in that. But a thing I can show you is that you can even use the AI tool that they have here. And say, for example, how to install Docker on Windows. And if we do that, I think it is going to give us a few suggestions. So I think we need to go through Ask AI here and how to install Docker on Windows. And you will be following these steps here. I have a typo here, but I don't think the AI is going to worry about this. So they will give you the steps to install. I would recommend you go through WSL on Windows. This is the option you have. And you will follow these steps here. If you want, you can ask the same question for Mac. So how do I install Docker on Mac? And it is also going to give us the instructions. You should follow these instructions and install on your device. And after you have Docker installed, I want you to go to your terminal and call Docker to see the version. So I want you to look at the steps they provide here. After it is done, the button here is going to go away. I can even ask how to install Docker on Ubuntu 24.04, which is the system that I use if I happen to need Ubuntu. So it is also going to gather the resources and then give me the instructions that I can follow. I want you to follow this and really install Docker on your system. Once you have Docker installed, you should have a terminal window in which to run Docker. So let's resize this and bring this down again. And I am going to do this on my Windows machine. So I can go back to our guide again. I am going to assume that you already have Docker installed and that you have it started. If you have it started, you should say Docker -- version. It is going to be reporting a Docker version. And this is going to make sure that you have Docker on your system. On Windows, if you have it installed, you can just go to the start menu and say Docker desktop. It is going to start and you can run this command to confirm that you have Docker installed. At this point, I am going to assume that you have Docker installed. Make sure that you also have Visual Studio Code installed on your system. If you don't have it installed, you can just say install Visual Studio Code in the browser. And if you do that, you should get a link that you can follow to install Visual Studio Code on your system. So I am going to assume that you also have a Visual Studio Code installed. Now, I am going to open Visual Studio Code on my system. But before I even do that, I am going to show you the steps you need to get the container that we provide. I have a container ready that you can use to use the tools that we need to do C++. And at this point, my container is providing GCC 14 and Clang 19. This article needs to be updated, but you can see here that these are the versions that we have. The latest time I checked, we have GCC 14.2.0, we have Clang 19.1.7, we have CMake, Ninja, we have a vcpkg, and this container is also going to have the vcpkg root environment variable set, and we have a bunch of debuggers that we can use. This is really cool. Now, to get access to this container, after you have Docker installed, you will need to run this command here. This is going to download the image and put it on your local system, and you will be able to use it. So copy this command and put it in your terminal and run it. And if you do that, it is going to download and store this image on your system. In my case, it was fast because I already have this image downloaded. It is even me who built this image, so I have a copy of it on my system. That's why this was faster. But for you, it may take some time. It may take 10 minutes or 5 minutes, depending on the speed of your internet connection. But after you do that, you can say Docker image list. I think we have this, and it is going to list the images you have on your system, and one of those is going to be dig acquire GCC Clang. This is the image. It was created 4 days ago. That's when I created it, but now you can use it to create a container. So let's go down and look at what we can do. Now, if you want to run the container, you will be using the steps that I provide in the guide here. So run the following command, replacing path to code with your code project directory. So this command is going to be running Docker. It is going to be creating a Docker container named cpp_dev, and that container is going to map the local path to our code into a workspace directory inside of the container. And this is going to be done from the container or the image that we just downloaded. So this command has a few things. It has the name of the container, which is going to be named cpp-dev. It is going to be mapping a local directory, and I am going to make this the directory that contains my files, the files that you downloaded at the end of the first chapter of the course, and we are going to be mapping that to the workspace folder inside of the container. This is going to make sure that if we go into workspace inside of the container, we will see the file on our local file system, and this is really powerful. Now you can see a version of this command on Windows, so this is an example. You can see that I am mapping the D directory in Sandbox to workspace. This is just an example. You can map that to whatever you have on your system. And on Linux, this is going to look something like this. So this is the same command, just adapted for Linux system. And I am going to be assuming here that the code is going to be living in your home directory. You can see the tilde sign here. This is going to make sure that you have the thing. So let me show you my local environment, how it looks right now. So the files that I am going to be working with are in this course files folder. This is where I put the things I downloaded. And you see that I have a code live folder, I have a final code headers, and I have a final code modules. I can do all these things here, but I will be using the template project in code live, and I will go in environment setup and try to run the code both for modules and headers, because now we have the ability to do it. We even have access to a GCC compiler that we can use to compile our projects if the code we are compiling works with these compilers. So this is what I am going to do. So in this case, what I want to do is to map my code live, or I think it is even the path to course files. I am going to map that to a directory named workspace in the container. So if we go into workspace in the container, we should have a view of this folder here. This is what I mean. So I am going to take this path and store this somewhere in a text file. So I am going to store this, and I am going to take this command that we have and adapt it for my local environment here. I am on Windows, so I am going to be using this Windows example. I am going to copy this and bring this into my file. Then I am going to be pasting this command, and I want to replace this path to be the path that I have on top here. So what I am going to do is just delete this thing I have selected and then use this new path, which is going to be pointing to the location of the course files that I have. I really hope this is making some sense. So I am going to grab this and copy it, and then adapt this location. So this is going to be my new location, course files. That's going to be what I want to map to. And the rest is really how I want it. I want to run a container mapping the local directory to a directory in the container. And the name of the container is going to be cpp-dev. And this container is going to be created from the dig acquire image that we just downloaded here. So I am going to copy this command, adapt it to my local environment, and I put that in my terminal here. So let's go here, and you can even list the containers. So you can list the containers by doing docker. If I remember correctly, you can do docker psa-a. This is going to list the containers that you have on your system here. And you see that in this case, we don't have a container using our image, but if we run the command, we can run it. And I am going to increase the size so that you see it. I can even make this big so that you see the entire thing. So this is the command I just pulled from my file. This is going to create the container. Again, the container is going to be mapping a local file, a local folder, to a folder inside of the container. This is something I want you to see. And the name of the container is going to be cpp_dev. You can name it whatever you want. I am going to hit enter. This is going to create the container and immediately take me into that container. That's what happens here. Now the terminal we have here is no longer on our system. It is inside of the container. If I do ls, you see that I can see things. I think I can even do cat etc os release. If we have this, it is going to be reporting the version of Linux that you have. This image is built on top of GCC 14, I think, and it is going to be giving us a Linux environment, but this is not going to matter that much. Now we are inside of the container. What we want to see is that the mapping that we did is working right now. Let's bring up the file again. If you remember, let's increase the size of this. We mapped this local folder, so this local folder, to the workspace folder inside of the container. This is what we do. So if we cd into this folder inside of the container, we should see the content of this folder on my local system. And let me show you that folder on my local system. This is how it looks on my local system, and it contains 3 other folders: code live, final code headers, and final code modules. So let's go into the container and see if that's the case. I can change back to the terminal that contains my container, and I am going to cd into workspace. And if I do lsalh in the container, sure, you see that I see things on my local environment. This is really powerful. This is going to allow me to go into the container and work on things that are stored on my local environment. Sometimes this is going to be slow because, again, you are going from a container and manipulating files on your local system, but it is good enough for what we want to do in the course here. And it is going to allow us to even manage things in the same place. So we have the code on our local system, but we can manipulate either locally or through the container. This is a setup that I think is going to help you out. If you want, you can even clone the things and put them in the container immediately. That's another way to do things. But in this course, I will be doing things this way because it is much better and it is going to make things a bit easier. Now you should have a container and you should be able to look at the code that we mapped on our local file system. Let's go back to our guide and see if we can't add anything else. I think I am going to also bring this back together. So let's bring this back together and open my terminal. Where is my terminal? I can't see it. The PowerShell window should be here. So this is our container. Now that we have this, we are going to go back into here and confirm that we have these tools in our Docker environment here because we have access to them. So you don't have to install anything. This Docker container is going to come with everything. And this is really cool. So what we want to do is to check that we have a Clang installed. You can do that by doing Clang version. If you do that, this is going to give you a version of Clang that is installed. We can even check that we have a G++ installed. So if you put this command here, it is going to report a GCC version. Let's decrease this so that we see this in a nice way. So it is going to report a GCC version. In this case, you see that we have GCC 14. And this is good. I am going to copy the command for CMake and make sure that we have a version of CMake installed. This is the version of CMake that we have access to. Let's look at Ninja. So this is going to be our Ninja version. Let's add an N here. It is going to report a version. And our VC package is installed in this location. So you can go to that location and check that you have a VC package. If we run this, it is going to be reporting a VC package version. And this confirms that we have a container that we can use to do C++ on our local file system here. If you want to get out of the container, you can just do exit and you will come back to your terminal. In this case, I am going to come back to PowerShell because I am on Windows. But now I can do Docker PS. I think that's what we need to do, and do A. And now you see that we have access to a container that we just created whose name is cppdev. So let's try and run the command again so that we see everything. I don't know why it is behaving like this. I should really be able to see things on one line. That's what I like. So let's run the command again. And you see that I have a Docker container named cppdev. This is what we just created. And we just exited out of it 37 seconds ago. The container was created 4 minutes ago. We just created it. And the container is created from this image that we downloaded earlier. And this is the container ID. We can use this to do things if we want to. But now we have this container and we can do all kinds of crazy things. So that's what we have here. If you made it at this point, congratulations. You have a Docker environment in which you can do modern C++. Now, what we want to do is to use this container from Visual Studio Code. What I am going to do is follow the steps here. But before you use it, open Visual Studio Code and make sure that you have the containers that are needed to do these things here. I am going to recommend you install a bunch of extensions. One of the extensions you need is remote containers. Let's look at it. So remote containers, remote development. I think this is what it is called. So let's install the dev container. So install this and make sure that you have it available. We also have remote development. Make sure that you also have this installed and available. I think this is going to make your life easy. And I think a good way to go about this is to just look at the extensions relating to Docker that I have installed. And these are going to be making your life easy. So let's go down and look. We have dev containers. I want you to install this. We have dev containers here. We have the Docker container. You can install it. It is going to make it easy to work with Docker. Let's go down and look at other containers that I might want you to install. Anything relating to Docker. If you are on Windows, you may need to install the WSL extension because it will allow you to manage WSL connections. And I think we have a remote connections container. After you have these extensions installed, I want you to come back to the bottom menu and see a menu saying Open Remote Window. So this is where I want you to go. So click on this. It is going to give you a bunch of options. And one of these is going to be attached to running container. And because we have the Docker extension installed, now we should have the ability to manage Docker containers even from Visual Studio Code. I think we can do that from here. So this is something you need to do. So if you click on Docker, it is going to give you the containers that you have. So you can see that we have the container that we just exited a few minutes ago. The name of the container is going to be shown here, cpp dev. It is from this image. And you can really do all kinds of crazy things here. I am going to right click on this container and see what we can do with it. We can start it because now it is killed. We just killed it by exiting it. But now we can start it even from Visual Studio Code. I am going to start it and make it run. And if it is running, you should see a green play button saying that this Docker is running from Visual Studio Code. One thing you can do from Visual Studio Code is even attach a terminal to it. So if you go to attach shell, we will have a terminal window which is running inside of that container. So if we go in here and say Clang version, we will have access to our Clang version. We can basically do all the things that we were doing in the last terminal that we were in, but now Visual Studio Code is making it easy to do the things that we want to do here. Another thing you should confirm is that you can cd into workspace and see your course files. So if we cd into workspace, and go there and do ls, we should see our things. You see that we can see our files. So the connection we did is going to even persist if you close a Docker container and open it again, and this is going to make our life really easy. Now that we have this, we want to connect Visual Studio Code to our running container. So we can go down again and choose attach to running container. And Visual Studio Code is going to be listing the containers that are running on my system. And sure, we see our container, cpp_dev. I want you to click on that. So I am going to go there and attach to running container and then choose cpp_dev. This is going to open a new Visual Studio Code window, which is working inside of that container. And this is really cool. This may do a bunch of weird things because I already were using Visual Studio Code to connect to a container. So there may be some things that it wants to do, but I am going to let it do whatever it wants. And if it fails, I am going to cancel out of this. And I want you to come and just close folder. This is going to close the folder, but it is going to stay in this container here. And it is going to give you the option to open a folder or do whatever you want to do. And you see that the terminal is even in our container here. Again, we can look at the Clang version. Let's say Clang plus version. If we do that, it is going to be reporting our version. This is running in the container. Another way Visual Studio Code is going to hit you that this is running in a container is if you go to the bottom left corner, you will see that it is a container running through this image, and it is going to say the name of the container. I think if you hover over this, it is going to give you all the information here. Now, what we want to do is to open a folder in this Visual Studio Code instance, which is connected to our container. Now, another thing you may need to do if you open Visual Studio Code connected to a container is to go to extensions and install the extensions you need to do everything you need to do here. This is working because I think I installed these things earlier. But if we go to clang D, you see I have it available. This is an extension we have used before. I think we even have code LLDB. If we go to this, it is installed. If you don't have it installed, just click on the button to install it. It is going to be installing. Make sure you have CMake tools installed and enabled. Also make sure that you have CMake installed and enabled. This is going to give you the ability to do C++ in this container, which we are connected to through Visual Studio Code here. Now I want to close this and come back to my Explorer tab. I am going to open a folder, and the folder I want to open is my workspace folder. Why do I want to do that? Because this folder is connected to a folder that contains the course projects that we want to work on in this video here. So I am going to click on workspace, and if I do that, you see that I see my code live folder. I have my final code files that I can open if I want to, but in this case we want to run the template project for modules, which is living in 02 environment setup. That's where I am going to go. So project template modules 01, this is what I want to open. I am going to click on that, and then I click on the OK button that I have on the right here. Let's click OK. Visual Studio Code is going to do whatever it needs to do to get things set up. And immediately you see that it is going to give us the option to choose the compiler that we want to use to compile this project here. You can see we can use Linux GCC, we can use Linux Clang. Because we are using a modules project, I would recommend you do Clang because Clang is going to support this well based on the experiences that I have done. But another thing you should notice is that at the top, this is going to give you the name of the project. It is going to give you the container in which it is running. So we have the image and we have the container name, and we have this information here. Make sure that you notice all these things because they help you out. Now, what we want to do is to go to view and do command palette, and then select the configure preset. This is something we have done before if you went through the install videos. I am going to choose Linux Clang, and you notice that we don't need to install anything. The project is going to try and configure right away and give me everything I need because now my local instance of Visual Studio Code is talking to a container that has everything installed, and I can talk to that container and do everything like I am using my local environment. This is the power you get by using Docker. I am going to give it a minute to download whatever it needs. I think it is taking some time because we are using the SFML library here. So give it a moment, and if we have a problem, we will try to fix it. You can see that it is downloading things that we need as third-party dependencies. So we need the FMT library, we need the SFML library, and this is going to be downloaded through vcpkg because this is the setup we are doing here. Again, I am getting ahead of myself. We will talk about all these things here, but at this point, just make sure that you get everything working in your Docker container. Let's give this a moment to finish up. Okay, let's go down and see if it has finished. It seems that, let's look at the output here, and it is going to fail. This is an error I wanted you to see. If this happens, it usually means that there are some dependencies that were not found on your local system to be able to use or to build and use the SFML library. And in some cases, it is going to give us hints on how to get those. So if we go down, you see that SFML currently requires the following libraries from the System Package Manager, and we can install them by running the command here. You see they are nice enough to even give a command that we can run. So I am going to copy this command and go in my terminal. So this is going to go in my terminal here, and then I am going to say sudo and install these things. Notice that I am installing without a care in the world because this is running in a container that I can throw away. If this was my local environment, I will be careful about the things that I install. So I am going to run this. This is not going to run because I think I need to update my sources. So let's say sudo apt update, and I give this a moment. So let's say apt update, and give this a moment. And after it is done, I am going to clear and run the command that I got from the terminal. And this is going to be installing these things that I need here. You can see that it is going to be 150 megs of data. So I am going to say yes to this and then give it a moment to install those things that SFML needs. I am really glad that you saw this error. And now that you know a way to get around this, These are things that professional C++ deal with on a daily basis, and you really need to see this right from the get-go. So give this a moment to build. Okay, it seems that the build is good. Now what I can do is try to configure the project again. I can do that by going to View Command Palette and select the Configure preset and choose Clang again. This is not going to do it. So let's try and do crash, clean, rebuild. If I do that, it is going to try to rebuild the project. But now it's going to be finding those dependencies that it needed to build the project here. So let's give this a moment. Again, it is going to be giving us the same information, and we need to give it a minute to finish whatever it is doing. You can see that it is doing things by looking at the spinning wheel down here. That's how I know it. So let's wait, and let's go down now and see what happens. It seems that it is done, and now we should be good because it is saying that exit code is 0. So it configured and built the project in one go. So if we hit build again, we will see that it is not going to do anything. And now we have a local environment in which we can do a lot of things, and we can run the application, and you see that it is going to be reporting whatever data was in our application here. Again, now I don't have to explain this because you have done this in the install videos that we have done before. But what we want to do is to make sure that we can run our application through the run menu here. You know the drill. We need to go to the debug and run tab and then add a launch.json file. And if we do that, now I am not going to click on that because I don't want to double my information. So it is going to be using LLDB and launch. And we need to point this to the location where our binary was generated. We can find that out in our Explorer window. So if we go in build and go in debug, we will see that that's the location where our binary was generated. And it is going to be using the Linux_Clang folder. It may be using another folder for you, but just cd into this folder and point it to the location where you have your binary. That's what I am going to do here. So let's go to our launch.json file and say that we want it to go in build and then Linux_Clang, because that's what we see here. Okay, that's the folder we have, Linux_Clang. Inside of that, we want to go into the debug folder and we want to find a rocket binary. This is what we want to debug. Make sure that this is pointing to the correct location in your environment. Your environment may not be exactly set up like I do here, so make sure that you use the information that pertains to your environment. After you have this, you can close the launch.json file and go to the main file, and you can now go to run and start without debugging to see that we can run the application here. If we do that, the application is going to run and we will see our output here. Let's run again. So run, start without debugging. It is going to run again and it is going to give us the output. Let's change this and add another value to make sure that everything is really all right. And if I make any change from Docker here, the change is going to be affecting the local code that lives on my local environment. I really want you to understand this. We have a Visual Studio Code. It is working on the files that live on my environment, but we connected the Docker container that is running from another location to be manipulating the files on my local file system. So if I do a change in Visual Studio Code and put that in my container, the container is going to write that back on my local file system. This is the setup that we have here, and I really want you to understand this. Now we are going to be adding another variable, value 3, and put in 30. So do that and add the semicolon. And then we can say we also have another value and put that here. And now we need to go and change this to add that as a third parameter, value 3. So let's say value 3. You can use Visual Studio Code for this. Now that we have a new change, we need to rebuild the application. Again, you can use the shortcuts. I could go to View Command Palette and do CMake build, which is using the shortcut F7, but I am just going to hit F7 on my keyboard, and this is going to just build the project. If I want to run it without debugging, I am going to do Control F5, and the application is going to run, and you see that my new value is running here. This is really cool. We can even debug like we did on any local environment. So if I come here and add a breakpoint, and you can start debugging by doing run start debugging or using the F5 shortcut here. So if I hit F5, this is going to start debugging, and you can see that I can do all kinds of crazy things using the Docker container that contains everything we need to do modern C++ development. I get excited every time I get to do this. This is really cool. I can step over this by using the F10 key, or by using the step over button on top here, but we are becoming better C++ developers, so why not use the shortcuts like the pros do? I am going to hit F10, and this is going to execute line 10 and put the value in our locals as you see here. I am going to hit F10 again. This is going to execute value 2, and if I hit again, it is going to execute line 12 with value 3. You can see that we have our values in our locals at this point. And if I execute again by hitting F10, this is going to print the information and show that to me in my terminal window here. So let's do that. And this is going to run and do whatever it is we want to do here. Now we have run a project using C++ 20 modules from our container. And this is really cool. But I want you to see that you can even do all kinds of crazy things. So we are going to try and run the header version of our template project. To do that, we just need to open a folder. So go to File and Open Folder. And now I am going to choose Template Headers because this is what I want to do. This is going to be using the header-based compilation model. And you can compile this project and run it using any of the compilers that support the features that we need. Let's start by using the Clang compiler and see that it is going to do what is needed. Now this shouldn't take long because we have the FMT library already downloaded. We just used it. So this is going to take a moment. You can see that it is using the Clang 19 compiler because it is what we just chose. So give this a moment to finish what it is doing, and we can look at what is going to happen if we run the application by picking at the main file. So it is going to set up value 1 and value 2, and we will print those values here. But this is using the header-based compilation model. So notice that these are header files. This is a hint that this is using the header compilation model. I think we have generated the build files. Now we can build the application. Again, you can build by going to View Command Palette and hitting CMake build. But we know better. We can use a shortcut. So I am going to hit F7 to build the project. And a binary is going to be generated. You can go into your build folder to see where the binary was generated. We go in debug. We should find a rocket binary as you see here. So we can run it by doing run start without debugging. And now you can see that we need to provide a debug configuration because this is a new project here. But we already know how to do that. So we can go into our JSON file. So let's go. And see, you see a JSON file has been generated by that pop-up window that just came up. And it is going to give us a starter template from which we can specify the location where our binary are generated. Now we can do this much faster because we are getting better. So I am going to point it to build. The name of the folder is Linux Clang _. So Clang, we go in debug, and then we specify that we want to debug the rocket binary. And now I think we should be ready. I am going to close out of this and go to my main file so that I can see what is happening here. So this is the current file. And if I do run and start without debugging, this should run my application. It may take a second. And if we go to terminal, we should see our output here. So this is running and doing whatever we want to do. And this is using the template for headers. Now, another thing I want you to see is that if we are using headers, we can even compile this using another compiler that this container is going to give you. This compiler is not going to behave well if you use modules. That's my experience. But you can try things out now that you have these containers. All the tools are within your hands, and you can use them to do all kinds of crazy things. So how do we choose the compiler? Well, you go to View and say Command Palette and select the Configure preset. If you do that, you will be given a choice to choose a compiler. And you see we have a Clang that we just used, but we also have a GCC compiler that is perfect for building C++ code on a Linux environment that we are in right now in our container. So I am going to choose GCC. And this is going to redo the steps that it did to configure our project and generate the build files. You see that it is using GNU 14.20. This is another compiler, and the build files have been generated. This is really cool. Now I can do the things that I did before, but before I run through the run menu, I have to make sure that I am debugging the binary that was generated by my setup here. Notice that the files now have been put in a folder named Linux GCC because we are using another compiler. So what we need to do if we want to debug this, we need to go into our launch.json file and change the location of the binary. In this case, it is Linux-GCC. My naming is not consistent, but in the files that you use, it may be consistent. So make sure you adapt this to your local environment. Now that I have this, I am going to try and build, and again, I can use the F7 key without even doing anything, without leaving my keyboard. If I do that, I am going to build the project again, and now I can do run without debugging, and this is going to run my application. You can see that it is reporting the values here. This is really cool. We can do all kinds of crazy things. In Visual Studio Code, if you want to change the preset you are using to build, you can even come down here and click on this button. You see now it is saying Linux GCC, but if you want to change it to Clang, you can do that. So let's come back and use Clang again. But before I do that, I am going to show you that you can even debug using GCC. So if we set up a breakpoint and do run and do start debugging, this is going to do the usual. It is going to freeze at line 12, and we can step over and do all kinds of crazy things. These are things that we have done before. If you want to change back to the Clang compiler, click the button down below here, or you can do view command palette, select configure preset. This is going to give you the choice, and then you can choose Clang again. This is going to configure the project using that compiler. You can really do all kinds of crazy things. I always get excited when I get to do this, but now because we are using the Clang compiler, we need to reconfigure our launch.json file to use Linux_Clang, and I am going to adapt this path here. So Linux_Clang, because that's where we are putting our files. Now we can build by hitting the build button here. This is going to build, or you can hit the F7 key without leaving your keyboard. And if you want to run without debugging, you can do Control F5, and this is going to run the application. You see that we can see our values here. This is really all I set out to show you in this video, how you can use the Docker containers that I provide for this course. Make sure you take advantage of this if it is something you need. For now, I am going to stop here, and I will see you in the next one. Okay, by now you should have a compiler and a bunch of other tools installed on whatever operating system on which you are following the course. And in this video, I am going to show you that it is possible to use some of these compilers through the browser. I have to say that this is not a substitute for a real local environment on which you can generate binaries and do all kinds of crazy things. But this comes in handy, for example, if you want to test a small feature, if you want to test your ideas, or even if you are on the way, you can use these things to take advantage of these online compilers here. I will show you one of the best that I use. It is Compiler Explorer. It is an online tool that lets you explore how C++ code is compiled by different compilers. And this tool is mainly designed to show you assembly code. So something that is between your source code and the binary code that your CPU executes. This thing is called assembly code, and this is what Compiler Explorer is going to show you. Assembly code is specific to the architecture on which it's going to run. I'm not going to go into those details because that's well out of scope for the course here. But I know that Compiler Explorer is a tool you can use to compile code online, and it is going to give you access to many compilers. So this is how it's going to work. You will pass your code through this tool, and it is going to show you how the code is compiled by different compilers. You can examine the generated assembly code. You can compare compiler optimizations. So for example, you can see how the same thing is done by both GCC and Clang. I think they even have access to the Visual C++ compiler online, which is pretty crazy. And you can test new features. You can do all kinds of crazy things. So let's go to the course and show you how you can get access to that. If you go to the course platform where you are watching and go to Chapter 2, Environment Setup, you have a lecture on environment setup, and in there, you have a resource link that I want you to click right now. So let's go there and click on that. It is going to open in another tab. And it is going to open Compiler Explorer for us. So you can see the link here. This is what we have on top. And you see that I have some boilerplate code inside. This is just a simple piece of code I wrote to get this program to tell us the compiler on which it is running. And on the left here, you can put in your code. So you can type code like we did in Visual Studio Code or any other editor that you may be using. On the right here, we have an assembly view. So this is the assembly code for this C++ code that we have here. And now we can explore a little more the compilation process. So you have your source code as you have it here. When you tell your compiler to process it, it is going to do a bunch of steps. But one of these steps is assembly, in which we will be generating code that looks like this. Once we have assembly code like we have here, this code is going to be transformed into binary code, which is really a bunch of zeros and ones that the CPU is going to understand. This is a good way to see what your C++ code is going to be transformed to. And it helps in seeing how some different pieces of code perform if they are doing the same things. For example, if you have two implementations of a function, you can see the assembly code of these functions and decide that one is better than another. Again, that's something that is out of scope for this course here. Here, we just want to use Compiler Explorer to compile the code and see the output. And we can see the output down here. If you go in the main function here, you see that we are calling our function. I know that you probably don't know what a function is, but that's okay. Just look at what is happening here. This is just a way to tell this program to tell us which compiler it is using. And you see that if you run it, it is going to tell us that it is using GCC 15, which is pretty advanced at the time when I am recording this video here. I think GCC 15 is going to be released in May of this year, 2025, and I am recording this video in March. So this is pretty way ahead of its time here. And we can get access to this in Compiler Explorer. This is happening because they build their own versions and they give us access to that. And a good hint at that is that they are using a trunk version. These are versions that they build daily, and if you want, you can get access to them. But you have to be able to build this from source and get your own binaries that you can run. We don't really want to do that, but I want you to see that Compiler Explorer can give you access to these things without you having to build these binaries yourself, which is a really good thing. So let me show you something I usually use this for. For example, if I know that my local compiler, which is Visual C++ at this time, doesn't support a feature that I need, I can come to Compiler Explorer and try this out. I can change the compiler. If I click here, you see that I have a list of different compilers that I can try. You can put the C++ standard version you want to try out here. And for example, a few months ago, Visual C++ didn't support the std generator facility that was introduced in C++ 23, but I knew that GCC supported it, so I could come here and try out this code, and I am going to put it in here and wait for a minute. You see that we get a bunch of errors saying that generator is not known, so I know that to use this, I need to include something. So let's go and include generator, so I can do that. And I am going to give this a chance to recompile. And you see now that it is good. Now I can go in main and try this out. So what I can do is put a piece of code in place to try out my generator. I know you don't understand what is going on here, but we are just getting started. And I want you to see that you can try Compiler Explorer to do a bunch of things if that's something you are into. So let's give this a moment to process. You see that we have a spinning wheel saying that something is happening. And when it is done, it is going to compile the code and run this main function here. And it is going to give us some output. You see that even if it is still spinning, and it says that it is compiling, it is going to give us output here. So the first line of output is coming from the function call that we do here. The second one is printing Daniel using stdprint. This is something I will show you in a minute when we start learning about C++. And you see that we print the first value is 1 and the second value is 2. This is something I can do because I am using std generator here. I think I will do a video showing you about these C++ 23 features. So just know that you can use Compiler Explorer to do a lot of things. This is really all I had to share in this video, making you aware of what you can do with Compiler Explorer. Another thing I can even tell you before I go is that you can share your code. So if you want to share this code with the world, you can just come to the top here and get a short link by clicking here. And then you can share this with anyone. They can see your code and see how it works. This is also a great way to share ideas with other developers. This is really cool. Make sure you take advantage of this if you need it. I am going to stop here and I will see you in the next one. In this video, we are going to explore the file that make up our C++ project. So far, we have been running and building the projects and doing all kinds of crazy things, but I never really took the time to tell you about all these files that we have in our folder that make up our project. And the first file you see is a CMake lists.txt file. As the name implies, this is a CMake file. And what we will do in this file is give CMake basic information about our project. For example, the name of the project, the name of the binary we want to generate out of the project, the version of C++ that we want to use, and things like that. Let's look at some information about this file here. This is the main configuration file for CMake, the build system generator. And again, here, I want you to think about the chain of command in our application. Suppose we have a bunch of source files that make up our project. So say we have 3 files. And when we want to build them, we will pass them to CMake. So we will describe the structure of our project to CMake, and we will tell it that we have 3 files here. CMake is going to take these files and process them. Then under CMake, we will have different build systems. For example, on Windows, you can have Visual C++, you can have Ninja, you can have Linux make files. Let's use the initials here. And now, what you need to do when you set up your project, you can tell CMake that I want this project to be built using one of the build systems here. And we describe that in another file, which is specific to CMake, which is named the CMake preset file. But what you should know is that CMake is a build system generator. It is a build system generator because it generates build files for different build systems. For example, you can tell it to generate build files for Visual C++ on Windows. You can tell it to generate build files for Ninja on whatever operating systems, because Ninja is cross-platform. You can do all kinds of crazy things. After this is passed to the build system, then the build system needs to be told the compiler that it is going to be using, because most of these build systems can also use different compilers. For example, if you are using Ninja, you can specify to either use Clang or GCC. So you will pass this information to Ninja, and then the build system is going to use that compiler to generate a binary that you want out of the source files that you have here. I really want you to understand this structure that we are dealing with in our C++ project. So a CMake list.txt file defines how the project should be built, including the source files, the dependencies, and compiler settings. You can put all these things in a CMake list.txt file. And another thing I should specify is that this file should be named like this, exactly, including the .txt extension. If you name it differently, CMake is going to deny it, and your project is not going to do what you want it to do. In a CMake list.txt file, we can also specify the project name, the version, the libraries that the project is going to be using, and CMake is going to be using this file to generate appropriate build files. So this is something I just described here. We can generate make files, build files, we can generate Visual Studio build files, we can do all kinds of crazy things. And I think we are going to see this in a minute when we get to see a real project here. We also have a CMake presets file, which is really used to take off some load of the CMake list.txt file to make it easy to build our project. It is also a CMake file, but this file is going to be providing a standardized way to define CMake configurations for different build environments. You see that using a CMake preset file, we can decide to set up a build configuration for Windows using Visual C++. We can do all kinds of crazy things. We can even tell a configuration to hide itself if it finds itself in an environment where it is not appropriate. For example, you will see that in our project, if we try to run the project on Windows, the GCC and Clang configurations are going to hide themselves because we don't want to use them on our system. This is something you can do in the CMake presets file here. It is going to be storing settings for different build presets as compiler options, and you can really put any kind of information in a CMake preset file. It is going to be up to you to decide whether that setting is going to be living in the CMake list.txt file or in a CMake preset file. This is some control that you have, but it is really good to store all these build environment settings in a CMake preset file. Now we have looked at two files. The next one is a main CPP file. This is pretty easy. This is going to be the entry point of our application because it contains a main function here. So every C++ program is going to be containing a main function, which is going to be the main thing the CPU looks for if it wants to execute your application. So this is typically the entry point of any C++ program. It is going to be containing the main function where the program execution starts, and it may include other files and logic to initialize and run your application. This is what we do in a main C++ file here. You have seen that in our project, we also have a utilities.ixx file. In this project, we will be using the ixx extension for C++ 20 modules, but please note that this is not the only extension. You may see other people use other extensions. This is just my preference because I am a Windows developer. I do most of my work on Windows, and this is the extension that the Microsoft compiler Visual C++ chose to use for C++ 20 modules, but not to worry, we can compile our code still using this extension, even if we run it on Linux or a Mac. So a utility file is really an extension to the main C++ file. How should I describe this? We have our main C++ file, which contains the entry point of our application, but it is likely that the application is not going to put everything in the main C++ file. So what we do, we set up external entities that do things that then we can get access to by importing those entities into the main C++ file. You have seen that to be able to use things in utilities, we have to do some kind of import in the main C++ file. This is basically bringing these external entities for use in our main function here. This is a C++ 20 module interface file. It defines a module that we will name utilities, and it is going to be exposing some entity for use by people who happen to be importing this module in their own code. Using modules improves the efficiency of the build process. We will get a chance to talk about this. This is something that was introduced in C++ 20, and it is meant to improve the way we compile our C++ programs, making things more manageable and efficient, as they claim in the documentation of this feature in C++. We also have a vcpkg file. This is an easy one. It is a vcpkg file, and this is what vcpkg is going to be using to download our dependencies. You have seen that in this file, we can specify that we want the fmt library or that we want the sfml library. I think these are all the files. You can also have a gitignore file. This is a file in which you put things that you don't want Git to worry about. But I will talk about this more when we get to talk about Git in this course here. So this is what we have. Now, what I think I can do is open a project on my system and show you all these files here. So I just opened the template project for modules, and I should close it and show you how I opened that. So suppose you have a Visual Studio Code opened. So I am going to close the folder and I go to the location where I have my project. This is in the course files. You will go in Code Live, and then you will open Environment Setup. If you drag and drop template modules here, we will have the project opened on Windows, and on Windows automatically, we will pick the Visual C++ compiler. But let's explore these files one by one. So we can look at the CMake list.txt file. Again, this is a file which is going to be consumed by CMake. So to be able to use this project on your system, you should have access to CMake. If you open the terminal, let's close this and show you how I just opened it. You can go to View and choose Terminal here. This is going to show the terminal window at this point, so that you have access to it. And this is going to be in our Windows system. So I can confirm that I have a CMake by doing CMake version in the terminal here. So CMake version, 2 dashes. This is going to be reporting the CMake version I have installed. And this version is going to be processing my CMake lists.txt file. This file has some rules that you have to follow. The first thing is to specify the minimum version that is required to build your project. In my case, it is CMake 328, but I think I can even make it 330 because we are using modern C++ here. This is something we can do. It is not going to hurt for our project. And you see that if I modify my CMake less to that txt file, Visual Studio Code is going to automatically reconfigure the project to make sure that the change I do here is acceptable. Let's try and put in something that is nonsense and see what CMake is going to say. It is going to pick this up and it is probably going to give me an error. It should give me an error. Maybe it is going to give me an error when I try to build the project. I had built this project before, so maybe that's why. But the idea is that whenever you change something here, CMake is going to reconfigure your project and make sure that everything is all right. Now, we have specified the minimum required version for CMake. Down here on line 4, I think I can even reduce the size a bit so that everything is on one line. On line 4, we have a setting which is going to make sure that CMake is going to be picking up vcpkg and use it as a dependency manager. How do we do that? We do that by setting up a variable named CMake toolchain file, and this file is going to be pointing to a location where we installed the vcpkg on my system. Now you see that the vcpkg_root variable we set up is coming in use. This is going to go to that location on my system. Then it is going to go in the scripts folder. It is going to go into the build systems folder and find a vcpkg.cmake file, which teaches Visual Studio Code how to pick dependencies using CMake and vcpkg. This is basically what we are saying here. If we go into our environment variables, I think we have a command to print environment variables in PowerShell, but I forgot it. So let's bring up our terminal. I can show you my environment variables right away. So if I go into environment variables, I will have a vcpkg_root environment variable, which is pointing to the location where I have vcpkg installed. You can see it here, and you see that it is pointing at C in the folder of vcpkg. If I go in this location on my system, I can show you that we are learning here. You should really understand everything that is going on here. So we can go to the C drive of my system and look at vcpkg. If we go in this folder, now we can follow what CMake is really trying to do here. Now I can cancel out of this. And if we go in the location where vcpkg is installed, which is vcpkg_root, we can go in the scripts folder. We have a folder named scripts. You can see it right here. I don't know if you can see it on video. If we go inside, we will find a build systems folder, and you can see it right here. If we go inside, we will find a vcpkg.cmake file. You can see the properties of this file here. So if we do that, you will see that its extension. Let's see the extension of this file. That's what I want to see. Where do we get to see that? Let's look at details, security. You see that the extension of this file is .cmake. So it is this file that we are telling our project to look for to teach CMake how to use vcpkg to fetch dependencies here. If you want, you can even open this file in Visual Studio Code, so you can just drag and drop it, and you can see that it contains things that vcpkg is going to use to pull the dependencies. This is a CMake file that somebody wrote to do this kind of thing here. And you need this line in your CMake list.txt file for everything to work as it should be. I think that's enough about vcpkg and CMake. Now we have a project command which is going to be specifying the name of the project. You can specify the version of the project here. And an important thing is that we are telling this project that it is a C++ project here. That's what we are doing. In Visual Studio Code, if you hover over a command, you will even have some explanation here. So this is something cool you have in Visual Studio Code. You can use this to set the name of the project. If you keep scrolling here, you will have different ways. It is going to set the name of the project and store it in a variable named project name when called from the top level. And they will tell you all about this here. We are about to use this project name variable in a minute. But down here, you see how we can set the C++ standard. Here, I am going to set it to 23, but you can set it to any standard that is supported by C++ here. So for example, you can set this to 11, 17. These are the standards that you have in C++. I think we have 14 after 11. After 14, we have 17, then we have 20, then we have 23, which is the latest now. You can see that C++ standards are released every 3 years, and you can use any standard here. The first setting on line 10 is saying that this standard is required. So if we try to compile this project in an environment that doesn't have that standard, compilation is going to fail. And down here, we have a setting which is going to tell this project to use C++ 20 modules. This is something you need if you want to use C++ 20 modules. Down here, we have a find package command, which is going to make sure that this package or that this third-party dependency we want to use is available on the system. It is not going to download the dependency. I want you to make that very clear. Find package is not going to download the dependency for you. So you have your project here, and it is using a third-party dependency. Find package is going to look on your system and see if that dependency is there. If it is not there, then you will have a problem. Compilation is going to fail. What is going to be downloading your dependencies is vcpkg. So the way things are going to work, if you try to build this project on a system, CMake is going to detect that we are using vcpkg, and it is going to tell vcpkg to download the dependencies that are listed in here. After they are downloaded, then CMake is going to work and find the packages. So find the package here, it's going to confirm that we have the dependencies downloaded, and then everything is going to go on. Here we are setting up the name of the project. So at this point, you can think of this as the name of the project, and we are going to be pulling the name of the project from a CMake variable named project name. If you go back to project here and see the documentation that pops up, you see that it is going to set the name of the project and store it in a variable named project name. Down here, you see that we are going to be using that variable. And now you can learn that to read from a CMake variable, you have to use this syntax here. You do a $, you open a parenthesis, you put the variable name inside, and then you enclose that in another parenthesis. This is how you read the project name. This is going to allow us to set the project in one location and get to use this in many other locations. And another good benefit of this is that if we decide to change the name of the binary that we generate, we can control this at this project command. So if we change it here, it is going to be changing in every location where this thing is used. This is something you need to take advantage of. The add executable command is going to take a list of files that make up your project. And at this point, it is going to be taking files that are not modules. And I should say even that it is just going to be taking CPP files. Files with the .cpp extension. This is where you need to list each of these files that you have in your project here. We have a target sources command in which we will be listing the module files. So every module file that we put in our project is going to be put in here. At this point, don't worry about these other things that we have here. Just know that every module file that you add in your project is going to be added up here. So if, for example, I add a module named 1, I am going to list that right here. If I have a CPP file named 1, I am going to list that after the main file here. So let's say 1.cpp. This is where I am going to put it. Of course, I don't have these files in my project, so I am going to take them down. But I just want you to know what is going on here. Now, you see that the CMake list.txt file is going to be listing files that make up my project. Now we can look at these files that make up the project here. We have a utilities file, which is a C++ 20 module file, as I told you. And we have the main C++ file, which is the entry point of our application here. Let's look at the main file. The first thing we have here is a comment. And a comment is a way to tell C++ to ignore the things that you have in there. So if I put an opening backslash and put a star here, and I have a star and a closing backslash, everything inside here is going to be ignored by the compiler. This is a good way to put some explanations in my code for other developers to read, but the compiler is not going to be processing anything inside here. This is a comment. There are other ways to specify a comment, and I think I should even talk about that here. So this is a comment which is going to be commenting out the entire line. Okay, so this is a one-line comment, but if you want to comment across different lines, then you will be using this syntax here. On top, we have the includes that bring things that we want this project to use here. And this is something that is brought into our project by the FMT library, which is a dependency to this project. So when we tell vcpkg to download the FMT library, it is going to download it and put it on our system. Then CMake is going to find that package. But another thing we do at the end in our application is to tell CMake to link against that FMT library that we downloaded. So when we do that, we automatically get access to things that are included by the FMT library. So that's why we can go here and say include FMT format. And again, you may be asking, how do I know that I do include FMT format? This is something you know by reading the documentation of the FMT library. So if you go to the FMT library documentation, you may get examples that tell you how to use this library. So to use a third-party library, you need to read the documentation and know how to use it. The second line that we have on line 8 is going to be importing a module file. You can see that the utilities module file doesn't have much in it. It is just defining a module which doesn't contain anything yet. But the first thing you need to put in a module file is this module thing, which is going to tell tools that this is a module file. This is optional, so this is going to work if you ignore this. So we can comment this out and the program is still going to work. But personally, I like to put it here because it makes me see what is making up my C++ module file. So the code we have on line 3 is going to be defining a module named utilities. So if you want to define a module, the first thing you need to do is to put that declaration in a module file. In this case, we will be using the IXX extension, but you will see other extensions like CPPM. I think we have a CPPM used as an extension for C++ 20 modules, but in this video, we will be using IXX. So you go in a module file and then you put a declaration like this. So if you want to declare a module, you say export, you say module, exactly like this. Then you specify the name of the module. Then you put a semicolon as we do here. Later on, if you need to import that module or use it in other files, you will be importing that module. That's something you need to know right now. And now we can go and define our entry point. The entry point is the main function. And right now you can think that you have to use this syntax that you have here. So your code may look like this. I am going to delete what I have here. The main function should have a return value. And in this case, we will be using int. We will give it a name. The name should be exactly main. And then you will put a pair of parentheses. After that, you will put a pair of curlies. And inside these curlies is where you will be putting code that the main function should execute. You have seen that we can say fmt print. We can put in hello world and put a \n. If we do this, our main function is going to execute this code when we run our binary. This is something you have seen before, but the main function should have this syntax here. A return value, in this case, it is int. The name should be main. You should put a pair of parentheses, and we could put some other things inside these parentheses. But for now, they are going to be empty. And in the main function, in the body of the main function within these curlies, is where you put the code that you want your C++ program to execute. That's what we have right here. So that's what our program does. I think we have looked at the CMake list.txt file. We have looked at the main CPP file. We have looked at the utilities file. We have also picked at the vcpkg file. This is where you list the dependencies that your project is going to be using. In this case, we are going to list them simply. So we are going to put the name of the dependency in these quotes here. And how do you know the name you put in here? I think I can show you that. We can go to the browser and then visit the site for vcpkg. I think we can do that right now. We are learning. So if we say vcpkg, we should get the website for it in the first position. Let's make this bright and make sure you can see this. They are going to say what vcpkg is, but you have a button for browsing packages. If you click on this, you will have the option to search for libraries. In this case, I am going to search for FMT. If I do that, I have the first entry saying that it is an open source formatting library, blah, blah, blah. If I click on this, it is going to tell me the name that I can use to get this library. This is basically the name that I copy and that I put in my vcpkg file. I come and I put it here just like this. And if I need SFML, again, I can go back and search for SFML. Let's browse packages and then search for SFML. This is a popular library. Again, the name I use is SFML. I copy it and then I put in my vcpkg file. Another thing you should not forget with vcpkg is this setting that we have here. I would recommend you use this setting in the course because I made sure that the versions that come with this baseline version are what I use in the video here. What this is going to do is to store a list of the versions of the libraries that you will be using in this project here. Again, I will talk about this later on when we have some C++ knowledge. For now, note that this is a setting that you need to use. Don't change this, otherwise you may have problems with vcpkg and the things that we are using in the course here. So use this baseline, exactly copy it, or if you used the starter files that I provided, you don't even need to change this because it is going to come that way. In a vcpkg JSON file, you can specify the name and the version, but they are not very important here. What is important is this dependencies section and the libraries that you put in here using this syntax. So another thing that I should talk about is the CMake preset file, which is going to be storing the build configurations for your project. Now, this is going to seem overwhelming if you look at this the first time, but what you can think about this is that this is going to be storing the compilers that we want to use on any operating system. The way I set this up is that we have 3 operating systems. We have Windows, we have Linux, and we have Mac. And on Windows, I want to use the Visual C++ compiler. On Linux and Mac, I am going to give you the option to choose the compilers that are available on these systems. On Linux, I will give you GCC and Clang. So GCC and Clang. The first one is GCC, the other one is Clang. And on the Mac, this is going to give you the option to use the default compiler. This is basically what I wanted here. Don't worry too much about this, but we can go down and look at Linux GCC. This is a setting that is going to control what happens if we are on Linux. We will be using the GCC compiler. This is going to be the name. This is going to be a setting we use for building on Linux, and you can see that it is using the G++ compiler, and it is building for this architecture. This is something we can specify, and this is going to be applicable if we are on a Linux system. This is a condition you can set up, and this is going to only be applied if the host system name is Linux. This is basically what I am saying here. Let's go down. You see that on a Mac, we are going to be building for this architecture, and it is just going to be using the compiler that is provided on a Mac. You see that we even have a setting for a Mac version using ARM. Let's go down and look at what we do on Windows. On Windows, we will be using the CL compiler. So the host is going to be x64, and we will be using the CL compiler. This is a setting I put together. I think we also have Linux Clang. Let's go down and look at that. This is going to be using the Clang compiler. You see that it is using Clang++. And again, don't worry too much about this. You need to read some documentation to know what you do in a CMake presets file. But this one I gave you is going to make sure that you get a good experience using CMake and a bunch of other tools that make your life easy as a C++ developer. Now that we have this, we can try to build this project. I am going to build it on Windows, and I am just going to show you the folder. So what do I do here? I am going to close this and open everything together with you. I think I had another window using the container that I set up earlier, but let's just go to the location where we have this and then clear these projects here. I am going to take out the build folder, and I am going to go into the headers project and also make sure that it is clean. Then I am going to open Visual Studio Code on my system here. I am going to close the remote connection that is attempting to be open here. Let's go to the location of our project, and I am going to grab the one using modules. So let's drag and drop this on top of Visual Studio Code. You saw that it didn't contain anything, but now that we are going to be configuring it on Windows, it has generated a build folder for us. So this is what these things do. On Windows, we don't have any other preset because that's what the CMake presets is saying. So if we do view command palette and select configure preset, we will only be shown a Windows configuration here. Why is this happening? Because all the other ones are going to be showing up on other operating systems. For example, if we go to Linux GCC, this is going to show up only if the host system name is equal to Linux. If it's not equal to Linux, then this preset is not going to show up. And this is basically what we are seeing on Windows here. I have to remind you that another way you can select the configure preset is coming down here where it said click to change the active configure preset. If you click on that, you will have this menu and you can change it, but we don't need to change it here. Let's look at the build files that have been generated for us. This is going to be educational. So I can go on my file system and open that folder. So I am going to go into modules and then go into build. You see that we generated a CL folder, which is specific to the preset that is being used on Windows here. So this is what we are basically saying. You see the name of the preset is CL, and the build files are going to be generated in a folder named this way. Where am I setting this up? I think it is at the top. This is saying that I will be putting my build files in the build folder. You see, we have a build folder. And under that, we will have another named the same as the preset name. This is a preset that we will be inheriting from. And what this means is that we have a generic preset from which we will be generating other presets. This is how this thing is working. But again, don't worry if you don't understand what is happening here. I just want to teach you what this project is going to give you, and you should know where to look for things. So let's go inside our CL folder. And you can see that because this is a Visual Studio project that was generated, it is specific to Visual C++ using the Ninja build system. A Ninja build file was generated for this project here. This is what we get. Now, if we build the project, we will generate a binary in the debug folder. This is something you have seen before. Again, to build this project, you can just hit F7. I think this is something I have shown you before. If you do that, a binary file is going to be generated. Now, if I go in debug, this is going to be rebuilding the project here. So this is something you have. Now that we have the binary, we can run it. And to run the binary through the run menu, again, you know that you should go to the Visual Studio Code folder here and make sure that the program setting is pointing to the location where the binary was generated. In our case, the binary was generated in this folder. Let's make sure you can see it. And you can see that we are saying from the workspace, we go in build, then we go in CL, then we go in debug, then in there, we will be looking for a binary named rocket.exe. And you can see that if we do that, that binary is going to be found. So if we run, our program should run and do whatever we are doing in the main function here. So let's go to run and say it to start without debugging. This is going to run. And if we look at the terminal, we have hello world here. We can change this again. We can play with this project. The sky is blue. And after we do this, we need to rebuild the project. I am going to do that by hitting F7. If you don't know what F7 does, it is going to be building the project. You can see that it is the shortcut to build the project. F7 is something you need. So I am going to click on that, hit. This is going to build the project. A new binary with this code is going to be generated, and then I can run it. So start without debugging. It is going to run and say the sky is blue. This is basically how you use this project. And I really want you to have a good understanding of what is going on here. Now that we have this, I think it is going to be educational if you see how this is going to be working with the other compilers. So let's just open the container. I am going to attach to a running container. This is a container we set up with Docker. If you don't know what Docker is, or if you didn't set up Docker, just ignore the step. Just assume that I am on a Linux system which has GCC and Clang installed. I just opened the same project using modules on a Linux system. So this is going to be using the Clang compiler. You can see that the preset we are using is Clang, but if we go to view and say command palette and then select a configure preset, you will see that now we are given two options because these options are set up to show themselves on a Linux system. I know that this project is using modules, so GCC is not behaving well from my experience. So I am going to be choosing Clang to build this project. And if I build it, it is going to do the same thing we did before. The only different thing we will see is that because we are using the Clang preset, let's go there and show you that. So we should have that somewhere. the Linux Clang preset. Where is that? Linux Clang. This is the preset we are using. Our build files are going to be generated in that preset name. So we will go in build, then we will go in preset name. The preset name is Linux Clang. So if we go in our build folder, you see that we have two folders now. One is for the things that I was doing on Windows. The other is for things I am doing on Linux using Linux Clang. So this is what we have here. Now the path to our binary has changed. If we want to run things using this compiler through the run command, we need to remember to go in the VS Code folder and change the launch.json file to account for that, because I am running this on a Linux system now. So I am going to go into the build folder and use Linux Clang. Let's do that together. Okay, this is what we do. And the executable file is a Linux file, so we don't need the .exe extension here. Now that we have this, we can build the project by hitting F7. This is something I really want you to practice. We build the project, it is going to be built. And when we configured the project, it did download the dependencies specified by this vcpkg.json file here. So now we can run the project because we know that the binary has been generated, but I can confirm that the binary has been generated by going into Linux Clang here, going into debug and finding the rocket binary. I can do the same on the terminal. So make sure you can do the same thing in different ways. If we cd into build, we cd into Linux Clang, we cd into debug, and do lsalh, we should find a rocket binary that is runnable on this system here. So I know that my binary has been generated. So if I do run and do start without debugging, so does not exist, Linux underscore Clang, is that what I put in there? You can see that if you mess these up, you will have a problem. Yes, I put an underscore. It should be a dash. So if I run again, run without debugging, the thing is going to run and it is going to show me my output here. Again, if I want to change what this program does, I can go in the main file and add another line. Okay, we can do that. This is going to be printing this on another line, because the \n is going to move us to the next line where we will be printing the other thing here. Now, because I just changed this project, I can hit F7 to build it, but I can also do that through View Command Palette and CMake build. It is going to do the same thing. Now that it is built, I can do run and start without debugging. It is going to run and tell me how I am doing here. This is something you can do. Now we are using another compiler, and you see that if you use different compilers, things are going to be generated in different build files. This is how I set up this project here. I think because we are on Linux, we can use the GCC compiler if we are using the header compilation model. So what I am going to do is to open my header compilation model template project. I have access to it, so open that on Linux if you are on a Linux system, and just use that template. I am going to choose that and hit OK. It is going to open up. Again, it is going to give me the option to choose the compiler that I want to use. Let's use Clang first, and give this a moment to do what it does. As it does this, we can look at the VC package file. The VC package file is just using the FMT library, which is okay. But notice that we don't have .ixx files. We have a .h file and a .cpp file. This is what you do if you are using the header compilation model. So let's look at the CMake list.txt file. It is mostly the same, but we took out the things that are specific to C++ 20 modules. So this is how a header-based compilation model CMake list.txt file is going to look. But it is still going to have the project command, it is going to have a find package, and it is going to have target link libraries to link the third-party dependencies that you downloaded into your binary that you are building here. Add executable is going to define the name of the binary that we want to generate, and the target link libraries command is going to make sure that the things we get from that library are baked into our own binary. This is what we are doing here. I think our build files have been generated. You can bring up the command line using this menu here, and if you look at output, we should have build files have been written to our folder, and you see that we are using Clang, and we will put them in the Linux Clang folder. So let's try and run this project. we can hit build, or we can do view command palette and build the project. So if we build, the build files are going to be generated. If we go into build and go into Linux Clang and go into debug, we have our binary. Now we want to run it, and we need to make sure that we have the path of that burnt into our program option into the launch.json file. We are using dashes now. So if we run the application, we should be able to see the things that we specified in the main file here. So we have a value 1 and value 2, and we are going to print them as we have done in other parts of the course here. I think I can run this by going to run and start without debugging. I am going to give this a second. It is going to run. Okay, it has run, and if I go in terminal, I see my values here. This is working and using the Clang compiler on Linux. But again, because this is using the header-based compilation model, I can change the compiler and use the GCC compiler. I can either do that by coming to this option in Visual Studio Code by clicking on this. You see that if I hover over this, let's hover over this properly, it is going to prompt me to click to change the active configure preset. If I do that, I will have this menu and I can change that. But another way to do that is to come to View Command Palette and say Select Configure Preset and then choose GCC here. This is going to tell Visual Studio Code to use GCC to build our project. It is going to reconfigure and do whatever it needs to do. You see, it has detected that we are using the FMT library as a third-party dependency. It knows that we should use the GNU 14.2.0 compiler, and it has generated build files that use the Ninja build system with the GCC compiler. If we go in the build folder, we see that we have a new folder named Linux GCC. This is really cool. And we can now hit build to generate the build files. Right now, we just have a blueprint of a project, but we haven't generated the binary yet. To generate the binary, you have to build. So you can build by coming to View Command Palette and saying CMake build. This is something you know by now. If we do that, a binary is going to be generated. Now, if I open my debug folder in Linux GCC, so let's see, Linux GCC. And why am I not seeing that there in Visual Studio Code? Let's open the folder again and go into debug and go. We are using a debug configuration. Let's go there and confirm so we can clear and cd into build. We can cd into Linux GCC. That's what we want. If we do lsalh, we will see the folders. And if we cd into debug, and do ls, we have our binary. It must be Visual Studio Code, which is not picking this up, but you see that the binary is there. If we want to run it using this compiler, we need to adapt our program path. Now we are using Linux GCC. I am going to put in the path. And if I want to run, I can just say run and run without debugging. This is going to run and it is going to give me my output here. Now we have 3 different compilers or configurations that we are using to build the project. I am going to hop back on my Windows machine because this setup is building the same project using both the container and the local environment. So I can just go to another window, which is Visual C++, and then open the same template project using the Visual C++ compiler. So I am going to drag and drop that here. And it is going to open up. It is going to give me the option to choose the compiler. Let's go to Command Palette and select Configure Preset. I am going to be using the Visual C++ compiler because that's the only option on Windows. It is going to do its thing. And you can see that now it is using the MSVC compiler, which is Visual C++. And my build files are going to be generated into the CL folder. Now I have a blueprint for the project for the CL compiler. You see now that we have 3 configurations that we are using. We have the CL that we pick up on Windows, and we have the Linux GCC and Linux Clang that we just used on Linux here. This is how your project is going to behave if you build it using different configurations here. Now we are into the CL compiler. If we go into debug, we don't have any binary in there, but we can generate it by hitting F7. So let's go to the main file and see what it was saying. You see that it is the same thing we had there. So we can build by coming to View Command Palette and hitting CMake build or hitting the F7 key On the keyboard, I am going to hit F7. This is going to build the project on Windows. And if I want to run it on Windows, I have to adapt my launch.json file. Now our build files are put into the CL folder, so I am going to put them there. And the binary is named rocket.exe. I am going to adapt that. Now I can go to run and start without debugging. This is going to run the application on Windows, and it is going to give me the output here. Now, the whole purpose of this video was to make you familiar with the files that make up the project, and I really want you to know the way to work with us. Things you see if you change the project, where things are put if you build, how behavior changes if you use a different compilers. I really wanted you to get this experience. Don't worry if you just have access to one environment. Make sure that your configuration is going to give you the build files that are specific to your environment. I just went to Docker and showed you different compilers because I want you to see how everything behaves. And if you are using a single system, this is also going to be useful because you are training to be a cross-platform C++ developer. So you should have an idea about how things work in a different environment from the environment that you are working in now. I hope you have a good idea about the files that make up your project. Now we are going to stop here in this video, and I will see you in the next one. In this video, I am going to show you how to use Git to manage versions or changes in your project. And I have to say that this video is optional. If you want, you can leave this out. But if you do it, it is going to improve the ways you use Git or the way you manage things in your application. One of the things I like to use it for is to have a place to fall back to if something goes wrong. Suppose I open my project in the morning and I start doing things, then I mess up. I don't know what is going on. Sometimes all you want is to come back to the way things were. And Git is going to make this very easy. This is one of the motivations for you to try and use this tool here. If you already know Git and you've never used it in Visual Studio Code, I would still recommend you watch because you will know how to use this tool within the Visual Studio Code environment. So let's do this. I am going to be working in the context of the projects that we already have. So at this point, you should have your Code Live folder containing things that you downloaded and that we used to configure our project here. So we need to set this up as a Git repository. To work with us, I am going to drag the whole Code Live folder because this is the place where we are going to be doing our work. The other folders here are just for reference to show you how the final code is going to look, and you can look at this if you need this, but you will be doing your work in Code Live here. So I am going to open this parent folder and make it visible within Visual Studio Code here. And what I am going to do is to initialize a Git repository. And I have to say that to be able to do this, you need to have a Git installed on your system. You can confirm that you have it by going to the terminal and saying git -- version. This is something we have done before. This is the version I have on my Windows box here. Once you do this, you will come back to the tab that says Git. As you see here, this tab here, this is what I want you to visit. If you hover over it, it is going to say source control. I am going to be using Git with us, but there are other version control systems, but Git is very popular. It is highly probable that you are also going to be using it. So if I come to this tab here, it is going to say the folder currently open doesn't have a Git repository. You can initialize a Git repository, which will enable source control features powered by Git, or you can directly publish this folder to GitHub. What I want to do is to initialize a Git repository here. Another thing I have to say is that you can do all these things on the terminal, but I want you to see how to do them in Visual Studio Code. If you want to learn how to use Git through the terminal, there are many other resources that you can consult and get to do that here. So click Init repository, and if you do that, it is going to tell you to stage these things. And before we even do this, we need to make sure that the files that we build are not taken into account by Git here. So what I want to do is to get out of this. So I am going to hit escape here. And let's see. We don't want to do this. I am just going to leave this out. So I am going to, I'm not going to do this. I am going to cancel out of this. And what I want to do is to add a gitignore file to this project, which is going to make sure that the files that we build Let's come back to the location of our project here. So let's open the project. If we go in Code Live and go to environment setup and go in these template projects here, we don't want these things to be pushed to the Git repository because they are personal. The VS Code folder is going to be wiring the binaries to the locations that I have on my system, and I don't want these build files to be pushed to the Git repository because they are personal. Things you want to push to Git repositories are things that other people would want if they are working on your project here. So we need a way to ignore these files, and we will use a file that we name a git ignore file. I am going to go into the root of my repository where I have a .git folder. This .git folder is the folder that Git is going to be using to manage things here. You can see that it has a dot in front, and this means that it is going to be hidden. But we can see it here because this is how I have my system configured. So what I am going to do, I am going to put in a git ignore file. So let's put that in the project. I am going to paste it in from my system here. You can find it in the Git repository, maybe download it, or even copy it, or create a file named git ignore and paste in the content. You will decide how you want this to work. Now, if I go to my project, I will see that I have a git ignore file, which is going to list things that I want to ignore in this repository here. So you see that everything in the build directory is going to be ignored, and we are going to be ignoring a bunch of things. And another thing I like to do, just to play it safe, is to go in the locations of my projects and also put in this git ignore file here. So in any project that I create, I am going to add in a git ignore file. So I am going to put it in the template project for modules, and I am going to put that in the template project for headers. So let's put that here. And then I am going to come back to Visual Studio Code. Now I am going to push the git ignore file first. So if I come to source control again and look at the changes that we have, I am going to go to my git ignore files that I just added. I am going to do the one in the root. I am also going to do the one in the project template modules. We should have another one for headers. So we have a git ignore down here. I am going to add these things and then commit. So the things I put on the staging area are things that I want to tell Git that I have added to the project here. So I am going to add these three changes first, and I am going to give a message. So add git ignore files. And after I do that, I am going to commit. This is going to be put into Git. And then I am also going to be adding initial files. So you see that now everything else is not accounted for. In the changes that we make, we are only caring for the project files. You see that the build files and the VS Code files are gone, and we have a few files that we are accounting for here. This is the reason you need a git ignore file. After I do that, I am going to stage all the other things I have here. So I am going to stage all of this in one go by going to the top and hitting the plus button here. So hit it. This is going to be adding these things to the staging area. And I can add a commit message. So I am going to put a message add initial project files, both for modules and headers. I think this is descriptive enough. And after I do this, I am going to hit commit. If I do this, you will see that now all the changes that I have locally on my system are going to be accounted for by Git here. And you will see that down below, we have a graph in Visual Studio Code that we can watch to see the changes that we did. Another thing I should tell you is that the changes that we are doing now are living on the main branch. Git has the concept of branches, and a branch is a line on which you are when you are doing your work. So you create your project, you add features, you are on this main line. And later on, when you want to add something, you can create another line from this current line here. And this is going to be another branch from which you will be doing things. This is how Git works. If you want, you can take some moment to learn about Git if these concepts are rusty here. I just want you to see how to use it in Visual Studio Code. Now you can click on any of these lines here, and each of these is going to be a commit message. And another thing is that you see that Git is going to be encoding my information here. So this is the person that pushed this commit on Git. And to be able to use Git, you need to log in. and put your information in Visual Studio Code, and you can do that right here. I think I should have said that before. Okay, now we have this. What we need is to push this to a remote repository, and to be able to do that, you need a GitHub account. So go to your GitHub and make sure that you can log in. If I open this, I am going to see my projects here. So this is my Git, and if I push, it is going to be pushing to my Git repository here. So let's say I want to push this remote. I click on the button here. It is going to tell me how do I want to push this. So I can push it on a private repository, or I can push it on a public repository. If you want this to make private, especially if you are learning, you can make it private, but you can also make it public. That's a decision you have to make. And the first thing you have to specify here is the name for the project. So I can call it CPP Dev because you are learning about C++. And then after you do that, I am going to publish this to a private repository because this is a toy project for me. But if you want, you can make it public. So I am going to hit, and it is going to publish this to my GitHub repository. And every time I make a change, I am going to need to add those changes in GitHub here in the source control tab, and then push. This is going to make it so that my changes are accounted for. And if I happen to mess up, I can just pull those changes and use them right away. I just wanted to give you a simple introduction on how you can use Git within Visual Studio Code. So now if we go in our project, let's open it up. Now I can open the project template for modules. I can open it and I can do things within it. So let's just go inside. And if we go to Git, this is going to say that it has found that the parent folder contains a Git repository, and we can open it and start doing things here. So I am going to open that. It is going to be opening that folder, and any change we do as we are working on this project is also going to be accounted for in our Git repository. Let me show you what could happen. For example, if you change the project, I am going to try and make it add up two numbers. We can do that. We are learning here. So I am going to say int value 1. And I give it a value of 10. And when I do that, you see that Git already knows that I just changed this file here. If I go, you will see that it shows me what we call a def. It is a comparison of the last state of the file and the current state of the file. You see that in the eyes of Git, I have removed all these things and have just added this new line here. In the eyes of Git, I am saying. So let's go back and make this program work, because this is how you do things if you are using this in a practical setting. So let's go down and say value 2, and it is going to have a value of 20 like we like to do. Then I am going to say int result equals value 1 plus value 2, and I am going to print the result here. So print, and I am going to put this in a placeholder and add a \n as we have grown to know and love. Then I am going to be printing the result value. I think this is going to do what we want. I can hit F7 to build this project on my system. I am building it on Windows, so that's what we have. And if I want to run it, I have to make sure that the path in the launch.json file is appropriate to what I am doing here. I am building this on Windows, so I am going to make this use the CL folder. And the binary that is generated is going to be an executable file because we are on Windows here. Now that I have this, I can just hit Control F5 to run the application. If I do that, it is probably not going to give me what I want. It is going to do that. But you can build by hitting F7 and then hit Control F5 to run, and it is going to be adding up these numbers and give you a result. But what I want you to see is that now our repository is accounted for in GitHub, and if we come here, we will see the changes that we just made. You can click here to see the changes. You see I have removed the code that I had before and added this code here, and I can add this to my Git history. So you do this in 2 stages. You have to add things to the staging area, and after that you have to commit. What I want to do is to add this change I did in the main file to the staging area. I do that by hitting the plus button. If you want, you can undo these changes. And if I do this, this is going to bring the file back to the state where it was before. This is something really useful if you mess up and you want to come back to the initial state. So before I do that, I think I am going to go to my file and copy the changes because I may want to bring them back. So I am going to copy this and store this somewhere on my local file system. Okay, I have it stored. Now I can go back to Git and hit this button to discard my changes. If I do that, it is going to give me a warning and I am going to discard, and it is going to take out everything I had done before. You see that my main file is back to the state where it was before. And if I run the program now, I need to build first. So I am going to hit F7 and build the program. And if I run it, it is no longer going to do the sum. It is just going to print some messages here. But I can put my code back because I have it stored as a backup. I just want you to see that if you do a change, you can also push it to the Git repository and make it visible there. So this is the code. Again, if I go to Git, it is going to see that I just changed the file. I can click to see the changes. Again, things that we removed are going to be in red, as you see here. I think this is a convention for GitHub and Git. And the things you added are going to be in something like green. This is what I see in most tools. So let's add this to the staging area. I am going to hit plus. You can see that now it has moved to a staged changes section. And now I can commit this. And I am going to add a commit message. Now that we are in the era of AI and everything, it is actually possible to generate your commit message using AI. I can do this because I am using GitHub Copilot. So I am going to generate and see what this is going to come up with. So update main CPP to perform addition and print the result. I think this is what we did. I am going to commit this. And I can sync the changes. And if I do that, this is going to be pushing this to our remote repository. You can see that the change I just did is also accounted for locally here, but these changes are local. I have not pushed these yet to the remote repository. So if I click, I am also going to see those changes. If I click on another, I am going to see the changes that I did. In this one, I added the initial files. In the first one, I added the git ignore files. You can see these things here. If I want to push this to the remote repository, I can do that. But before I do that, I should go to my Git repository and show you the project that we are working on. So let's go to GitHub and I say cpp dev. Now I have that repository. I just created it. So it is a cpp dev here. If I click on it, you see that now the two commits I did are going to be accounted for. So I did this change 9 minutes ago, and you can see that these are the changes that we did. But what we just did now is not accounted for because I have not pushed it yet. I can click on this button to do that, and it is going to give me a warning that this is going to push commits to the remote repository. And I am going to hit OK because that's what we want. It is going to do that in a second. And if we go back to GitHub and refresh, we should see our new commit here. Now we are updating the main CPP file to perform addition and print the result. If we click on that, we should see our diff. You see that this is what we added. GitHub is going to visualize things differently. So this is what we removed. Okay, and you can see that we have a bunch of minus signs here. And these are things that we added. And all these changes happened in the main CPP file of our project. And again, you can see that our Git repository is not containing the build files that we set up. If we go inside the project template modules, you see that we just have the project files. We don't have the build files. We don't have the .vs code files. Anything that is specifically tied to your local environment should be ignored in your git ignore file. And you can see the syntax that I am using in my git ignore file to ignore all those things here. This is really all I wanted you to see in this video, giving you a good introduction on how to use Git within Visual Studio Code. This is going to make it easy to track your changes. I would encourage you to try and use this if it makes sense for whatever you are doing. But Git is really an essential tool, so use it unless you really have a big reason not to. Let's just build and make sure that the changes are seen. We have built successfully. We can hit Control F5 to run. Now you see that the result is 30. I am going to stop here in this video and I will see you in the next one. In this video, I am going to show you how I use GitHub Copilot to do things or get it to help me do things faster. One thing I have to warn you about is that you shouldn't really use any of these AI agents to take over your thinking or your designing, because that's really what you are doing. You want to use them as helpers, but you don't want them to take over your work. This is something you should really do. But if you use them carefully, if you know the basics and you want to do things faster, you want them to help find bugs and everything, they become really helpful. But don't be taken over by them. I think the best way to say this is to not be lazy and let them take you over, because if you let them do that, you will be irrelevant and you won't have anything to offer. You want to use them to empower you. You don't want them to replace you. That's what I am saying here. So what I am going to do is set up a template project. One thing you can do is tell these AI agents to generate a project for you. I think I can even try to do that to show you what is going on. So I am going to go in a folder on my system. So let's come in my sandbox folder here, where I like to do things on my system. And I am going to create a project and name it CPP dev. This is not going to hurt. So let's say CPP_dev. This is going to be our folder here. And I am going to drag and drop this on top of Visual Studio Code. I have to say that I am using an insider version of Visual Studio Code. I am going to agree here. So it is an insider version, which is going to give me the latest features that they are working on in terms of GitHub Copilot. And another thing I should say is that I am using GitHub Copilot, but there are thousands of these agents and anyone you choose is going to do. I just wanted to show you the basics of how I use these things in the context of a C++ project. If I come to help here in Visual Studio Code, you will see my version. So this is version 1.99.0 Insider. If you want to use regular Visual Studio Code, it is going to be blue at the top here. And another thing I should say is that you don't have to sign up to anything to get access to Visual Studio Code Insiders. You can go to Google or any search engine and type in Visual Studio Code Insider. You will get a link where you can download this. If you decide to go this way, it is really helpful to check for updates regularly to make sure that you have the latest changes. But now that I have a folder open, I can tell my agent to create a C++ project for me. How do I do that? I can come to the top here and open chat. And another thing I should warn you is that these things change a lot. You should really focus on understanding the basics here. Later on, you can come and find that this option has moved to another location. So keep that in mind here. So I am going to open chat. And if I do that, I will have a chat window open to the right. That's what we have here in this current version of Visual Studio Code Insiders. And I can ask my questions. I have the option to choose a model to use to do my coding for me. I can also do a bunch of things. For example, I can ask a question, I can get it to work in edit mode, or I can get it to work in agent mode. Agent mode is a mode in which it is going to be iterating and doing things on its own. You are basically giving up control and telling it to do things for you. In edit mode, it is going to do things step by step, but it is not going to take over completely. That's something you should know. In ask mode, you are basically asking questions about your project. So what I want to do here is to get it to create a project for me. I will go in agent mode because I want it to take over. You can read about this mode here, and I can tell it I want you to create a C++ project for me. Let's increase the size so that you can see what is happening here. CMake latest, or let's just say CMake, and a VC package and a CMake presets to control the build. I want the project to use C++17 and headers, and make it pull the format library for me. Assume that I have a VC package root environment variable pointing to the location where I have it installed. Okay, so, and one thing you should notice is that to be able to use these things, you should have the knowledge. You see that I know that I want to use these tools. I want to use C++17, and I know that VC package is going to look for an environment variable named VC package root. You should know things before you get these agents to do things for you. If you don't know anything about C++, or if you don't even know how to use it properly, you won't get any value out of these things. They are going to be helpful if you know the basics to start with. So let's pass this command in, and you notice that I am using the Claude model because this is good for coding. We have a bunch of options we can choose here. We can use 3.7 or GPT-4o here. I am going to use 3.5 because it is good for my purposes here. And I am going to let this go. Let's see what comes up. We will wait for a while. And you see that it is going to think for a while. It is going to create a C++ project using CMake VC package. C++ 17 is going to be used. It is going to be using the FMT library. And it is going to create a plan. So let's look at this. First, I'll create the basic project structure and essential files are setup, CMake configuration with C++ 17, CMake presets, VC package, a source structure, and the FMT library is going to be brought in here. You can see that now it wants to run a command on my system here. And one thing you should really keep in mind is to let it run when you know what it is really going to do. If you don't know what is happening, that's a risk that you are taking because you should be the one doing these things. It is really like you have a junior developer close to you helping you do things. And when they want to do something, they come to you, they say, I am going to do this. Is this proper? You give them the permission to do it, and then they do it. You should think of it that way. It is going to want to create a source folder, a build folder, and a GitHub folder. I am okay with this, so I am going to tell it to continue. And you see that because I am on Windows, it is going to fail because these commands are specific to Linux. It is going to notice that mkdir is going to fail because we're on Windows. It is going to try again with another syntax. So let's continue. This is going to fail again. And you notice that when I tell it to continue, it is going to be running this command on my terminal here, which is really cool. So it is going to keep failing, and you can see that this is really the benefit of using agent mode. It is going to take control, but when it needs permissions, it is going to ask you if it should do that. It is going to continue, and here it has failed again. At some point, it is going to realize that I am using PowerShell. I think that's the biggest problem we have here. But let's give this a moment. So great. I've created a basic directory structure. Now let me create the necessary configurations files for your project. First, I'll create things. You see that a project structure is being created and a Visual Studio Code is trying to build my project here. I am going to ignore it for now and let the Copilot agent finish what it is doing here. And I will see that this is going to work. So let's give this a moment. I'll create the main source files to implement the functionality, and you can really follow what it is doing here. Okay, so the project is here. Now it is going to want to run a VC package install, and this is not what I want. I want a VC package to run automatically when we configure this project. That's how I like to do things here. I don't want to run it manually like this. So I am going to go down and say, I don't want to run vcpkg manually. It should run automatically when I configure the CMake project. Set up things that way. Okay, and it is going to figure out a way to do that. And here you should see that you don't always have to accept the suggestions that it gives you. You can tailor them to exactly what you need. And another thing you should get out of this is that this is really not going to take over your work. You have to do the thinking. You have to do the strategic planning. You are in control. This agent is not in control. Keep that in mind here. I am going to pass this command and let's see what comes out. Okay, I understand you want VC package dependencies to be installed automatically during configuration. I'll modify the CMake list.txt file to do that. If you want, you can even open that file. If you click on it, it is going to show up here. And I think because of that, it is going to use the CMake toolchain file thing. Okay, so it is doing that. Let's give this a moment and you can see what it has done on the right here. Perfect. Now with these changes in place, VC package will automatically install the dependencies and it has given me my project here. Now that I have the project, I am going to hold off before I keep the changes that it has done here. Now the changes are in your project and you can try to build the project and see that it works well. But why not let this agent build and run the project to make sure that everything is okay? I am going to go down here and tell it that I want you to build and run the project to make sure that all is well. Okay, let's do that. And I am going to give it the command, and it is going to try to run the CMake configuration command on my machine here. You see, it is trying to use the preset x64 debug because it should be in the preset file here. I haven't even looked at it, but let's trust it. So let's see what happens here. If it has a problem, it is going to fix it. You can see that this is really not completely automatic. It is not going to do the thinking for you. If you have problems, figure out what is going on, and this is going to help you out a bit. So you can see it is trying to pass the Visual Studio generator explicitly. So let's give it a chance. And it is going to see, and it is going to have problems here. Let's continue. It is going to try to clean up. And it can iterate until it figures out the proper way to build this project here. Now it is trying to use the PowerShell command to remove the build folder and everything. I am going to let it do that. And you see that the build folder is gone on the left here. This is something you can do. Okay, it has cleaned up the build directory. Now it is going to figure out the command to configure using CMake. Let's see what comes out. It just changed the preset file as well. Now it is going to be using that preset. Let's give it a chance. And now you see that this seems to have run, and the build files have been written to this folder here. It is going to report that. So great, the CMake configuration was successful, and a VC package automatically installed the FMT library as expected. I want to build the project using this build preset here. I am going to give it the permission to continue. Now the build completed successfully. Now let's run the executable to make sure everything works. It is going to try and run the executable, and you see that we have hello world printed out here. This is really cool. We have generated a project and we didn't do much of it. It took over and did the things that we told it to do. Now that I have a project that I know runs, I am going to keep this. So now it is done, and I can try to work with this project and do things that I want to do. I hope you see how this can help in making things easy in your C++ project. So let's look at the project. We have a greeting CPP file. We should have an include folder having the declarations for the function that we have here. We can go in greeting CPP and see what is going on. You see it is using the FMT library, and the main CPP file is going to be including the greeting header and using that to do things that we want to do here. You can really do all kinds of crazy things. Now that I have this, I can pass this through the compiler. So we can say CMake select configure preset because we want to be using presets here. We don't want to be using kits. So I can go to view command palette and say CMake select configure preset. So let's say CMake. So what is the CMake preset file doing here? Oh, this is going to be building using kits, but I want to use presets here. Let's see what we have in our presets file. So we should have Windows base, we have x64 debug. I am going to close this and open this again because sometimes Visual Studio Code needs to rethink what it is doing here. You see now that it is giving me the option to choose a configure preset. So I can go to view and say command palette and say CMake select configure preset. Now I am going to have this option here, and I want to use the debug version of this. So let's give this a moment. It wants to install Docker. I don't want to do this now. Okay, now we have configured the project. If I hit F7, this is going to build the project as we have seen in our configuration, and I can run the application by hitting the run button here. Or I can set up a launch JSON file. You see that I can create it as we have done before, but that's not something I am going to concern myself with now. I just want you to see that you can generate a project. Now that we have a project we like, it is good to really use Git to keep track of things happening in your project. So I am going to go to the Git tab here, and tell it that I want to initialize a Git repository here. So let's initialize it, and I am going to add everything we have in the project. But before I do this, I am going to, no, I don't want to delete these. But what I want to do is to add a git ignore file to this project here to make sure that everything is proper with Git. So I can tell my agent to generate a git ignore file. So let's do that. Generate a git ignore file that ignores the build folder and any non-necessary local files. You can do that. And I am going to give it the context of the project, and hitting this context button is going to give you different ways to give context to your project. I want it to look at my entire code base here, and let's give it a chance to run. It is going to take a moment, probably looking at everything in my project here. And what I really want is to ignore the build file. I could have done it myself, but why worry about that if I can get somebody to do that for me in a minute or two? So let's wait and see what comes out. You have to know that sometimes these agents can really mess up and give you things that don't make sense. So make sure you really know what you are doing and only accept things that you think make sense. In a minute, I am going to show you ways you can see things that have been added or removed. You see that this has been added. I can open this file and look at what is inside. I think it is good enough. I just want to ignore the build folder. You see, it is ignored, and it is going to ignore common things that C++ projects ignore in projects. I am going to keep this, and I am going to add it to my project first. So let's go. And now you see that a lot of things are gone because we want to keep track of things that are really specific to this project here. Now I like this, so I am going to add this to the staging area, and I am going to commit this. Locally, you don't have to push this even to GitHub or any remote repositories. So I am going to say initial project setup, and I can hit commit here. And it is in my Git history now. If I go to the source control tab, you see initial project setup, and you can look at the changes that were done in this setup here. So we added a git ignore file. We have a CMake list file, we have a CMake presets file, we have a greeting header, a greeting CPP file, a main CPP file, and a vcpkg.json file here. These are the changes that we did in this commit that we did in Git here. I can close everything, so let's close all. Okay, now that we have this, this is a basic C++ project. You can even store this somewhere and make it a basic C++ project template from which you will be doing other things here. You can learn a few things. You see, we have a source folder which contains our source files. We have an include folder which is going to be containing our implementation files. And this project is using C++ 17, as you see here. You have to find the third-party dependencies and link against them. You see, we are finding package, and then we are target linking the FMT library. And our executable is going to be named the same thing as the project name. And the project name is something you pass here. So this is our project name. And we can do all kinds of crazy things. We can build the project again. We can hit F7 to build using CMake. This is going to generate the executable, and you can run it. If you run it, you will see the output here. It is hello world. Everything seems to work. Now, on top of this, we wanted to do something more. And I wanted to push the limits and see what we can do with this agent that comes from GitHub Copilot here. So let's try and use FTX UI. If you don't know what FTX UI is, you can search here in your search engine. It is a library, a third-party library that you can bring into your own applications and get to build graphical user interfaces that run in the terminal. So it is going to be able to run in a terminal like this. If you run your application, you will see a UI and you will be able to click around and do all kinds of crazy things. You can read more on this library here, but we will try to build a to-do list application. So the idea is that we have some user interface And we have a field in which to put our text. And the text is going to be a to-do list item. We will have some add button. If you click on the add button, the item is going to be added, and you have the ability to toggle items and do all kinds of crazy things. It is basically a to-do list. Another thing I think would make this interesting is to also persist our data, so that if we close the application and start it again, the data that we had is going to be persisted. There are different ways to do this. You may store the information in a file, you may store the information in the cloud, but what I want to do here is to bring in an SQLite third-party dependency and use that to persist our data. So our data is going to be persisted in a database. We want to make that work. But we are not going to be combining those two things here. So I am going to first make this become an FTX UI based graphical user interface. And after that, I will bring in SQLite and try to see what comes up here. That's the plan we have. So we need to describe what we want to the agent here. Make sure you have agent selected and you are using a model that you have access to. You can use any of these models really, but I prefer to use Claude Sonnet because it gives me the best results from what I have done with this thing here. So I am going to bring in my context. My context is going to be the code base. So it is going to take all the files in my project here and use them to decide what it is going to do for me. And I will tell it I want to change this application to be a to-do list. Okay, this is my request here. I want to change the application to be a to-do list application. The UI is going to be using FTX UI, so I should fix this typo here. You will bring in the third-party dependency and link against it, and change the main file to set up a to-do list interface. We will have a field on top where we type our data, a button to add a new item, a button to toggle, and a button to delete an item. Completed tasks should be in green, and those not completed should be in red. And I will also tell it to build the application and make sure that everything it gave me compiles. Okay, so this is my prompt. And sometimes I want to save these prompts because sometimes things don't work and I may need to reuse them. So I will bring a text file like this and paste it in and just put it away in case I need it. Then I am going to pass this through this thing here. I will give it a moment, so it is going to go to work and try to give me what I just described here. Let's wait and see what comes up. You see it is doing some work here. I'll help you transform this into a to-do list application using FTX UI. This is where you make sure that it understood your requirements. And if it didn't understand them, you can come down here and stop it. So you can come down here and stop it and give the instructions again. These are things you can do. But here you see that it is doing the work. It is going to first update the vcpkg file to add FTX UI. You see it has already done that. And it's going to create the main application with a to-do list interface. Let me start by searching. It is going to do what it needs to do. And it is going to update the CMake list.txt file. So this is basically going to find the FTX UI package and link against it. And again, I am going to stress that you really need to know your language before you use these things here. If things go wrong, you want to know which directions to tune things in. So you should be knowledgeable in C++ before you do these kinds of things here. Or in general, you should be knowledgeable in the language or the technology that you are using with these AI tools here. Otherwise, you are just going to be going blind and things are going to go wrong. So it's done its work. Now it wants to configure the project. It is going to be selecting the preset. So I think this is okay. I am going to tell it to go. And let's see what comes out. It seems that the configuration was good. Now it is going to ask me if it can build the project. Let's give it a chance to do that. You see, it wants to build the project. This is the command to build using our build configuration here. So let's continue and we will see if all is well. It seems that the build was good. So it is going to tell me that all is good and I can try this application here. I am going to decrease the size here because this is ridiculous. So it says an input field at the top for entering new tasks. An add button was added. Each to-do list items shows a checkbox to toggle completion. This is really good. The task text and a delete button to remove the item. You can now run the application, but I don't see the option to toggle. Oh, to toggle completion, this is the checkbox that we use here. So run the application. And if we run it, it is going to complain. So I am going to abort. Let's see if it can figure out that something went wrong here. I just closed that terminal. And we will see what comes out here. If you want, you can look at what it did in the main file. So let's go to source and open our main file. This is what it has done for us here. It has noticed that we had an exception, so it's going to try and redo the thing. And this is what I don't like about this tool. It is going to completely change things here. So let me fix the issue. And fixing the issue is basically rewriting the entire thing, which I don't like that much. But let's give it a chance and see what comes out. Okay, the build seems to be good. So let's see what it comes up with. It should give me the prompt to let it run the application. I will let it run. And now we have a field in which we can type. So let's say walk the dog or wash the clothes. And if I hit add, the thing is going to be added. This seems promising. So let's say fetch water. Okay, and I am going to add. You see, I can fetch water and I can toggle completion. You see, this seems to be really good. And I can delete a task. This is really good. I think this is what we asked for. And it is really good. So let's close the application and see what it says. It should say that everything is all right now. And another thing I should stress is that you should try to do things in steps. And try to not do everything in one bulk prompt. Because then chances are going to be that a lot is going to be wrong. So when you give it a vague prompt, it is going to have the ability to go in thousands of directions, and you don't really want that. So now we have a UI that we like. After we have it, we will, why is it still running? Let's show the terminal window. So let's go to view terminal, and we can close this. I am going to stop it because I already have something I like, and I am going to hit F7 to build on my own to see if everything is good. I can even open a terminal window, so let's go there. So we can bring up the terminal window here in Visual Studio Code and say build X and say debug. I think this is where the thing is. And the application is named cpp project.exe. So I can type a task, fetch water. Okay, and add a task. I can say that this has been completed. Okay, I like it. I can add another one. So wash dishes. Okay, let's type this here and we add. And I can say that this is also completed. I can delete a task. I think I like this. This is a good design. Now that I like it, I am going to say that I want to keep it. So let's keep this. So keep. And after we keep, the changes are going to be basically stored in our source code here. And I can try to build again to make sure that everything is all right. Now we have a fatal error and it cannot open the executable because it is already running somewhere. So where is it running? Let's bring up our terminal. Yeah, it is still running here. So I am going to hit Control-C and close it and then build again. Make sure that everything is all right. And now we are sure that we like these changes here. I can even say that we are done. So what I want to do is to come back to our Git interface and add these changes to Git and make this our last good working state. I can't stress how important this is. Another thing you can do is what changes it did. So for example, from what we had before, we just added FTX UI. So this was removed and this was added in the vcpkg JSON file. So now we have two dependencies. We had one, but now we have two. Let's go in the CMake list.txt file and see what it did. We can even close all this here. So in the CMake list.txt file, this was changed. So find required packages. It is going to try and find FMT and FTX UI, and it is going to link against this library here. This is basically what it did. We found FTX UI, and now we are linking against that, as you see here. And we are going to be linking that into our executable that we are creating through this command here. This is the set of changes we did in the CMake file. If we go in main, this is where most of the work happened. And you see that things are set up in a way that gets things to work here. For example, you can see we added FTX UI, we brought in the namespace, we created a to-do item as a class, and in main, we set up everything. This is really not a complex application, but it is good enough to show what is going on here. You can see how they are modeling the delete button, which is really cool. It is just this icon that we have here, and it is going to show up. And this is really good. Now that we have this, we can add this and make this our last working state so that if things go wrong, we can come back to this state here. So I am going to stage these changes. And another thing you can do using these agents here in Visual Studio Code is to let it even generate your commit message, which is really cool. So we can click on this button here at the top, and it is going to generate the commit message, which I like to do a lot. So let's see what it does. And it is going to say add FTX UI dependency and implement basic to-do list functionality. This is what we did. So I am going to commit this. And now you can see the new change that we did here. And this is really cool. Now that we have this, we can do the last thing we wanted to do. Now, the next thing we want to do is to persist the data using SQLite. So I am going to describe what I want again. So let's come down here and add my code base as context. And I am going to say, add the feature to persist data using SQLite. When the app is started, the data should be automatically loaded. And when the data changes, the changes should be written to the database. I think this is descriptive enough. So I am going to pass this here. Make sure that you have context. So we have the code base, the entire code that we have in our project here. And I am going to pass this command here. So I am using Claude Sonnet, and I will see what comes out here. Let's give it a chance to do what it needs to do. It is probably going to modify the vcpkg file. It is going to modify the CMake file here. And it is going to change things in the main file. And probably add another file for database handling. Let's see what it's going to do. So I'll help you add SQLite persistent to your C++ application. And what we need to do is add SQLite as a dependency, create a database handler class, and add the functionality to load and save data automatically. This seems like what we need to do. So it is going to do what it needs to do here. It is going to create a to-do database header file. We will also set up a CPP file, and we will bring everything together in the main file. I think that's what it is going to do. And you can see that as it does these changes, Git is going to be tracking what changed. And anytime things go wrong, we can come back here and discard all these changes here. We have this safety in using Git. The last state we had, things working with a good user interface, is just stored here. This is really cool. So let's give this a moment to do what it needs to do. I am going to decrease the size so that we can look at this better. And give this a moment. Okay, you see it has done some work here. I was busy with something else, but now I am back. So it even found that it had a few errors, and it fixed them in by adding the missing include files and everything. So it is updating the to-do database CPP file. Let's let it do what it needs to do. Again, we have the safety in that if things go wrong, we can come back to the last working state here. This is really cool. So let's let it do what it needs to do. But we can see what it's doing here. For example, we can look at the CMake list.txt file and notice that, or we can even start by the vcpkg file. So did you not modify the vcpkg file? You should have modified it. You should have modified it. So let's look and see what it does. It did not. You need to do that. It's going to run into errors, but let's let it finish. That's why it is running into these errors. And I am going to stop it and tell it that it needs to add the SQLite dependency to the vcpkg file. Okay, and again, this stresses that you need to understand what is going on to get these AI agents to do what you want to do. If you don't understand what is going on, for example, you can't notice that it has missed this important detail here. Make sure you know what is happening. You need to already be a developer to take advantage of these tools here. I see some people say, oh, I am not a developer. I don't need to learn programming or anything. I can tell these agents to do work for me. If things go wrong, then you won't know what is going wrong, and that's a bad thing here. Let's see what is happening here. So it has added SQLite. Let's continue and see if this is going to work. We need to try it. And if things go wrong, we will try to fix them. You see that it has already faced a problem. So let's see what it does about this. I see there is an error in finding SQLite. The issue is in the CMake package name. So it is going to try and change the CMake list file, and it wants to configure again. So, it seems that we have configured the project. You can see that the build files have been generated. Now it is going to say, great, configuration was good. Now let's create the necessary files for SQLite persistence. It is going to go in and create these classes to make everything work. Let's give it a moment to see if all goes well here. Okay, it has done all it needs to do. I see that it has created a lot of files in here. So headers and CPP files, let's try to configure. We will give it the chance to do that, and we have a problem. So with FTX UI, it's going to have a bunch of problems with lambdas with FTX UI here. Let's see if it can fix them. We will give it that chance here. It has done its work. Now we want to configure and see if all is well. And it has configured. We still have problems, but we will give it a chance to redeem itself. And you can see that everything is running in a command or a terminal named Copilot here, because this was created to run commands from Copilot. So we still have the problem with FTX UI here. And this is what I don't like. If it starts modifying a lot about FTX UI, we will lose the features that we had before. That's my experience here. So we have to be careful in accepting these changes here. But again, we have a safety line here. If we don't like what is going on, we can revert to what we had before. I am going to let it configure. Again, we have these problems, and it is going to keep looping around. So it notices that we still have issues with FTX UI. I am going to give it this chance. If it keeps failing, I am going to stop it and tell it to try other approaches, but still give us the features that we had in our user interface here. So let's continue, and here we still have problems. So I am going to stop it and tell it, I see that you are struggling with FTX UI lambdas, and I need you to fix this once for all and keep the UI. Okay, we are going to try and be mean here. We don't have all the time in the world, so I'm going to tell it to try again. Sometimes this is going to nudge it in the right direction and make it give you things. Let me fix FTX UI lambda issues quickly. You see that it has noticed that we're not happy with the performance that it had. And maybe this is going to get it to give us what we want here. It's going to be a little more careful, if I can say it like that. I don't know how it finds these compiler errors without running the things through the compiler. You see, it says, I see there are compilation errors mainly due to missing include files. How does it find that? Maybe it is using some static analysis to figure out things that could go wrong. But this is really cool. It can find out problems even before we run the code through the compiler. And again, this may take your time, because you do a lot of iteration on what you want to do. And sometimes I do this for across a bunch of days. If I have some time to kill and I have an idea that I want to play with, I can do this. Once I have something I like, I will put it in my Git history. Then tomorrow when I have time, I will try to iterate again. This may be something you do over a long period of time, unless this is the main project you are working on from morning to evening. Then things are going to be faster. But I usually do these in my spare time. Okay, so what is it doing? I see that it is just searching and doing all kinds of crazy things here. Maybe that's because I was mean to it here, saying it that we don't have all the time in the world. So let's see what this does. And as it changes file, you will see changes here. Sometimes if we change the vcpkg file or the CMake file, Visual Studio Code is going to automatically reconfigure the project, and you will see things happening here. So let's see what is going on. It wants to clear everything I have and rebuild again. This is what this command here is going to do. So let's see what happens. PowerShell did not like this command. So it is going to try and change into the directory, and then it is going to run the command. This is what it is doing here. I think I should increase the size here and close the list of files that I have so that we have these two views here. So it's going to try and configure the project, and the configuration is going to fail again. So FTX UI component base has problems. Let's see what it does. Again, if you want to use FTX UI in something serious in your projects, you should really invest the time in learning it so that you can go down and try to fix these problems. You should be able to fix these things on your own if you invest the time in doing that. That's the best way to go about using these agents here. But I like to use this for prototyping or trying out ideas because it saves me a lot of time. This is usually something I would offload to my junior or anything, but I have the ability to do this on my own without having to need to offload this to someone else. So it can see that I have been doing this for some time. I am going to give it a chance to try and do this again. So let's see what's happening. We still have issues with FTX UI. So what are you doing? You can see that there are errors related to this, but now you have stopped. Yeah, it knows that it's been doing this for a while. It was thinking it's going to try and do something else, I guess. And again, it is going to modify the entire file, which is crazy. So let's see what comes up. Getting FTX UI to work was a bit easy, but now we are trying to combine this with the SQLite database to persist data. And some things need to change in our user interface. That's why we are changing a lot of things in the main file here. So let's verify that there are any remaining errors after fixing the button component. So what happens, it changes one thing, and that one thing is going to trigger thousands of other errors. This is the process you have to go through if you need to use these things here. Okay, it says it may need to delete the build folder and reconfigure everything. So I am going to tell it to do that. Again, this command is not going to work because this is Linux specific. It needs to change into the directory and do things using PowerShell because I'm on Windows here. Okay, so it's going to cd into there, and it's going to come up with a command to delete the build folder. I think that's what it is going to do. Okay, let's reconfigure, and we have errors here. This is a PowerShell error. I think this is going to be sorted out. The problems we don't want are those coming from our code here. It seems now that the build is good. Okay, it's going to say that the build was good. Now we get to try what it gave us to make sure that we can persist the data. Okay, so it seems that we have the thing here. Now we can go into our project, and let's go into our code and just open any file and hit F7 here to try to build the project on our own. Now we have the binary. We can open the terminal and go to the location of our project. So I am going to clear and say build and say X and say debug and say CPP. That's the binary. If we run it, it is going to give us our user interface. You can even see that we have the DB file in our project here. So if we type, we are going to have the data. Let's say wash car. If we add, the task is going to be there. It's not going to be completed. And let's close the application and do Control-C to kill the application. If we run it again, we should see the data loaded, and you see that wash car is here. It seems that it is working. I am going to toggle it and make it completed and close the application. Okay, and if I run the application again, it should show it as completed. It seems that we have everything we wanted. This is really cool. We did this using this AI agent, and we didn't have to really do a lot of thinking. All we needed was to know what we want And one piece of advice I would give you is that you should try to break things into different steps. For example, if you told it, I want SQLite and I want FTX UI in one go, then you lose the chance to decide what you want the user interface to look like. It is really important to break things into priorities, decide what you want to do first, make sure you have that. After you have that, you push that into GitHub or Git, and then on top of that, you start iterating, getting the things that you want. I think that's the best way to get good results out of these agents here. This is all we had to do. So now that we have this, we are going to add this to our Git repository. You see, we even have a database file that we want to ignore because we don't want to push this to GitHub. So I am going to say that I am done, but I will tell it to add the database file to the git ignore file here. We don't want that in our project. So I am going to give it the context and of the project and say add the db file to git ignore, and I will give it a second. So it's going to change the git ignore file and add that. And you can see that it has added database files. So what does it, since you already have some changes in your working directory, you want to make sure Git starts tracking this change to git ignore. Let me run a git command to show you the current status. So let's do that. This is not harmful. So it is going to do that. From the git status, I can see that the git ignore has been modified. Let me commit this change to make sure that the DB files are ignored going forward. So it is going to do that for me. I can even do that myself, but why not let it do that for me? And this is going to fail. And I see the command failed because the AND operator is not accepted. So let's say git add git ignore, and it is going to commit this. Okay, so if it commits this, you will see that it is going to go. And we have this message here. It's doing a lot for us, and this is really cool. Now we can see things without the DB file that we had before. I am going to keep these changes here, and I am going to add everything to my staging area. So let's do that. I can go to the top here and hit the plus button. Things have been added to the staging area, and I can generate a commit message by clicking the button there and implement to do database functionality with SQLite integration. This is what we did. I am going to commit this, and if I wanted, I would publish this into a remote repository, but I don't need to do that. The goal was to show you that you can build something really cool using these AI agents in Visual Studio Code using Claude Sonnet as we did here. And we have a slightly intermediate project that we can use to do all kinds of crazy things. For example, now if we need another dependency, we can add it here. We can do all kinds of crazy things. This is all I had to share in this video. I hope you found it useful. I am stopping here, and I will see you next time.